Web server stacks come in many different shapes and sizes. You can run your own web server on a physical machine or on a virtual machine that you completely control on premises, or you might have a virtual machine in the cloud where you manually install a web server stack. And actually hosting web servers in a third-party computing environment has been around for decades. These days, it's commonly done in the cloud as a managed service, where a managed service means you don't have to manually set up the virtual machine and the web server stack. You just deploy a web app in the cloud, and the underlying work to set up that infrastructure is done for you. And that's what I'm going to do here in the Microsoft Azure cloud. So I've already signed into the Microsoft Azure portal, the web-based GUI tool. So at the top, near the left, I'll click Create a Resource. And under Popular Azure Services, under that heading, I'm just going to scroll down, and under Web App, I'll choose Create. And I'll have to answer a number of questions here. I'll have to fill in a lot of details to build this web app. I have to tie this web app to an Azure subscription. A subscription is a billing boundary. And you could have more than one subscription, but I only have one, so that's an easy selection. Then I can deploy this into an existing resource group or create a new resource group. In the Microsoft Azure cloud, a resource group is used to organize related cloud-based resources, like related web apps and storage accounts and virtual machines and load balancers, that type of thing. I've already got one here called RG1, so I'm going to select that. Then I have to specify the web application name. I'm going to call this web app YHZ1, and what it will do is add the .azurewebsites.net DNS suffix at the end. You need to use a unique name here. If I were to just call this, let's say, web app, it says that app name is not available. Someone else is already using it. So you need to specify a unique name. For the web app, we can select that it will be a code-based web app where we can choose the runtime stack. So what language do we want to use to develop this? Is it going to be a .NET variant? Is it going to be Java? Will it be Node.js, PHP, Python, Ruby? Let's say it's going to be Python, and I'll choose Python 3.8. Now, because of that selection, the only operating system choice is Linux. Windows is unavailable. But if I were to choose ASP.NET, one of those variations, and Windows is what gets selected. Now, notice, other than code, I could also specify that I want to publish my application, my web app, as a Docker container. And then we get the selection of either Windows or Linux to host that Docker container, since Docker is supported on those platforms. Or I could choose a static web app. A static web app is normally used when you want to link it to some kind of code repository like in GitHub, so that when there are commits to GitHub, those are pushed into the web app in Azure and kept up to date that way. In this case, I'll just use code and I'll leave it on ASP.NET. So for the region here, I'm going to choose where I want this deployed. Let's say Canada East. And I have to either create or select an app service plan. This is a separate cloud resource that will be created, and an app service plan hosts one or more web applications. And this is where you specify the horsepower. In this case, it's using a unit of measurement called ACUs, Azure Compute Units, which is a measure of the CPU power. More means more CPU compute power, and then the amount of memory. We could click Change Size if we needed to accommodate more horsepower to support our web app or web apps. I'll click Next Deployment. I'm not going to link this to GitHub, so I'll just click Next Networking. The Enable Network Injection option is set off. What this means is that my web app does not have the ability to reach into other virtual networks in the cloud to contact endpoints, maybe for a database or a storage account, let's say. But it is open to the internet. I'm going to leave that off. Could change it at any point in time. And if it's a public-facing web app that I want to host, then I do want it available to the internet. Next, for monitoring, depending on my selection on the Basics tab, and if I click on that and go back, so depending on the runtime stack selection and whatnot, will determine whether I have the monitoring option for enabling application insights available. Currently, it's set to no. So if I were to go back to Basics, let's say, and maybe choose .NET 6 as my runtime stack for my web server, if I go back to monitoring, now enabling application insights is available. What this does is it lets me get detailed things like performance metrics. It monitors HTTP types of errors to the web application, that sort of thing. However, if I want to use a different runtime stack, let's say a Node.js variant, and I go back to monitoring, then again, it's turned off and I can't turn it on. But there is a note that says, as a software developer, I can use the Application Insights SDK. The SDK is a software developer kit in order to build monitoring into my app. I'll click Next for tags. I could add metadata information like tying this, let's say, to a project. Let's say I want this to be tied to project A. So I can do that. Notice it says 2 resources selected because we have the web application and the app service plan that hosts it. I'll click Next for review and create. I'm given an estimated monthly price up at the top to host this in the cloud if it's running all of the time. So I'm going to go ahead and click Create. So we are now in the midst of deploying our web application in the Azure cloud. And it won't take long before the deployment is complete. So we didn't have to deal with the virtual machine or installing web server software. That's taken care of for us because this is a managed service. Now, at the same time, it means we have less configuration flexibility than if we did do that ourselves, for example, even on premises. However, at this point, I'm going to click the Go to Resource button, which takes me into the properties of my newly deployed web application, which is called an app service in Azure. Over on the right, I have the URL for the web app. Notice by default it uses HTTPS, which is good from a security standpoint to secure the network connection. I could either click that link or I could click the Browse button to open up a new web browser window to open up the page for that web app. And here we have the default Microsoft Azure web app page. Of course, if I were to click back here in the portal Quick Start under deployment on the left, I could click Node.js, that's the code base that we selected, where it takes me into the documentation on how to create my Node.js web app in Azure. And I might even use a tool like Microsoft Visual Studio to write all my code for that web app and push it into that web app in Azure. The other thing I'll just point out here is if I were to go home here back in the portal and choose Create a Resource and search for Application Gateway. An Application Gateway is a way that you can load balance traffic to your web application. So for a busy web app, it can increase availability because you'll have multiple back-end virtual machines serving an app. It can also improve performance. And not only that, but the application gateway has a component, depending on how you configure it, to enable a web application firewall, a WAF. That's part of the application gateway. And of course, web application firewalls, as we'll get into a little bit more later, are important in protecting your web application from common web application exploits. In this demonstration, I will be installing a Windows web server. Now, there are many different web server stacks that you can run on the Windows platform. In this particular case, I'm going to be using the built-in Internet Information Services, or IIS. Now, it's built in, but that doesn't mean it's installed automatically. So here in Windows Server 2019, the first thing I will do is go out into a PowerShell prompt, because that's one way that we can check on as well as install components. If I run get-windows feature, which is a PowerShell commandlet, and use an asterisk wildcard symbol along with the word web, followed by another asterisk wildcard symbol. So basically, show me any Windows components, Windows features that have the word web in their name. And there are quite a few of them showing up here. And we're viewing here the name column, which has the word web in all of these components. The display name shown on the left in the output here includes things like what we're looking for, the web server IIS, which is called web-server, along with all of its components. So there's not an X within the square brackets, which indicates that that component is not installed. We could use the install-Windows feature or add-Windows feature commandlets to install the web server component and its subordinates. We can also use the GUI, which I'm going to do here. I'm going to go into my Start menu and fire up the Server Manager. Once it fires up, I will click the Add Roles and Features link, and I'll click Next twice. Then I'll select the appropriate server. Well, it's the server that I'm doing this on, so that's where I want to install something, so I'll click Next. Then I have a list of roles. If I take a look down towards the bottom, I've got Web Server IIS. I'm going to turn that role on by clicking on it, which checks it on, and it pops up and asks if I want to add additional features, such as management tools. I do, so I'll just click Add Features, and now Web Server IIS has a check mark in it. I'll click Next to get to the Features screen. And if there were other components I wanted, like BitLocker drive encryption for protection of data at rest, although there are many other solutions to do that besides BitLocker, but this is built into Windows, I could just turn it on here. If I wanted to enable network load balancing for application availability and better performance, I could also do that. But really, all I'm doing here is installing the web server. So I'll click Next, and I'll continue on through to where I get the Role Services screen. This gives me all of the individual granular subcomponents for the web server, such as whether I want to enable HTTP redirection. HTTP redirection is one of those features that you only want to enable in your web app if you're going to be checking that secure cookies are in use. Otherwise, you shouldn't be using HTTP redirection. We could enable custom logging for our web server. We could enable Windows authentication to allow sign-in to the web server using Windows credentials. We could enable the FTP server component. FTP is natively insecure. In other words, it transmits everything, including signing credentials in Cleartext over the network. So unless you're using another service that supports secure FTP, this is one you should probably stay away from. Even if you're using a VPN to tunnel into your web server and connect to it, everything is sent in Cleartext. So unless that's not an issue, stay away from FTP where possible. Okay, I'm going to click Next, and I'll click Install. Okay, once the installation has succeeded on my host, I'll click Close. And what I'll notice here is if I go to the Tools menu here in the Server Manager, I will now have the Internet Information Services or IIS Manager GUI tool available. Not only that, I can also spawn that from the Start menu. If I go into my Start menu and go under Windows Administrative Tools and then scroll down to the I's, there's Internet Information Services, IIS. That's the web server. So if I click on it, it takes me into that configuration tool where I've got my server name shown on the left. And if I drill down, I can go under Sites, and I've got my default website, which I can then select and have some options over on the right, such as the default document that I want to enable. So when someone browses to my website, which document will pop up? Well, we've got a number of them shown here, like default HTML. If we've got a web page with that name, that'll be our home page. Default ASP, index HTML, index HTML. So you can change these as required. And you can also set the documents in order of priority. You can select one of these and move it up or down the list to determine which should be read first if we have all of these types of document names in the web server root. Which, by the way, if we go into the file system on this host, I'm going to go down to drive C, then I'll go into the inetpub directory where I have a www root folder in which I have my root for my web server. This is where all of the files would go, at least by default. So back in my IIS management tool, if I go back to my default website by clicking on it in the left-hand navigator, we can also configure authentication for this web server. So notice that anonymous authentication is enabled by default, which means you don't have to sign in at least to get to the home page. Now, having that selected over on the far right, I could click Edit to determine the default identity used when anonymous users connect, but I'll cancel out of that and I'll select the default website yet again. We could determine whether or not we want to enable directory browsing. So if I double click on that, I could click Enable then over on the far right. You want to be very careful with this when it comes to web app security. If you're not careful how this is enabled and how strong authentication is if you enable it for your web app, it could lead to sensitive file disclosure through the directory browsing feature. So just be careful if you're going to be doing that. You can control the error page details that will pop up, depending on the HTTP status code, like a 403 error, for example. A 403 is a forbidden code where something has been requested through the web server, but the web server refuses to grant access to it. So you can customize the files used for that. I'll click on Default Website yet again. You could click on SSL settings here to determine if you want to require, for instance, client certificates. It's one thing to use SSL on the web server side. Technically, SSL is an outdated and deprecated security protocol. Really, it should be TLS, shouldn't it? Transport Layer Security. But a lot of the tools still refer to SSL. Well, by enabling SSL server side, you need a PKI certificate, and it protects the network connection. But what we're talking about here is setting up an option where clients can also have PKI certificates installed on client devices. And if we choose require, our web server would have to trust the issuer of those certificates before the client is even allowed to try to authenticate to our web application. So it's just an additional layer of security for highly secure websites. So if I just go into a command prompt on this host and do an IP config, I have two network adapters. I'm just going to pick the IP address for the first one, 192.168.4.167. And when I enter that into a web browser on this host, it pops up with the default Internet Information Services webpage. So we know that the website and the web server are functional. If I right-click on the default website in the left-hand navigator back here in the IIS Manager tool, I can choose Edit Bindings and notice that we have both an HTTP binding on TCP port 80 as well as one on 443 HTTPS. We could click Edit to see the details. It looks like there's a default SSL certificate already assigned to the server. And if we click View, we get a message saying the certificate can't be verified up to a trusted certification authority. So we can see who it was issued by. In other words, this is a private certificate issued by a private certification authority. This means that when client devices connect to this website over HTTPS, their devices by default will not trust the issuer of the certificate unless we install it on all of those devices. So if you're going to have a public-facing web application, you need to make sure that you have a certificate issued by a publicly trusted certification authority. So at this point, we've now set up a basic default Microsoft Internet Information Services, or IIS, web server stack. In this demonstration, I'm going to be installing an Apache 2 web server on the Ubuntu Linux platform. The Apache web server is one of the products available from the Apache Foundation. You can run the Apache web server on a number of different platforms, including on Windows. Here we're going to be doing it on Linux. So to get started, the first thing I need to do on my Linux machine is make sure I install the appropriate package. To do that, I'm going to run sudo, to run this as an elevated privileged command, apt-get install, and I'm going to install the Apache 2 package. What's going to happen is it's going to reach out to any package repositories configured for this specific machine and pull that down over the internet. And after a moment, it will have installed the Apache web server. Now, naturally, from a security standpoint, web application security begins at the foundation. It means making sure the operating system, in this case Ubuntu Linux, is kept up to date and configured securely, including installed packages being updated, like the Apache 2 web server. So what we can do is we can always run sudo apt-get update to make sure that our list of package repositories is up to date. And you don't have to point to the internet. Your organization, if it uses Linux extensively, might have local private repositories with carefully curated software packages that are made available to install on Linux hosts internally. We can also run the sudo apt-get upgrade command to upgrade any existing software components installed on this host. I'm just going to go ahead and choose yes to make sure that we have the latest updates applied. So we know that this is an important part of web application security at this level, the operating system and web server stack level. So the next thing to do then is to make sure that the Apache web server daemon or background service is up and running. I can do that with sudo service, it's called Apache 2, and then I'll pass it the status parameters. So we get a returned listing that shows us that the Apache 2 web server daemon is active and up and running. So the Apache HTTP server then has been started. Okay, so I'm going to press Q for quit, and I'm going to run IP address, which will show me my local loopback IP, along with any other IPv6 and IPv4 addresses for this host. For example, I'm interested in the IPv4 address, 192.168.4.154. Why don't we open up a web browser on this network on a different host and just try to connect to the Apache web page? So when I do that, it opens up the Apache 2 Ubuntu default web page, and it says it works. So we know then that the default web page configuration for that web server is now up and running on our Ubuntu Linux host, and of course we've also patched it to make sure we've got the latest updates applied. Now the great thing about a lot of these web server default web pages is they also serve double duty as not only a test page, but also a configuration page where it gives you some examples of what to do. Here it's showing us the configuration file layout on this host for the Ubuntu Apache 2 web server, such as going into /etc/Apache2. Let's explore that a little bit. So back here in Linux, I'm going to change directory to /etc/Apache2. I'll clear the screen, I'll do an ls. So we've got the apache2.conf file along with the ports.conf file. If I were to cat the ports.conf file to show the contents of that text file, it defines the listening ports for the web server. Here it's listening on port 80. And if we've got the SSL module enabled for the web server with the PKI certificate, then it's going to listen by default on port 443. But we know that SSL really is deprecated, should never be used. Instead, we should be using TLS, Transport Layer Security. Now, if the SSL module is not enabled for the web server stack, then it won't be listening for that type of connection on 443 using the SSL network security protocol. So we could even comment out those lines if we wanted to, but really, as long as we don't enable the SSL module, we're good. Now, speaking of that, why don't we take a look at the apache2.conf file, the config file, the main config file for the web server. So I'll clear the screen. I'm actually going to use the Nano editor to open it up, and it's called apache2.conf. Okay, so we've got a lot of comments at the top. Of course, these config files, as is pretty much normally the case everywhere in Linux, comments are notated on the line with a hashtag symbol or a pound symbol. That means that line is a comment. It is not to be interpreted as anything such as a configuration directive. So notice, for example, the server root directive is commented out. The default is /etc/apache2. We then have the error log directive, which is using a built-in Apache logdir variable /error.log as the default error log unless otherwise specified for the Apache web server. The log level is set to warning. Then we've got an include module section for additional modules that provide additional functionality for the web server. All the files that end with .load or .conf in the mods enabled location, which would determine things like whether SSL or TLS is being used, whether we have some kind of Java server-side components that are up and running. And notice it's also including the ports.conf file that we just looked at. As we go further down through the apache2.conf file, we also have some options for what permissions are allowed for different subdirectories on the web server. So I'm going to press Ctrl-X to close out of that file. We haven't made any changes. I'm going to do an ls again. We already talked about the ports.conf file for the listening ports for the web server, but here's the mods-available directory. Let's go into that directory. We've already talked about the ports.conf file for listening ports for the web server stack, but let's go into the mods-available directory. Change directory, mods-available. And if I were to do an ls in there, we've got all kinds of files that end with either .conf or .load as per our apache2.conf file. For example, we have an ssl.conf and an ssl.load file. So let's open up the ssl.conf file. Notice there's not a TLS file. These days, there's a lot of old references to SSL, even though we would be using its superseding network security protocol, TLS. So I'm going to open up the ssl.conf file. I'm going to use the sudo prefix so I can write to it. So I'm going to use the Nano text editor built into Ubuntu Linux, ssl.conf. What I'm interested in doing is making sure that the only protocol that is allowed in my particular case is TLS v1.2. Now notice the SSL protocol directive here currently has all, and the plus means we want to also add support for TLS v1.2. You could also alternatively change that to minus if you wanted to remove something, or I could just say SSL protocol, I'm not going to use the word all, but instead plus TLS v1.2 to make sure only that network security protocol version is to be used for this particular web server. Now, syntactically, you could also just remove the plus sign, which implies that we only want to support TLS version 1.2 on this host. Just bear in mind that if we want to support a newer version, such as TLS 1.3, we have to bear in mind that our configuration will have to change because we'll have to reference it in the ssl.conf file. So I'm going to go ahead and press Ctrl-X. It asks to save the modified buffer. I'll type in the letter Y. I want to overwrite the same file. I'll just press Enter, and it's done. At least the config is done, but it's not in effect until I restart the Apache 2 web server daemon, which I'll do with sudo service apache 2 restart. I'll just use the up arrow key to bring up that previous command, and I'm going to change restart to status. And so the Apache web server now is showing as active running. The purpose of OWASP is to ensure that web applications are protected against common web application exploits. We want to make sure the web app is hardened and as resilient to attacks as possible. One way to do this is to have a vulnerable web application to test common exploits against. And this is where Metasploitable comes in. Here I've done a search on the internet and ended up on the Rapid7 website where I can download the Metasploitable 2 intentionally vulnerable web application which runs in a virtual machine. So in the left-hand navigator, I've navigated down to installing Metasploit, setting up a vulnerable target, and then I've come across Metasploitable 2. And on the right, as I scroll down, I have two links where Metasploitable 2 is available. So I'm going to follow one of the links by clicking on it, and then I'll scroll down to the Download Now section, and I'll fill in the details, such as first name, last name, job title, job level, company, and so on. Once I've filled in the form properly, I then get the option to download Metasploitable. So I'm going to go ahead and click on that now. And I'm going to download the Metasploitable Linux-based virtual machine into my local downloads folder. It's a zip file, so I'll need a way to unzip that after the fact. So I'm going to go ahead and save it. It's an 825 megabyte download, so depending on your internet speed will determine how long it takes to get that brought down. Once the download's done, I'm going to go ahead and show it in folder, and I'll right-click on it. And I've got 7-zip installed, so I'm going to choose that option, and I will extract it to its own folder. Okay, so I'm going to open up the extracted folder. There's the Metasploitable 2-Linux as another folder, and here I've got the files for a VMware virtual machine. So I can copy that folder to wherever I need it to be, wherever I store my VMware virtual machines, and I'm going to go ahead and get ready to fire that up in VMware Workstation Pro, which I've got installed on my on-premises station. So here in VMware Workstation Pro, and I'm specifically running Workstation 16 Pro, I'm going to choose Open a Virtual Machine. And I'll navigate to the folder where I've extracted my Metasploitable 2 VM, and I'll choose the Metasploitable VMX file, and I'll choose Open. So the Metasploitable 2 virtual machine is now showing up in VMware Workstation. So under Devices on the left, I see the virtual hardware assigned to the VM, like the memory in the amount of 512 megabytes, the number of processors, and so on. I'm going to go ahead and start the virtual machine by clicking Power on this virtual machine over on the left. VMware Workstation then gives me a message about the virtual machine perhaps having been moved or copied. So I'm just going to choose I copied it, and the virtual machine starts. Now back in our documentation page where we started this whole thing off, where we had the links for downloading Metasploitable 2, if I were to scroll down further on that page, it talks about powering on the Metasploitable 2 virtual machine using VMware Workstation, which I'm using, or VMware Server, and then logging into it. Here we have the credentials. The username is msfadmin, and the password is also msfadmin. Once I've signed in with those credentials, the first order of business is identifying the IP address assigned to my virtual machine, but we're going to verify it with ifconfig. Okay, so the virtual machine has started up, so I'm going to sign in with msfadmin, and I'll press enter, and the password is also the same thing, msfadmin. And we're in. So if I were to type ifconfig, I have the IP address, which in this case is shown as 192.168.49.132. Now, the only problem is I know that that is not an IP address on my local area network. Well, that's because if I were to go to the workstation menu up here in the upper left, go to VM, and then all the way down to settings, if I take a look at my network settings, I've got two network adapters for this VM. One is set as NAT, Network Address Translation. So it allows me, for example, to get out to the internet from within that VM using the host's IP address, the host on which VMware is running. And the network adapter 2 is host only. So depending on your environment will determine how you configure this. For instance, if I select my network adapter for NAT, one option is to bridge it or connect it directly to the physical network as I described earlier, which is what I want. I want it to appear as a separate host on my LAN. And through DHCP, I want it to get an IP address on my LAN, like any other device would. I'm going to go ahead and click OK. And just try to run init space 6. That switches to run level 6, which means reboot. It says you need to be root. Okay, well, no problem. sudo init 6. We're not logged in as root. Remember, we are logged in as msfadmin. Let's reboot. It wants the password for msfadmin, which is msfadmin. Okay, let's give it a moment to restart. Okay, so let's sign back into our VM now that it's restarted, and let's run ifconfig. This is better because I know that my subnet is 192.168.4, and then I have .196. I've downloaded the free PuTTY tool and I've fired it up on my machine. PuTTY is one way that you can make a remote connection using SSH to remotely manage devices and hosts, like Linux hosts running the SSH daemon. So I've popped in the IP address for my Metasploitable virtual machine. It's set to SSH port 22 over on the left under Window Appearance. I'm just going to go ahead and click the Change button to increase the font size to 22. I'll click OK. I'll go back to Session in the left-hand navigator, and I'm going to give this a name. Let's call it Metasploitable, because I want to be able to call this up just by selecting the name. Now that I've saved it here, I can select it in the future and just load it up and then click Open to connect to it, instead of specifying all these details each time. So I select Metasploitable, I would choose Open. The SSH daemon is automatically enabled on that virtual machine, that Linux virtual machine. So PuTTY comes up and says, we've never connected to this before. Do you trust the RSA fingerprint of this host? I'm going to choose Accept, so it gets cached on my machine, and then it asks me to authenticate. I'll specify MSFadmin, and we're in. So this is much clearer and more legible than connecting to the virtual machine window. And finally, in a web browser, if I navigate to that IP address, it pops up the Metasploitable 2 web interface. From here, we have some links to configure various aspects of this intentionally vulnerable web application, which we'll see in future demos. Every organization should have a vulnerability scanner tool or have IT contractors that have tools that they use to periodically test the security of the network and of hosts on that network. One such example of a tool is OpenVAS. Here I've gone to openvas.org, where I'm going to click on the Test Now link, because this will take me to a trial of this tool where I can choose to download. Now, when I do that, it takes me down below and gives me the instructions for either VMware Workstation Player or Pro or Oracle VirtualBox. So it's a virtual machine appliance. And, for example, under VMware Workstation Player Pro, which I will be using, if I go under Instruction, it talks about the requirements. And ultimately, down at step 1, we have a download link to download the VMware OVA file for the trial. So it gives me instructions on the fact that I need to download and install VMware. And within VMware Workstation, I need to open the virtual machine OVA file that I previously would have downloaded in step 1. So I'm going to go ahead and click the download link to get that downloaded. Okay, so in my downloads folder, I've got the OVA file that I've downloaded. It's approximately 1.5 gigabytes in size. So what I would normally do is move that into a subdirectory wherever I store my virtual machines so that I can then open it as a virtual machine in VMware Workstation. Okay, so here in VMware Workstation version 16 Pro on the home page, I'll click the Open a Virtual Machine button. And I'll navigate to wherever I placed that downloaded OVA file for the OpenVAS virtual machine trial, and I'll choose Open. And I'll specify a name for the virtual machine, a storage path for the virtual machine, and I'll choose Import. All right, after a moment, it will have been imported, and I can see on the left here that I've got memory in the amount of 5 gigabytes allocated to the virtual machine, 2 processors, a 16 gig hard disk, bridged networking, so it will be on my local area network and should acquire an IP address via DHCP. All of that is fine, so I'm just going to go ahead and click Power On this virtual machine. And in the interface, I'm prompted with a GSM login screen where I'll specify a username of admin and also a password of admin. I'm then prompted if I'd like to complete setup. Yes is selected, so I'll just press Enter. It says that there's no user for the web interface, and I need a user if I want to connect to that. So it says, do you want to create a global web admin now? Yes. So I'll specify an account name for the web interface along with the password, and I'll confirm the password. Note to move from field to field, you use your arrow keys and not the tab key. The tab key will move down to OK or cancel. So I'll tab down to OK. I'll press Enter on that. It says the user was created. Okay. Press Enter. Now, if I go to the main setup menu, one of the options I'll have here is network, and I can go down within that to display the IP address, which in this case is 192.168.4.197. So it would acquire this on my local network through DHCP. That's the IP address I need to know in order to connect to the web interface. Now, when I do attempt to make that connection, it says your connection is not private because the OpenVAS web appliance is not using a trusted PKI certificate, and that's fine. I know that in this case, I'll click Advanced, I'll scroll down, and I'll choose to proceed to that IP, where I'm then asked to sign in. So I'll specify the credentials I created during the setup, at which point I get signed in. So from the configuration menu at the top, I'm going to choose targets. There are no targets configured, so I will click the new target icon up in the upper left. I'm going to call it HQ_network. And to determine the hosts that will be scanned, I can manually specify the range. So I'll put in a starting IP address with a dash and then a closing IP address or an ending IP. I can also exclude certain hosts within that range. I can determine which ports should be scanned on each discovered hosts. I'll choose all IANA assigned TCP and UDP. I can then determine the method that will be used to determine if a host is alive, such as an ICM ping or an ARP ping at the MAC address level. I'll use ARP ping. I could then specify the credentials if I want to do a credentialed vulnerability scan for connecting to discovered hosts that support SSH versus SMB, server message blocks for file and print sharing for Windows, or VMware ESXi hosts, or through SNMP. I'm not going to configure any of that, so this will be a non-credentialed scan, and I'm going to go ahead and choose Save. So we've now got our HQ network target that's been set up. Now, if I go back under configuration, this is where I could have gone to credentials and added credential sets that would have been used when we configure our target if we really want to. It could be username and password, or maybe a client PKI certificate or a PGP encryption key. So we could have configured this here as well and then used it. We can go to port lists. And this is where those port lists from that drop-down list were defined. Again, we could have added a new one here, and then it would have been available when we configure our target. So if I go to my scans button up at the top, I can create a new scan. So I'll click the new task button. And for the scan target in the drop-down list, this is where I would choose HQ network. I'm going to call this initial HQ network scan. And there are many scanning options. For example, under scan config, it's set to full and fast. We could just do a basic host discovery scan, but I'm going to leave it on what the default selection is. And I'm not really going to change anything else here. So I'm just going to go ahead and click Save. So now the scan is added down at the bottom. So I'm going to go ahead and click the Start button to begin the scan. And on this web page, we can monitor the status. There is a progress meter showing us the status of the scan. You don't have to refresh your web page. It will do that automatically for you. Once the scan is done, the status will reflect this fact, and I can click on the link for the name of the scan, and I can click on the report date and time, where I can see things like the scan time and the scan duration. The duration will really be determined by how many hosts are discovered on the network and what's running on them. So I can click the Results tab at the top to see any results of things that were found that might be of concern. I've got a couple of medium severity issues related to things like DNS cache snooping. I can click on that to get details related to DNS cache snooping, including the solution or the mitigation steps like disabling DNS recursion or not allowing public access to DNS servers. And as I go further down below, I see all of the hosts that are affected by it. The host IP addresses are shown, and in this case, the port numbers where that's available are also listed. I also have some SSL and TLS deprecated issues where I'm running things less than TLS v1.2. We don't want to be using SSL or anything less than TLS 1.2 to secure web applications. I can go back to the Hosts tab to get a list of the individual hosts that were discovered and the number of high, medium, or low severity issues with them. So I've got one particular host here that seems to have a higher number of medium severity issues compared to the other ones. And so I can click on it to open up its details. It's showing here that the OS is running a variation of the Linux kernel. So we can view those types of details. We can view the ports that were discovered, applications that were discovered, operating systems, a list of common vulnerabilities and exposures or CVEs that apply to what was discovered during the scan. In this case, it's the SSL and TLS deprecation issue. Any TLS certificates that were discovered running on devices. What we're always interested in here is the issuer distinguished name, the issuer DN, as well as the expiration date and time. We don't want to be using expired certificates. Up at the top, I've got a number of little icons, such as clicking the corresponding vulnerabilities list based on the scan. And as I scroll down, we get a list of specific issues like CGI scanning issues, discover DNS servers, of course our DNS cache snooping. So this is just another way to view the same type of information. And if I click back in my browser, we've got a number of other buttons up at the top, including a download filtered report button, where we can choose to download this as XML, a PDF, TXT, a CSV file, all these options. And after we've started running scans, we'll be able to go to the Assets view and get a list of hosts that will keep getting added to as new hosts are discovered over time. So this is an important step in discovering what's up and running on a network and whether or not it's exposed to a number of vulnerabilities. Because this is the same type of thing that attackers would do as part of the reconnaissance to discover what's on a network and essentially what the low-hanging fruit, the vulnerable hosts, might be. Implementing access control properly is crucial for the security of a web application, and that includes at the file system level. In this demo, we're going to focus on how to properly set Windows file system permissions. So the first thing I'll do here in Windows Server is I will go into the File Explorer, and I'm going to go to Drive E. Here I have a sample files folder with a couple of sample files within it. Now, the first thing we have to discuss is the fact that there are really two sets of permissions that can apply, at least over the network as well as locally, to files on a Windows host. So we have share permissions if we share a folder out over the network, and then we also have NTFS permissions for files and folders, which apply not only over the network, but also locally. Normally, shared folder permissions would apply on a local area network where people map drive letters to that shared folder. So for example, I'm going to right-click on my sample files folder. I'm going to go into Properties and Sharing, and I'll click Advanced Sharing. Now, currently, the folder is not shared over the network, so I'm going to choose Share this folder, and by default, it wants to use the same name that the folder currently has as the name of the shared folder over the network. They don't have to be the same. But I can also then click Permissions. The default is that everyone is allowed to read. However, I could add or remove entries to this ACL, to this access control list to change that. So for example, I might click Add, and I might put in the administrators group, and I might allow full control, change, and read. Notice that we have a deny column. Whenever you have allow and deny, when you've got combinations of users or groups and allow or deny permissions always take precedence. So this applies when people connect over the network to the sample files shared folder. So I'll just OK my way out of that. So one way to connect to that is using a UNC path. I'll just type in the address bar at the top of File Explorer here, /192.168.4.167. I'll just press enter to see what's shared. Among other items, notice we have our sample files folder. I could right-click on that and choose Map Network Drive, or I could open it directly. I'll just use drive letter Y, reconnect it, sign in. So I'm going to use all the default settings and I'll finish the drive mapping. And so now we have a drive mapping for letter Y, which points to our sample files location. But let me go back to the local sample files folder. You would normally not map to something that you're sharing locally. That really makes no sense. You would do it from other hosts over the network. So here in the sample files folder, I can also right-click on it and go to Properties. And instead of sharing, this time I'm going to click on Security. This is where I get to the NTFS file system permissions. NTFS is the formatted file system that's standard with Windows machines these days, where you can have local permissions for users and groups to individual files and folders. So I could select some of these default entries like the built-in users group here, which has allowed permissions for read and execute, list folder contents, read, and so on. Now, when you combine share level permissions for the shared folder and these NTFS permissions, the most restrictive applies. So you might have full control at the share level, but only have read access here at the NTFS level. Then you're only going to have read access. So you could click Edit, and you could add or remove entries. For example, if I click Add, this server is a part of an Active Directory domain. So I could click Advanced, Find Now, and I could actually go through and select users or groups from my Active Directory domain. For example, I'm going to choose East User 1 and click OK. So East User 1 is added to this access control list for this sample files folder, and that user automatically has read and execute, list folder contents, and read. Now, we could add additional permissions like the ability to write or the ability to modify. The primary difference being that with modify permissions, you can not only create and write to files and entries, but you can also delete them. That's not possible with the right permission. So I'm going to click OK. So now we've got permissions set at the share and NTFS levels for the sample files folder. Now those permissions flow down through the file system hierarchy, for example, to sample file 3 within that folder. If I were to right-click on sample file 3 and go to properties, notice I don't have a sharing tab. You can't share individual files, but I do have a security tab. Notice EastUser1 shows up here. I didn't add EastUser1 here, but if I click advanced, notice that EastUser1 is showing as being inherited from the permissions applied at the sample files folder level. We could disable inheritance and either copy these entries at this level or remove them, but the default is that file system permissions flow down through the hierarchy. You want to make sure you adhere to the principle of least privilege when you're doing this on a web server host to make sure that application components only have the permissions they need to function and nothing more. Managing Linux file system permissions is a very important task, and it can also apply to making sure that a user account that perhaps a web server stack is running as only has limited permissions to what it absolutely needs permissions to in terms of the file system. So basically adhering to the principle of least privilege. The first thing we'll do here in Ubuntu Linux is we'll use sudo cat. Cat shows us the contents of text files. We're going to look at what's inside /etc/shadow. The shadow file is the default credential file in Ubuntu Linux, and actually in many distributions of Linux. So we have a list of things like usernames, then perhaps a password hash, and then some information about password expiry and so on. So this is where you'd be able to determine, for example, whether we have a user called mbishop or sshd for the secure shell daemon. So in other words, the first order of business is determining the security principle to which you want to grant permissions. Now, if I were to type pwd for print working directory, it returns /home/cblackwell. If I type who am I, that's who I'm logged in as. I'm in my current home directory for this user account, where if I type ls, I've created a subdirectory called sample files. Let's go into that. Let's change directory to sample files, and let's do an ls. We've got 3 sample files here, sample file 1, 2, and 3. Each of them ends with .txt. If I were to do ls-l for a long listing, and remember here in Linux, everything's case sensitive, so we're talking about a lowercase letter L with -l. The long listing will still show me the file names, but much more information like modification date and timestamp information, the owning user, and the owning group. And yes, Ubuntu Linux does have a group for each user you create. For example, if I were to run sudo cat /etc/shadow, and I'll pipe that to the grep line filtering command, let's say for C Blackwell. Okay, so C Blackwell exists in the etc shadow file, but if I use the up arrow key to bring up that command too, and let's say we went into /etc and looked at the group file. Well, C Blackwell is also added as a group, so that's why it looks like a duplication of the username with the long listing, but really the first column is for the user, and the next is for the group. So let's clear the screen again, and let's do our ls-l listing. So we've got a set of permissions here. Now, in the first placeholder, we just have a dash. Well, if I were to make a directory here, mkdir, let's call it test. Let's do an ls-l again. Notice that the test directory has a D in the first placeholder because it's a directory. That's why we just have a dash in the other ones. The next 3 permissions are for whoever is listed as the owning user, which is in the next column, actually 2 columns over. In this case, user C Blackwell. RW means read and write. But what I could do is use the change mode command, chmod, to set permissions. And for the owning user, u, plus x, I want to add execute. And of course, in this case, let's say it's for sample file 3.txt. Of course, there's a typo in the name of the file. It's just samp file, no L, my mistake. That's okay. We'll just refer to the correct file name. We'll clear the screen, do an ls-l. And notice that the file now shows up lit up in green in this distribution of Linux anyways, because execute as a permission is turned on. So the owning user C Blackwell now has read, write, and execute R, W, and X. The next set of 3 permissions, which potentially could be read, write, execute, but here they're only read and write, applies to the owning group. And finally, the last 3 permission sets, which again potentially could be read, write, execute, are for everybody else. Now let's say I use the sudo group add command to add a group called HQ_admin. So let's say I want to add HQ_admin as the owning group for SAMP file 3. So sudo chgrp, which means change group. The group in question is HQ_admin, and the file or directory I want to apply it to, in this case it's a file, is SAMP file3.txt. Now, if we do an ls-l, notice that for SAMP file 3, C Blackwell is still the owning user, but HQadmin is the owning group, which means whoever's a member of HQadmin would get whatever the second set of group permissions are for this file. In this case, just read, write. Everybody else in the world only has read. I could change that, of course. As an example, there are many ways to do this. I could run chmod O for other -R. I want to remove the read permission, and this would be for SAMP file3.txt. If we do an ls-l, notice that the read permission is gone. So basically, only users C Blackwell and members of HQadmin would have any access at all to SAMP file 3. Now, instead of using the letters like I'm using, like O for other and R for read, you could also do something like this. You could run chmod, let's say 776, and I could apply that to SAMP file3.txt. What does that mean? Well, read has a numeric value of 4, write has a value of 2, and execute has a value of 1. 4 plus 2 plus 1 equals 7, so that's where the 7 comes from. So the first 7 would mean we're giving all permissions, read, write, and execute to the owning user. The second 7 means we're giving all permissions, read, write, and execute to the owning group. And 6 would mean we're only giving read and write, 4 plus 2 is 6, to everyone else. Let's see what that looks like, ls-l. Yeah, that pretty much looks right. RW and X, 4, 2, and 1. The first one is 7, then again, RW and X is 7, RW is 6. So you can set permissions using the numeric codes, the octal codes for permissions, as well as using the letters, whichever suits you the best. But at the end of the day, all we're really trying to do is set the appropriate file system permissions in Linux. And that's especially important in securing a web server to make sure that even if the user account used by a web server is compromised, the attacker won't have full reign of the entire file system. So it begs the question, under which user account would the Apache web server be running? Well, how about this? I'm going to change directory to /etc apache2. And of course, if I were to run sudo service apache2 status, I would see that the Apache web server is installed, of course, and it's active and up and running. So now that I'm in this location, I'm going to use the grep line filtering command to look for what I know is the user account. www-data is the user account under which the Apache web server will run. And in the environment variables file, which is used by the Apache web server, there's a user and a group, both called www-data, used for running Apache. So we could take that a step further. If I were to do cd/ to go back to the root of the file system, I can verify that with pwd. From here, I might run sudo ls-l, long listing, capital R, recursive, pipe, grep, so line filter again, www-data. In other words, starting from the root of the file system and recursively through the entire file system hierarchy, let's look for user www-data in the output of ls-l. I'll press enter. So for example, to the Apache2 subdirectory, www-data is shown as the owning user with read, write, and execute permissions. In this demo, what I'm going to be doing is managing attribute-based file system permissions. So this means instead of simply adding users to groups and giving groups permissions to files, instead what we can do is configure it such that the attributes of a user, or the attributes of a device, it could also be that, will be checked, and if they meet a certain condition, then permissions would be applicable to a given resource, a file or a folder for that user or that device. Now that's not to say you shouldn't be using groups. Using groups for permissions is still a great strategy. This is just an alternative way of doing it. It also depends on attributes being filled in consistently for users. For example, if you want to look at the department that a user is in to determine if they have access to certain files or folders on a file server, then that has to have been filled in for user accounts. And what we're talking about securing here is the underlying file system that might host files used by a web application. So this feature in Windows Server is called Dynamic Access Control. To get started here in my Windows Server, I'm going to go into the Start menu, and under Windows Administrative Tools, I'm going to fire up the Active Directory Administrative Center. This server is joined to an Active Directory domain, and the appropriate Active Directory management tools are available on it. In the left-hand navigator, I'm going to click Dynamic Access Control, since that is the feature that we want to configure here. And what I want to do is I want to create what's called a claim type. So I'm going to click on Claim Types. I could right-click, or instead, over in the tasks bar to the far right, under Claim Types, I could choose New Claim Type. A claim is an assertion about something, such as the department that a user is in, or the subnet IP address range they're connecting from, or whether they're a part-timer or a full-time employee, or could be a device attribute such as the mobile device operating system type. All of those are attributes that can be used in what's called a claim. And a claim can be used to authorize access to something such as files on a file server. So on the right, I want this to be a user claim. And in the list of attributes here, I'm interested, let's say, in determining whether people should have access to certain files based on their department. That means for user accounts, in this case, in this environment in Active Directory, users have to have been populated with the department for this to work correctly. Okay, so user department, and I'll click OK. So I've got my department claim type at the user level. Now I'm going to click Dynamic Access Control again on the left, and then I'm going to click Resource Properties on the right. A resource is a file or a folder. In the end, we want these settings that we are configuring applied to one or more file servers within the Active Directory domain. And so what I'm going to do here is I'm going to enable the built-in department resource property. In other words, not only do we want the department attribute filled in for user accounts in Active Directory, but I also want to make sure that we flag files in the file system as being part of a certain department, because those two things together will allow us to set the appropriate permissions. For example, if a user is in the Human Resources department, they would have read and write access, perhaps, to files on file servers that are flagged as human resources. So I'm going to right-click on the department attribute to enable it, and the icon changes to indicate that that attribute is now enabled. Now I'm going to go back to Dynamic Access Control on the left, and I'm going to go to Central Access Rules. I have to create a rule here and then add it to a central access policy. So I'll click New in the far right, and I'll choose Central Access Rule, and I'm going to call it HR, Human Resources, File Access. Now for the target resources, again, a resource is either a file or a folder. I'm going to click the Edit button to the right of that section, and I'm going to click Add a Condition. Basically, what I want to do is look at a resource property, which we've enabled, so it's important that we enable department first, otherwise it wouldn't show up here. Department equals, and here I can choose whatever value I want. Let's say human resources, which means that we have to have flagged files in the file system. Remember, a resource is a file or a folder. We have to have flagged them as department human resources in order for all of this to work. And I'll show you that in a moment. I'll click OK. Then down below, I can choose Use the following permissions as current permissions. I can click Edit. And this is where it would be like adding file system permissions at the NTFS level normally on a Windows host. I could click Add. I could choose Select a Principal. Here I could specify a specific group, for example, even the built-in Everyone group. So everyone will be checked to see if they're in the HR department. We'll get to that in a moment. And then I can set the permissions that should be applicable if that's true when they try to access files flagged as Department of Human Resources. But I don't just want to give everyone these permissions. They have to meet a certain condition, and I'll click Add a Condition down below. This is where I will select User, Department, Equals, and for example, Human Resources. So that has to have been filled in consistently for this to work for user accounts that are a member of the Human Resources department. Okay, so we've got a match between the user attribute being Human Resources and also the resource or file system department being set to resources. If those two match, then these permissions will apply for people in that department. Okay, so I'll click OK in the bottom right. I'll click Dynamic Access Control on the left, and I'll click Central Access Policies. And on the right, I'll go to New Central Access Policy. I'll call this HR File Permissions. And down below, I'm going to click Add to add my central access rule, HR File Access. So I'll move that over to the right, and I'll click OK. And then I'll click OK in the bottom right. We now have our HR File Permissions Central Access Policy. So the last thing we need to do is to make a few settings in Group Policy. So I'm going to open up my Start menu on this server, go to Windows Administrative Tools, and in the G's, I'll choose Group Policy Management. Under my Active Directory domain name, I'm going to choose to edit the default domain policy, so the settings I configure here will flow down to all of the file servers throughout the entire domain for these permissions. Otherwise, I could scope it out to a specific organizational unit or OU that might contain only a handful of file server computer accounts, whatever the case might be. I'm going to right-click and edit the default domain policy, and there I'm going to drill down under Computer Configuration, Policies, Administrative Templates, down under System, and then I'll choose KDC. I need to enable this KDC support for claims. So I'm going to choose Enabled, and I'll choose OK, because we configured attribute details for users. That's called a claim. But there's more I have to do here, so I need to go now, still under Computer Configuration and Policies, under Windows Settings, Security Settings, File System, and Central Access Policy. I need to right-click and choose Manage Central Access Policies. There's our HR File Permissions policy. I simply have to add it so that it will be applied to this part of the Active Directory hierarchy, meaning the Active Directory domain. And then it will flow down to the file servers. I'll click OK, and that's it. The configuration is now complete. We just have to wait for Group Policy to be applied to the file servers in order for this human resources file access to be put in place. Or we could force a Group Policy update on each server with the gp update/force command. But in order for this to all work, we need to make sure we have the File Server Resource Manager role service installed on all of the file servers that will be affected by our central access policy. Here in Server Manager, if I go to Add Roles and Features and proceed through until I get to the Roles screen, under File and Storage Services and then File and iSCSI Services, I need to make sure File Server Resource Manager is installed on all file servers that I want to partake in this attribute-based file system permission thing. So it's already installed here, which means I could launch it from the Start menu or straight from here in Server Manager under Tools, I could go into File Server Resource Manager, where if I expand Classification Management on the left and go to Classification Properties, if I click Refresh on the right, we'll then see that we have our Department Resource Property that we configured in the Active Directory Admin Center, which means that we could create a classification rule that looks for files that might contain something to determine if they should be flagged as human resources. We could also go into the file system and manually flag them as well. So if I were to right-click on a file and go into Properties and then Classification, so the Classification tab is there because we installed the File Server Resource Manager role service. Department is set to none. I could select that. And this is where I could choose human resources, and that would be matched against whoever signed in trying to access these types of files to see if their user account is filled in with the department. So for that, of course, if I were just to go into my Active Directory Users and Computers tool as an example, when we create users or modify existing ones in the user properties, we could go under Organization where we could fill out the department and make sure it's filled in consistently, so maybe human resources. And then when this user attribute is matched against the resource property of human resources, they would have the appropriate permissions. One thing that might be revealed when conducting a vulnerability assessment against a web application and its components is code that includes credentials. So if we've got a piece of code for a web app that needs to talk to a backend database or talk to storage somewhere, it might have a database connection string, a username, a password, some kind of a security token embedded in the code. This is a no-no, especially if that code itself is not encrypted. The way to deal with this in the Microsoft Azure cloud is to work with what's called a managed identity. A managed identity represents a cloud resource like a virtual machine. You can then assign permissions to it, and any code running, in our example, in that virtual machine would be able to take advantage of the permissions granted. So to get started here in the Microsoft Azure portal, I'm going to create a virtual machine and we'll set up a managed identity and give it permissions. So to start, I'll click Create a Resource, and I'll choose virtual machine. Let's say our goal here is to deploy a Windows virtual machine in which we will manually set up the IIS web server and a custom web app. All we're going to do here is deploy the virtual machine and give it permissions. So I'll tie it to a resource group, and I'll give a unique name to the virtual machine. I'll deploy it in the East US region, and down below, the image is currently set to Ubuntu server. So I'm going to open that up, assuming I want Windows. Let's say I'll choose Windows Server 2022. Down below, I'll fill in a Windows operating system username and password. And really, I'm just going to continue through the wizard, pretty much accepting all of the defaults to the point where I'm just going to go through everything and then click Review and Create. Now, I can do that without going through all of the optional configuration settings. The validation has passed, so let's just get this created. I'll click the Create button. Okay, that won't take very long. The deployment is complete. I can click Go to Resource to open up that virtual machine's properties the way I've configured this in the overview blade selected on the left. On the right, it reveals many details, including the public IP address. So because it's running Windows, I could use an RDP, a remote desktop protocol client, to connect to this public IP with the correct credentials, and I could get into that operating system and configure a web server stack and whatever else I need to do. But the focus here is not specifically that, because if you want to focus on a web application in a cloud environment, we can just deploy a web app as a managed service in Azure where you don't have to set up the virtual machine and the web server stack. The reason we're doing it this way is because we want to take a look over in the left-hand navigator at identity. By default, identity is turned off. I'm going to turn on a system-assigned managed identity for this virtual machine, and I'll click Save. I'll click Yes. What this is going to do is it's going to create an identity in the underlying directory service here, Microsoft Azure Active Directory, Azure AD, and a system-assigned managed identity is tied to the lifecycle, in this case, of this virtual machine. In other words, if I delete the virtual machine, the system-assigned managed identity goes away. Now, once that's done, I can start assigning permissions to this virtual machine. In my left-hand navigator, I'm going to go to my list of storage accounts. Let's say that we know we're going to have some web app code running in that virtual machine that needs access to a storage account, maybe to get some graphic logo files to present on the website. So I'm going to open up that storage account, and I'm going to click Access Control IAM on the left. IAM stands for Identity and Access Management. This is where we can grant permissions to this resource. This resource is a storage account. So I'm going to click Add Role Assignment, and I want to select the Storage Blob Data Contributor role, which allows reading, writing, and deleting of blobs or files in the storage account. So I'll click Next. Now it wants to know to whom I would like to give this permission. A user group or service principal or a managed identity? Well, in this case, it's going to be a managed identity that represents our virtual machine. So I'll select Managed Identity, and down below I'll click Select Members. And from the Managed Identity drop-down list, I'll choose Virtual Machine, and there's the virtual machine that we turned on a managed identity for. So I'm going to select it, click Select, Review and Assign, and Review and Assign again. And I'm going to check my work. And maybe I'll filter it for WIN because I know that's part of the name of my Windows virtual machine. And sure enough, our Windows virtual machine has the Storage Blob Data Contributor role to this resource, which is a storage account. So instead of embedding credentials in config files used by your web app, this is by far a much more secure way of doing it, specifically if you're using the Microsoft Azure cloud to host your web application. Now, to take it a step further, you could also have made that role assignment at a different part of the hierarchy. Here we did it for an individual storage account. Well, I could, for example, search for the word sub up in the search bar at the top, choose subscriptions, click on my subscription for Azure, click Access Control IAM, and add the role assignment here. If I were to do it that way, to add the storage account permissions or role to my virtual machine, it would apply to all storage accounts in the subscription. Alternatively, if I open my left-hand navigator, I could also go to Resource Groups. I could open an existing resource group, choose Access Control IAM for it, and do the same thing. I could click Add Role Assignment, set storage account permissions for the virtual machine, and in this particular scenario, the permissions would apply to any storage accounts in the RG1 resource group. You can click Overview over here in the resource group, and then over on the right, you'll see all of the resources in that resource group. So there are plenty of ways then to set these permissions in a secure manner. We know that the top of our list, item A01 of the OWASP Top 10 for 2021, is Broken Access Control. And we have some details related to that here on the OWASP.org website. Now, broken access control can mean a lot of different things. In our particular case, we're going to be executing a directory traversal attack against a web application. Directory traversal attacks allow the malicious actor to traverse the file system hierarchy on a web server through the web server interface, maybe by modifying a URL. In other words, to gain access to files that they otherwise should not have access to at all. So it's a flaw in the design of the web application. I have the Metasploitable 2 intentionally vulnerable web app virtual machine up and running and available, so I've navigated to it in my web browser. On the Metasploitable 2 homepage, I'm going to click DVWA on the left, and I'm going to go ahead and sign in. Now, the username is admin, as it tells me at the very bottom, and the password is password, so I'll specify those credentials. What I'm interested in on the left in my list of potential attacks is a file inclusion attack. And the vulnerability file inclusion page here says to include a file, edit the page equals index page P in the URL to determine which file is included. Okay, so how do we do that exactly? Let's go back to the Linux VM where this virtual machine, this website is running, and let's navigate the file system a little bit. So I've SSH'd into my Metasploitable 2 virtual machine, and here I've changed directory to /var/www/dvwa/vulnerabilities/fi for file inclusion. And when I do an ls, it gives me the files that are used for the page that we were just looking at in the web browser. Now, to modify that URL to go backwards through the file system, I can do that using two dots. For example, right now, here at the command line, if I say cd space ... enter, it takes me one level back. cd ... enter, another level back, and so on. So if I were to go 1, 2, 3, 4, 5 levels back, that would put me at the root of the file system, which would then allow me to go down into the file system hierarchy into other subdirectories, such as etc. If I change directory to etc, I would be in here. And I've got a file here called password, but it's spelled PASSWD. The Linux password file here has user account information, and as well, if I were to cat the shadow file, that also has information, although I would have to run that with elevated permission, so sudo cat shadow, put in the password for msfadmin, which is also msfadmin. This shows me the user accounts, but it also includes a password hash for each of those accounts. My point is that these are sensitive files that potentially might be reachable through a vulnerable web app that allows directory traversal attacks. So back here in the web browser, I'm going to click in my address bar up at the top, and instead of page equals and include PHP, I'm going to put in ... that's one subdirectory level, 2, 3, 4, 5 levels back, /etc/ let's say password. Now here it says error, file not found. That's good. However, what we can do with the Metasploitable 2 web application is we can modify the levels of security on it to examine or observe how these attacks actually work and what they would result in. Let's go back in our web browser. I'm going to click DVWA security on the left. Currently, notice it's set to high security. Well, that's why we were unable to run that attack. But if I change that, let's say to low and submit it, go back to file inclusion on the left, and basically modify the URL in the address line like we did previously, .. 5 times to go 5 levels back to the root of the file system in the underlying Linux OS, and then specify /etc/password. This time, it actually returns the contents of the etc password file on that server. If we were to attempt to change that, let's say to etc shadow, In this case, the file system permissions in Linux will prevent access to that particular file. So we might not have access to everything we want access to, but the fact that we can pull up etc password is frightening. Back here in the Linux file system for my Metasploitable virtual machine, I'm back under /var/www/dvwa/vulnerabilities/fi. If I were to do an ls, in here I have a source directory. If I change directory to source, here I've got the high, low, and medium PHP files to set the security levels. Remember, I switched from high security to low. Let's examine what's in the high.php file. I'm going to cat high.php and pipe it to more to stop after the first screenful in case there's more than one screenful of information. So what the code is doing in this is it's checking that the file that is being referenced, we're getting that from the page. If the file is not include.php, we just get an error, file not found. So we're only allowing include.php to be retrieved in the URL. If I were to cat the low.php file, and I'll just pipe that to more, this does a get of the page, and it's not checking it. It's not validating anything. It's just simply retrieving whatever is asked for in the web application. So back here in Linux, I want to check to see which user account the HTTP web server is running as. So I can use the ps command to list running processes. With the AUX parameters, I'll pipe that to egrep, and I'm going to look for either Apache or HTTPD, and it returns back that the Apache 2 web server is running under the www-data user account. Down at the bottom, it's showing MSF admin because that is reflecting the command I just issued. So therefore, if I were to cat /etc/password and perhaps pipe that just to grep looking for www-data, grep is a line filtering tool, it returns back user account information for www-data. So to take that a step further, do a long listing ls-l of /etc/password. The first set of 3 permissions, in this case it's only RW, there's no X or execute, read and write, is applicable to the owning user shown here as user root. The next 3 sets of permission where only read is set is for the group that has permissions to the file. There's a group called root. And finally, the last R is for everybody else, which would include people that are not user account root nor part of the root group, such as the www-data file. So that's why the web server was potentially allowed access to this file. So you could change file system permissions if it makes sense to control access to certain files. Or of course, you could have validation where the server will check what the user is passing as credentials. All user input is to be treated as untrusted and must be validated before allowing the server to execute a client-supplied request. When we think about securing a web application, we can never forget about the physical security aspect. Not even necessarily of the web server and where it's being stored physically in a data center or a server room somewhere, but on the client side, which could be from anywhere. That could be in somebody's home. We're talking about a hardware keylogger. A hardware keylogger is a physical device that you plug into, for example, the back of a computer or a laptop, and then you plug the USB keyboard into it. That means that any input through that keyboard is being tracked by the hardware keylogger. This all happens before it enters the machine, before it's seen by the operating system and virus scanners, which will not pick up on this. It's not a software keylogger, it's a hardware keylogger. It's amazing what some people will do to try to gain access to web applications or the credentials to get into a web app. Imagine that a home is for sale, and we know that the owner, the seller of that home, is a high-profile executive at one of our competing companies. We might book a viewing with the real estate agent to get into that home, and during the viewing, we might covertly install a hardware keylogger on the homeowner's computer so we can log their keystrokes. Now, you don't even necessarily have to physically come back and get that hardware keylogger to read the keystrokes, as we're going to see here. It might have a built-in Wi-Fi access point that you could access from the street in front of the property. So it's in some of these absolutely ridiculous and crazy ways that sometimes web applications are hacked. Now, getting a hardware keylogger is very easy these days over the internet. Here I've done a search for USB hardware keylogger. And right away I have hardware keylogger, AirDrive and key grabber keylogger. If I click on it, we can read the details about this, and various products do the same type of thing. And then we can simply order it and pay for it. Here we can see it's around $45 thereabouts for a hardware keylogger. So depending on the model you want will determine how much you pay. But the point is that it's very easy to acquire this information, just like nefarious users can easily acquire hidden cameras that they might place throughout a building. Now, this means that the attacker would have to have access to a user station physically where that user is using something like a USB keyboard. So in this particular case, I've got my keyboard plugged into a hardware keylogger, so presumably a malicious user would have sneaked into a facility, for example, and plugged this in without my knowledge. And so when I'm signing into a website, it's going to capture everything I'm typing in. So here I'm at the DVWA website. That's the Damn Vulnerable Web Application. So what I'm going to do then is using my USB keyboard, which is plugged into the hardware keylogger, plugged into my machine, I'm going to specify a username and a password. So an attacker can connect remotely, at least within Wi-Fi distance, to the hardware keylogger with the embedded Wi-Fi network. So from their perspective, they would, for example, get a list of Wi-Fi networks. This one is called Air 0844BC by default, but certainly I could change that if I needed to. So I'm going to go ahead and click, and I'm going to connect to that Wi-Fi network. The default configuration here is it's an open network, so no credentials are required. Attackers would normally harden this, maybe with the WPA2 pre-shared key or something like that, to make sure only they can connect to and gather or harvest those keylogged credentials. Okay, so I'm connected to that Wi-Fi network. There's no internet connectivity, but I am connected to it. So what I'll do is go to a command prompt on my machine, so CMD, and what I want to do here is I want to type in ipconfig. So for my Wi-Fi network, I'm interested in the default gateway address. That's what I'm going to enter into a web browser, 192.168.4.1. Now, when I view the page, I immediately see that someone typed in admin, so presumably that's a username, then they pressed tab, then they entered a password of password, and then they pressed enter. Now, that's the only thing that was captured on this hardware keylogger. Otherwise, I could go through all of the pages. And if I go down to settings, here I can do things like change the name of this access point. Currently, it's open for security, but I could enable, for example, WPA2 so that we would have to know a passphrase to be able to connect. We can also have this as a hidden access point, so its name doesn't just show up when people are scanning for local Wi-Fi networks. And we can also go all the way down, for example, and we could erase the log if we want to start fresh and capture new items and not see old items that were captured. But the point is this: it is very, very easy for someone that has physical access to someone's computer to install a hardware keylogger unbeknownst to the owner of that computer. And if they're signing into web applications like was done here, it's incredibly easy for attackers to retrieve these credentials. Now, you might wonder, won't my virus scanner pick that up? It won't, because this is not a software keylogger. It's at the hardware level before stuff even gets into the computer operating system. So the only way to really mitigate this type of threat against the stealing of web app credentials is to ensure that we have physical security measures in place. We want to make sure, for example, in the reception area of a business, that there's always someone present. We don't want to leave the front desk unmanned for a period of time during lunch when customers or anyone could basically walk in and do this to the receptionist's workstation. In this demonstration, I'm going to be classifying data on a Windows server using the Microsoft File Server Resource Manager. File Server Resource Manager is often shortened or abbreviated to FSRM when it comes to literature and if you do a web search, that type of thing. The idea with classifying data is for us to know where our sensitive data exists, whether it be on premises, in the cloud, or a hybrid of both. We need to know where our sensitive data is in order to apply security controls to protect it accordingly, such as with encryption, using a cryptographic solution to protect data at rest. You could encrypt everything everywhere, but that's usually not feasible. We might want to gather up sensitive data, store it in a centralized location, and encrypt that location, whether it's some kind of a vault at the hardware or software level, or whether it's on a particular disk partition or an entire disk. So let's get started here in Windows Server. I'm going to open up my Start menu and fire up the Server Manager, because Server Manager is one way by which I can install server components. FSRM is not installed by default, although it's available to be installed. So under Configure this local server, I will click Add Roles and Features. I'm going to go to the Start menu just for a moment here and fire up Windows PowerShell, because if you're a command line type person, you could also use the add-Windows feature commandlet or install-Windows feature, same thing, and then give it the name of the feature you want to install, such as the File Server Resource Manager. Now, if I were to run get-Windows feature wildcard symbol resource again, here's the File Server Resource Manager. The actual name is fs-resource-manager, but notice it's not installed because we don't have an X within the square bracket. So I'm going to minimize that. And back here in the Server Manager, I'm going to proceed through the wizard. The current server on which I am doing this is selected. Well, that's where I want to install the feature. That's good. Next. Under Roles, what I want to do is expand File and Storage Services. And then within that, I want to expand File and iSCSI services, because that's where we'll find File Server Resource Manager. So I'm going to put a check mark on that. It'll pop up and ask if I want to install some additional tools. I'll just go ahead and choose Add Features because I do want that. I'll click Next. There are no features I want to enable here beyond what I've enabled for the role service for File Server Resource Manager, so I'll just click Next and I'll proceed by clicking Install. And before too long, the installation will have succeeded, so I'll close out of there. Let's just go back into PowerShell for a second and use the up arrow key to bring up that previous command. Notice this time the File Server Resource Manager shows as being installed. Okay, so back in the Server Manager GUI, I could also go to the Tools menu where I now have a File Server Resource Manager option because it's installed but it's not been configured. Or I could go to my Start menu and under Windows Administrative Tools in the same way, down in the Fs, I could go to my File Server Resource Manager. So I'm going to start that tool. What I'm interested in here is classification management. You've got other things you can do with this tool, like setting file system quotas and file screening to control which types of files are allowed on the server, run storage reports. All of that stuff is great, but not what I want. I want classification management. So down under that, I can select classification properties. These are different properties that are available that I can assign to files and folders to classify them in some way. For example, if I were to go into the file system here on this file server, let's say go to drive E, where I've got a sample files folder, and I've got a file here, sample file 2, that's got some text in it that says this is secret stuff, among other things. Well, if I wanted to, I could manually classify that file by right-clicking on it, going to the Properties option, and because I've installed File Server Resource Manager, the classification option is available here. Now I want to create a new property, so I'm going to choose Create Local Property over on the far right, and maybe I'll call this property Confidential. Now the type can be yes, no. Yes, it is confidential. No, it is not. It could be date, time, number. It could be a string or a multi-string value. In this case, just yes or no. And I'll click OK. So now confidential shows up in my list of local properties for file classification here on this file server, and only on this single file server. If you've got a bunch of file servers joined to the same Active Directory domain, you can define properties centrally that will show up. We'll look at that in a moment. Let's look at this first by going into the File Explorer on this file server. I'll navigate to Drive E, Sample Files. Here I've got a file, let's say called Sample File 2. I can manually classify the file by right-clicking on it, going to Properties, and going to Classification. Now, confidential shows up here as a local property on this server, but it's not set to yes or no. If it is confidential, I could choose yes. Now, of course, you might write a script that looks for these types of attributes and moves them to a centralized storage location where they'll be encrypted, or whatever mechanism you have in place to deal with that. There are many options. But it's doubtful that you'd want to go through all of the files in your environment and manually determine, in this case, if they're confidential or not. There must be an automated way to do it. Of course, there is. If I go back into the File Server Resource Manager, that's where classification rules come in. I'm going to right-click and choose Create Classification Rule. And I'm going to call it Seek Confidential Data. I'll click Scope. So I could choose certain types of files, or down below, I could click the Add button and specify a location, which I will do here. I want to specify drive letter E. I want to scour drive letter E in its entirety, although I could choose a folder on drive E, but I'll choose the root of drive letter E. I'll click OK. I'll click the Classification tab. I'm looking at the content within files, and I can select a property. I only created one called Confidential, and I can set a value of yes. Okay, but based upon what condition? Well, that's what the parameters and the configure button down below are for. If I click configure, I can tell it I want to look for a string, and it can be case sensitive or not, and I want to look for the word secret. And if that word is found, I want it flagged as confidential. Yes, I'll click OK and OK. So our Seek Confidential Data classification rule is shown. Now, if I go back into the file system, sample file 2, if I open it up, does have the word secret within it, whereas sample file 1 does not, nor does sample file 3. Back here in the FSRM tool, I could create a classification schedule so it periodically will, in this case, seek confidential data, or I could just run classification with all rules right now, which I will do for demonstration purposes. And I'll leave it on Run Classification in the background, and I'll click OK. Now, if we were to go back into the file system and right-click on sample file 2, go into its properties, and go into classification, we would see that confidential is now set to yes, whereas for the other files, it should remain unchanged. So if we go to classification, it's just set to none. So instead of manually scouring potentially millions of files, you could have this automated. Now, I did mention that instead of creating a local property like we did, called confidential, which only applies on this single file server, what if we've got 100 file servers and we want to use confidential? We don't want to do the same thing 100 times in terms of defining that property on each server. So we could do it centrally in Active Directory. From my Start menu, under Windows Administrative Tools, I'm going to choose Active Directory Administrative Center because that's where you can define things like centralized Active Directory properties. To do that, I would click on Dynamic Access Control on the left, and I would choose Resource Properties on the right. We have a number of properties here that we can choose to right-click and enable, and they would show up on all domain-joined computers. Notice we do have one here called Confidentiality, but I'm going to create my own custom new resource property. So over on the right, I'll click New Resource Property. I'm just going to call it Confidential. For the value type, it's going to be yes, no, kind of like what we did locally on the single file server. And then I'll click OK at the bottom. So we now have confidential that shows up here. If I right-click on it, notice that we don't have the option to enable it because it's already enabled when you create it. You could disable it. And that's why the icon looks a little bit different. It looks kind of like a colored-in dark gray rectangle as opposed to a light gray rectangle with a circle. So if I were to go back into the File Server Resource Manager tool, let's just click on something else and then click back on Classification Properties and maybe click Refresh over on the right. So now this confidential property here configured centrally in Active Directory will become available on all file servers joined to the domain where File Server Resource Manager is installed. And so then it could be used in that manner. So there are many tools out there, whether they're on-premises based like this or cloud-based solutions that will allow you to discover data and classify it accordingly in order to protect it. So you can apply the appropriate security controls to it. Depending on the nature of a web application will determine what kind of data it results in. And so this might be an absolute requirement, maybe a contractual or a regulatory obligation for compliance that you must put in place. We know that classifying data is important so that we know if we have sensitive data, where it resides, and this will facilitate the application of security controls to protect that data. Sometimes this is absolutely required for compliance with laws, regulations, perhaps security standards, even contractual obligations, to have the correct security in place. In this particular case, we're going to be using something called Amazon Macie in the Amazon Web Services or AWS Cloud to discover and classify data so that we know if we have any sensitive data stored in the cloud. To get started here in the AWS Management Console, in the search field at the top, I'm going to search for S3, and I'll click on S3. An S3 bucket is enterprise storage in the cloud. I've already got a bucket here called bucket-YHZ1. It's in the US East region. This is always important too when it comes to data sovereignty. Where does the data physically exist? Because that can determine which laws apply to the data. At any rate, I'm going to click to open up my bucket because within it I've already uploaded some sample files. So what we want to do in this case is enable a job in Amazon Macie to basically scour through one or more buckets looking for data and then determining if any of it is sensitive. To do that, I'm going to search in the search bar at the top here for Macie, M-A-C-I-E, and I'll choose Amazon Macie to open up that console. Now on the summary page here in Macie, I have some quick information made available about encryption for S3 buckets, any S3 buckets that might be enabled for public access. But over on the left, if I scroll down under Settings, I can choose Custom Data Identifiers. This is where I could click Create, and I could specify things like a regular expression, in other words, using special characters for pattern matching, looking for something within files uploaded to S3 buckets that I would consider to be secure, such as a social security number, or maybe we're looking for specific cost codes for products that would be sensitive information that consist of letters and numbers. So we could build our own custom data identifiers. Now the standard stuff like credit card numbers and so on will automatically be looked for. So up on the left, I'm going to go back to Summary where I want to create a job. So I'll click the Create Job button. And one of the first things I do here is choose the S3 bucket or buckets that I want to scour looking for sensitive information. So I'm going to put a check mark next to the bucket that we looked at, bucket-YHZ1. I'll click the next button over on the right, and I'll click Next again in the bottom right, and we can schedule this job recurrently. Maybe we want to have it look at any new or modified data daily or weekly or monthly looking for sensitive items. Or it can be a one-time job, which I will do in this example. We can then specify the sampling depth. The sampling depth here is set to 100%. Because we have such a small amount of data, I'm going to leave it that way. But you can imagine that if you had, let's say, 10 million objects in an S3 bucket, if you set the sampling depth to 50%, it will randomly select 50% of those 10 million items to analyze those. Of course, if you specify 100% as a sampling depth, it would take longer than if you had specified 50%. Down under Additional Settings, we can also add object criteria stored within the bucket, maybe looking for certain types of files by file name extensions, or the size, or how objects are tagged with key and value pairs. Maybe we only want to look at objects that were modified after a certain period of time. Now, if I don't specify anything for inclusion or exclusion criteria, it says here that the job will analyze all objects in the buckets in accordance with your sampling depth. Okay, so in the bottom right, I'll click Next. Now remember, we went in and looked at the fact that we could create a custom identifier, maybe looking for a product cost code or something like that. Here is where we specify the data identifier options. It's set to use all of them. We could exclude or include specific data identifiers. If I choose Include, here are some default built-in identifiers. Looking for addresses or an Australia driver's license, or a bank account number, or a Canadian passport number, Canadian social insurance number, credit card expiration date, looking for a credit card number. So we can specify which of these we want to use. In this case, I want to use them all, so I'm going to leave it on all, and I'll click Next. And as we saw earlier, during this configuration, once again, we have the option to create a custom identifier. I don't need to do that, so I'll click Next. So for the job name, I'll call it Seek Sensitive Stuff. I could specify an optional description, and then I'll click Next in the bottom right. Okay, so we have the review screen here for all of our settings. I'm just going to go ahead. Down at the bottom, I'm going to override the requirement for not having configured a repository. That's if you want to keep long-term storage of your discovery results, and I'll click Submit. Okay, the job is now submitted. So seek-sensitive stuff is shown with the status of active and running. Now I can click Refresh here to track the status of this job. It won't take very long because we don't have very much information stored within our S3 bucket. All right, and then before too long, the status will change to complete for our job. So I can click on that. Job. Okay, and before too long, the status of our job will change to complete. So having that selected, over on the right, I can choose the Show Results button and choose Show Findings, which opens up a new window. Now right away, it found some sensitive data, specifically in the financial category. And we have the bucket name shown here, specifically the file within that bucket. If I click on it to open it up, it even shows over on the right that it looks like it found some credit card expiration information, specifically 2 instances. If I click on the link for 2, it actually even references the cells. Apparently, this is a Microsoft Excel spreadsheet file where that information was found. So this is valuable information because by it identifying sensitive data, in this case, personally identifiable information or PI, we now have the knowledge that that type of data exists and we can put the appropriate security controls in place to protect it. If you're using a Windows computer, one way to protect data at rest is to encrypt files in the file system using Encrypting File System, otherwise called EFS. This was introduced as a Windows feature way back in Windows 2000. The idea is that based on the current signed-in user's credentials, they can encrypt files, and then when they sign in again, they have the ability to transparently decrypt them by simply opening them. So it is tied to the user credentials. In other words, if a user account can be compromised, well then all files encrypted with that user account are also compromised. Interestingly, in an Active Directory environment, the domain administrator account is a default recovery agent that can decrypt any encrypted files for any domain-joined computer. Now this is tied to the user. There are many other encryption systems that are not tied to a user. They might simply require a passphrase to decrypt a file, or they might be tied to a machine, such as with Trusted Platform Module or TPM firmware that works in conjunction with software like Microsoft BitLocker. Those are disk volume level encryption schemes tied to a machine. EFS is not that. So let's experiment a little bit with this. On my Windows server, I'm going to open up Windows Explorer, and I'm going to go to drive letter E where I've got a sample files folder. So I'm going to select that folder and right-click on it and choose Properties. Down below in Attributes, if I click Advanced, I have the option to compress contents to save disk space. Well, that's great for saving disk space, but we also have the option to encrypt contents to secure data. If I turn that on and click OK and OK, I'm then prompted as to whether I want to apply the changes to the folder only or to the folder, its subfolders, and existing files. I'm going to choose Apply Changes to Folder, Subfolders, and Files, OK. So now if I go into the sample files folder, each of these files is encrypted. Visually, there is a tiny gold padlock icon on each file, but we could just right-click on one of those files, go to Properties, click Advanced at the bottom, and indeed, the encryption attribute is turned on. So it's encrypted for the current logged-in user. Now here I've switched over to a Windows 10 computer, specifically Windows 10 Home Edition. The reason I've done this is to point out that some Windows editions, especially on the desktop side, do not support all features like Encrypting File System or EFS. If I were to right-click on a file here and go down to Properties, down at the bottom under Attributes, go to Advanced, well, compression is an option because it is an NTFS file system, but encryption is simply grayed out. So it's not available on some desktop operating system editions. Back here on my Windows server, I'm just going to cancel out of those screens. Now you could elect to encrypt some files within a folder and not others. For example, if I want to decrypt sample file 2, right-click, Properties, down to Advanced, just remove the check mark. Click OK. OK, it's no longer encrypted. If I were to create a new file here, so let's say I create a new text document, which I will call sample file 4, and press enter, we'll notice that the newly created file is automatically encrypted, and that's because the EFS encryption attribute is enabled on the folder in which we've created this file. So Not only will it encrypt existing files, but newly created files that are created or copied into this location will also be encrypted. If I were to right-click on any of these files that is encrypted and go to Properties, down to the Advanced button, when it's encrypted, the Details button to the right of the Encrypt option becomes available. If I click Details, it shows me who can access the file. I'm currently logged in as the administrator account for an Active Directory domain, so that's who is shown as being able to access the file. The domain administrator is also the recovery agent that can recover these files. Any domain-joined computer. Notice that we have an Add button. We could add additional users given that we have their certificates on our computer so that they too would be able to decrypt the file. Imagine a situation where you have a file where multiple admins should be able to decrypt it. Well, this is how you could go about doing that. Now, depending on the nature of what a web application is doing will determine whether you should use EFS encryption on a Windows-based web server. Remember that the encryption is tied to a specific user account, and that may not be the solution you're looking for if, for example, the result of your web application writes new files to the web server's disk or records in a database, and you want it encrypted but not tied to a particular user account. Now, with EFS, though, we can also work at the command line. If I open up a command line environment, I'm going to go to Drive E, and I'm going to change directory to sample files, where I'll type dir. So I've got my sample file shown here. If I were just to type cipher with no parameters, it lists each file with the capital letter E to the left, meaning it is encrypted. There's also a note at the top that says new files added to this directory, that would be /sample files / will automatically be encrypted. What I could do, though, is change the encryption attribute. Let's say I ran cipher/d for decrypt sample file 4.txt. Okay, it says it was decrypted, but if I just type cipher and press enter, notice that sample file 4.txt now has a capital U to the left of it instead of a capital E. It's been unencrypted. So we can manage the EFS encryption attribute for files and folders at the command line using the cipher.exe command line utility. In this demonstration, I'm going to encrypt data at rest on a Windows system using Microsoft BitLocker. BitLocker is a software encryption solution that can be used in conjunction with TPM, the Trusted Platform Module. This is normally a firmware chip, but there are ways to virtualize it with things like VMware. But the idea is that BitLocker is used to protect data at rest through encryption, where the encryption is tied to the machine where the TPM is. It's not tied to a user account like EFS is. BitLocker can also be used to verify startup integrity on a disk for the operating system to make sure that the startup environment hasn't been tampered with. So to get started here on my Windows server, I'm going to go into the Start menu and go into Server Manager. The reason I am doing this is because, well, for example, if I go into my Start menu on the server and type in BitLocker, I have a Manage BitLocker option, but it's kind of grayed out, and when I click it, it doesn't do anything. And that's because the feature's not installed. So here in Server Manager, I can install server-based features, just like I could at the PowerShell command line as well, using the add-Windows feature, which is the same as install-Windows feature. But here in Server Manager, I'm going to click Add Roles and Features. I'll click Next, and I'll keep going through past the server where I want this installed, which is the current server where I'm performing this action. That puts me on the Roles screen. BitLocker is not a role, it's a feature. So there's nothing here in Roles that I want to change, so I'll click Next. Here on the Features screen, this is where I can enable BitLocker Drive Encryption. When I select it, it asks if I want some additional tools installed, so I'll just accept that by clicking the Add Features button. I can also install the BitLocker Network Unlock feature if I want to use a network unlock key mechanism to unlock BitLocker protected drives on Active Directory domain joined computers. This could be useful if you have to do some kind of maintenance on machines during non-business hours. But I'm not going to do that. I'm just going to enable BitLocker Drive Encryption, and I'll click Next. Then I'll click Install. This is going to require a restart on the server, so I'm going to go ahead and close the installation screen and restart this machine. All right, so now I've restarted after having installed the BitLocker feature. Let's go into the file system on this server. Here I've got drive letter E, which is a separate data disk on which I have some sample files. So some files and also a folder. So what I want to do is I want to enable BitLocker on drive letter E. So I'm going to go ahead and right-click on drive letter E in the left-hand navigator, and I'm going to choose Turn on BitLocker. And it asks, how do you want to be able to unlock or decrypt the drive? So we could select to use a password that we have to enter, or we could use a smart card. If our machine has a smart card reader, we would simply have to insert the card and we'd be able to unlock it. Of course, you would need to know a PIN normally to use the smart card. But in this case, I'm going to use a password to unlock the drive. So I'm going to specify and confirm a password. And I'm going to click Next. Now I need to save the recovery key. So in case I forget that password, I need a way to still decrypt that content. So I can save to a file or print. I'm going to save to a file, and I'll click Next. I'll stick with the default setting of encrypting only used disk space, which is quicker than encrypting the entire drive. So Next. I want to use compatibility mode in case this drive were to be taken out of this host and placed in a different machine, maybe running an older version of Windows. So I'll click Next and start encrypting. Depending on how much data is on the drive will determine how long it takes for BitLocker to do its thing. Even though it's hard to see visually, there's a tiny gray padlock on the drive icon in the left-hand navigator. If I were to right-click on that, I have the option of changing the BitLocker password if I so choose. Maybe if I suspect it's been compromised, or I can choose Manage BitLocker, where for drive letter E, BitLocker is showing as being on, so I could choose to back up the recovery key again. Well, we had the option to change the password in the context menu, remove the password, add a smart card after the fact. I could turn on Auto Unlock or turn off BitLocker. Now what I want to do is observe the behavior if I restart the machine. BitLocker is designed to protect data at rest. So in a web server, for example, if a malicious user were to physically steal a BitLocker protected drive and insert it into another machine, because they don't have the password or the recovery key, they would not be able to get into it. Let's reboot the server to see what happens now that we've enabled BitLocker on that drive. Okay, so now that I've signed back in, let's go ahead and open up the File Explorer once again. Now, drive letter E local disk, if I click on it, it doesn't show me the contents. Instead, it prompts me to enter the password to unlock the drive. Now, if that were an operating system disk protected with BitLocker, the machine wouldn't start unless I enter the password to unlock it. There are ways to get around that by making sure that there is a TPM chip in the machine. TPM can also be virtualized with various virtualization platforms like VMware. It's like a virtual hardware device. If I enter the wrong password in here, naturally, it will not decrypt the drive. So I am protecting the data at rest on drive letter E. Of course, if I enter the correct password, then it will unlock it, and now I have access to the contents of drive letter E. So as it relates to a web application server, you have to determine which type of encryption solution makes the most sense. BitLocker is not going to be the only choice that is appropriate for every possible scenario. However, in many cases, when you're dealing with sensitive data, there will be laws, regulations, security standards that you must be compliant with to protect data at rest. Wireshark is a free open source network analysis tool. You could also say it's a packet capturing tool. It allows you to capture network traffic, whether on a wired or wireless network, and then you can go back and analyze that traffic. It might even be later down the road. You can save your packet capture as a file and then go through it to see if there's any suspicious activity, maybe to troubleshoot network problems, or to see if any Cleartext credentials are being sent over the network, which is really the focus here. We're going to use Wireshark to capture network traffic specifically so we can examine Cleartext credentials sent over the network. It's important to illustrate how easy this is to do, at least if you can place yourself correctly on the network, to reinforce the fact that we really do need to secure network communications. So, for instance, here I'm connected to a sample sign-in page on a website. However, in my browser in the upper left, it says not secure. If I click here, it says your connection is not secure. Any information you enter that's sensitive might be stolen by attackers, so you shouldn't use this. But let's say we don't heed that advice and instead we do. So let's say I'm going to fill in a username of C. Blackwell, and a sample password. Now, before I click the login button, let's go ahead and start a packet capturing session to make sure that we can see what that looks like in Cleartext once we've captured the traffic and we begin analyzing it. Now remember, think about the network layout. In order for a malicious user to capture the network traffic, they have to be able to see it. In modern network switched environments, the only traffic you see for the physical network switch port that you might be plugged into, if that's the type of network you're on, you only see your own traffic, other than broadcasts and multicasts. So unless you're using some kind of technique like ARP cache poisoning to funnel traffic through a device, or if you've enabled switch port mirroring to copy all traffic to a port where you're running the packet capture, it's not just a piece of cake all the time to capture and see all network traffic. So here I've started the free Wireshark tool that I've downloaded and installed, and many attackers would use tools similar to this if they wanted to try to steal credentials over the wire, or it could be wireless, when it comes to stuff that isn't encrypted sent over the network. So I'm going to go ahead and start a capture on my Wi-Fi network adapter by double-clicking, and there you go, we now see some traffic. So let's go ahead and submit that form. So all that means I'm going to do here is click Login. Now it says login failed. Well, that's fine. We don't really care if the login succeeds or not. What we want to do is see if we were able to capture those credentials being sent over the network. So here in Wireshark, I'm going to click the red button to stop my packet capture, and I'm going to filter based on an IP address of the host where that form was submitted, and I'll press enter. Now what I'm really looking at doing is finding those credentials, but where exactly am I going to find those? Well, we could also select HTTP traffic here. Oh, I already see there's a packet, an HTTP GET request for login PHP. Well, having that packet selected, let's see what happens if we click Analyze, Follow TCP Stream. Immediately, I'm already seeing the credentials. It doesn't take very long to follow through this session and see in this case that the username that was submitted is C. Blackwell and that the password that was submitted is test123. Now, we don't want to be lulled into a false sense of security if this is an internal web app that only runs on our internal network and thus we don't need to use HTTPS. We want to use HTTPS at all times, even internally, because we have to think about the concept of zero trust, not trusting anything or anybody, even our internal network. We might have a malicious internal user or a disgruntled former employee. We might have an innocent internal user that has a malware infection on their machine that might be able to capture network traffic like this. So there's never a good reason to use plain old HTTP when you might be submitting sensitive information like login credentials over the network. Now let's say we change our filter here to TLS, Transport Layer Security. So encrypted network traffic, basically over HTTPS. If I select any one of those packets, and let's say we break down the TCP header a little bit here, I see the source port is 443. So that's telling me, unless this is a spoofed packet, that traffic is coming from the web server. We could click on another transmission until we get to the point where we see the destination port is 443. That would be secure traffic being sent to the server over HTTPS. So destination port 443. Okay, well, what else can we see here? Anything of interest? Well, we then have a transport layer security header. And if we take a look at that, there's not really too much we can glean from that other than the fact that there's some encrypted data, HTTP, over TLS. And so instead of seeing plain text transmissions down in the payload, or if we select that packet and again go to Analyze, Follow TCP Stream, it all looks like gobbledygook. In other words, scrambled or encrypted data, which is entirely the point when using HTTPS to connect to a web application. In this demonstration, I'm going to be enabling an HTTPS binding for a Microsoft IIS web server. We know that HTTPS is absolutely crucial in protecting the communication channel between a client and a web application. And so in order to enable HTTPS, we first have to have a PKI certificate. So let's start with that. Here on my Windows server, I'm going to go into my command prompt, CMD, where I'm going to type MMC to launch the Microsoft Management Console. Now, the Microsoft Management Console is basically an empty administrative shell where you can add the snap-ins for the portions of the OS that you wish to administer. So to do that, I'll go to File, Add Remove Snap-in. I'm interested in certificates right now. So I'll select Certificates, I'll click Add, and I want to work with certificates for the local computer account. The local computer is a server where I've already installed the Internet Information Services web server, IIS. So I'll choose Next, Finish, and OK. All right, so what I want to do in the left-hand navigator is go down under Certificates and Personal, and then click on Certificates. We've got a number of certificates shown here with the name of the subject, such as the server common name versus the full DNS name of a server. And we've also got the issuer of the certificate, the certification authority. We have the expiration date of the certificate and the intended purpose of the certificate. So I've got one here with an intended purpose showing as server authentication, and the expiration date of that certificate is in the future, and it's for the DNS name of my host. So if I double click on that certificate, it also says there's a private key that corresponds to it, which is important because your PKI certificate that you install on a web server has to have a public and a private key pair. Stated in simple terms, your web server is going to transmit the public key from the service PKI certificate to the client device. The client device will use that to encrypt a transmission to the server. That will be a transmission of a unique session key generated by the browser, and the server can decrypt the received message with its related private key, thus exposing the unique session key used from that point forward to secure that connection for HTTPS. Anyhow, I'm going to click OK. We know we have a good certificate, so we're good to go. So I don't want to save my MMC console. What I want to do now is go into the Start menu, and under Windows Administrative Tools, I want to fire up the IIS Manager tool. I've already installed the IIS web server role on this host. If it wasn't already installed, I'd have to go ahead and install it. And if I drill down in the left-hand navigator and go under Sites, I've got a default website. If I right-click on it, I can choose Edit Bindings. Currently, it only has a binding on port 80. So let's just go in and take a look at our IP address in the command line here with ipconfig. It's 192.168.4.167. This host actually has multiple network interfaces, and you could choose to bind your web server to either one of them or all of them. The default is all. So if I go to a web browser and enter in that IP address, I get a connection to the default page for IIS. But it's happening over HTTP, which means nothing is encrypted over that connection. Now in this case, we haven't authenticated to the web app, we're not accessing sensitive information. However, the standard these days is to have an HTTPS-enabled web application at all times. It's so easy to configure, and there's really not a good reason not to use it. In fact, some people might shy away from websites that don't use HTTPS, even if you don't have to authenticate or access sensitive information. So it's worth doing. So let's flip back then to the IIS Manager. We're looking at our site bindings. I'm going to click Add. I want to add a binding of type HTTPS. Here's where I can choose the appropriate IP address. The default is the binding applies to all assigned IPs. HTTPS connections normally occur over TCP port 443. We could change that, but that's the default that's been selected here. Down at the bottom, I have to choose the SSL certificate. That in itself is a misnomer. SSL is deprecated. It's just the network security protocol, just like TLS, Transport Layer Security, supersedes SSL. But it's not a TLS certificate, even though often it's called that. TLS is a network security protocol that can use it. Technically, it's a PKI certificate. At any rate, it doesn't really matter. From the drop-down list, what matters is that we understand what we're doing and why we're doing it, and in this case, that we select the correct certificate. So I'm going to select a certificate from the list here and click View. We need to make sure that the certificate is still valid, that it has a private key. Now, in this case, it says at the top that this certificate cannot be verified up to a trusted certification authority because of who it was issued by. It's a self-certified certificate, so it's not trusted by the operating system. We could add the public root certificate for that certificate authority, so it would be trusted. But for what we're doing here in this demonstration, it's okay. I'll click OK, and I'll still leave the port 80 binding, although I could technically select that and remove it so that only 443 is available. I'll click Close. Let's test it out in the web browser. Back here in my web browser, I'm going to click the refresh button. So it's trying to connect to the same page again over HTTP, but this time it says I can't reach it because we removed the port 80 HTTP binding. That makes sense. Let's change the address bar here, the protocol, to HTTPS, and let's press Enter. As you might expect, it says, well, there's something there, but it's not secure because we don't trust the issuer of that server certificate. Well, we expected this. If I click More Information, we can still go on to the web page, which I will do. So now we have a connection to our web app over HTTPS. Of course, in this web browser, it's red at the top, certificate error. If I click on that and click View Certificates, it's the same thing we saw before. It can't verify the issuer of the certificate, the certification authority. So if you're going to be doing this on an internal network, maybe for a line of business web app used only by your employees, you're going to need to make sure that you install the CA certificate on all client devices. Otherwise, they're going to run into this same issue. IPsec, or IP security, is a collection of network security protocols that allow you to secure network traffic. Now, that might sound a lot like using HTTPS for a web application, but the difference is that HTTPS is specific to HTTP web servers for web apps. IPsec can be used to encrypt any type of network traffic, including all local area network traffic, even ping traffic or FTP traffic. Here in my web browser, I've done a simple search for IPsec LAN, and immediately we have numerous hits on how to use it to secure your network. Now, you might wonder, why would I be interested in using IPsec on a LAN? We're talking about web apps. Well, who's to say a web app wouldn't be used internally on an intranet, maybe for a line of business app for employees? This isn't something you would normally use over the internet. Securing web apps over the internet is normally done using HTTPS. But remember, you need to secure the entire ecosystem where your web server resides, and this is one way to do it internally. And I'm going to go into the Start menu and I'm going to type in Firewall. That will let me pop up Windows Defender Firewall with Advanced Security. Now, of course, Windows Defender Firewall can be used to define inbound and outbound rules to allow or deny traffic as it might be. But it's also got connection security rules. Here, we could right-click and build a connection security rule to determine how IPsec should behave. Now, by doing that on this host, we are only configuring IPsec on this host. However, we can also do it centrally through group policy, which would potentially affect multiple computers joined to the Active Directory domain. So from the Start menu, let's open up the Group Policy Management tool. So I'm going to go down under Windows Administrative Tools, and in the G's, sure enough, there's Group Policy Management. Every Active Directory domain has a default domain policy. That's a group policy object, or GPO, that could potentially contain thousands of settings. Now, it's linked or associated with the domain, so by default, it flows down to all organizational units. Unless we've got an organizational unit, or OU, as we do here, that's got block inheritance turned on. That's what that little blue symbol is. So if I right-click, block inheritance means what it says. Do not allow GPO settings from above to be inherited into this OU. And in this case, it's for admins. So let's go ahead and right-click on the default domain policy and choose Edit so we can talk about where to go to configure IPsec connection security rules. That's going to be under Computer Configuration. You have to expand Policies and go to Windows Settings. And under there, you'd then go into Security Settings. This is where the vast majority of Windows security settings are configured in Group Policy. It's at the computer level as opposed to the user level. So the computer that is joined to the Active Directory domain. So I'm going to go down under Windows Defender Firewall with Advanced Security. Just keep drilling down under there so we can see we can specify inbound and outbound rules, just like we could on an individual host, but we can also configure connection security rules. So the difference here is, by default, these rules will apply to all computers in the domain, of course, except where block inheritance has been turned on for OUs. So I'm going to go ahead and right-click on Connection Security Rules and choose New Rule. Depending on your requirements will determine which type of connection you select here. For example, here I'm going to choose server to server. I want to authenticate connections between specified computers. So I'll select that. I'll click Next. It asks if I want to specify IP addresses on each end of the connection. So we can specify specific IPs that would have this affected. So they would get these settings, in other words. I'm going to leave that to any IP address. Then we have the option. How do we want IPsec to be negotiated? Do we want to request it for inbound and outbound connections, or require it for inbound connections, but request authentication for outbound, or require for inbound and outbound? Now, by requiring for both inbound and outbound connections, that means that the hosts affected by this group policy object and these connection security rules, they will only talk to other machines configured similarly. Now, in a highly secured environment, that might make sense. But if the machine, for example, needs to connect to an internet host, that could be a problem if that internet host is not configured with the same IPsec connection security rules. So I'm going to choose request for inbound and outbound. So if a machine that is communicating with a server affected by this doesn't support IPsec, communication will still take place after checking to see if IPsec could be used. So I'm going to go ahead and click Next. We can use a computer certificate to authenticate machines to one another, but I could also click Advanced and choose Customize, and I've got two authentication methods I could select from, where if the first one fails, the second one kicks in. So if I click Add, it can be Computer Kerberos v5. Now that's the Active Directory Authentication Protocol. So for domain-joined computers, that's a good choice. There already is an implied level of trust by virtue of those hosts being joined to Active Directory. You could choose the older NTLM LAN Manager v2 protocol, PKI certificate, or you could use the least secure option, a pre-shared key, where you would put in the same item on both ends of a connection to allow them to communicate. But because in this case, I only want this applicable to domain-joined computers, it just makes sense to use Computer Kerberos v5. So I'm going to click OK and OK, and I'm just going to continue specifying which network location profile that this applies to. I'm going to leave it selected for all, so whether we're joined to an Active Directory domain network, if we're on a private network or public. In the case of a server, servers don't get carried around and moved, at least ideally they wouldn't be. So that probably isn't an issue when it comes to private and public networks. So I'm going to click Next. This is going to be called Request IPsec. Request IPsec. And then I'll click Finish. Now at this point, we've got that configured. Let's just switch back to that detailed screen. We've now got Request IPsec, which is now enabled in Group Policy. Now remember that Group Policy has to refresh before we can expect to see that on machines joined to the domain. So if I were to go back into Windows Defender Firewall and look at connection security rules, I don't see it there. But if I were to refresh Group Policy, so let's go to a command prompt, let's run gp update /force to force a group policy update manually just to test it. You wouldn't want to run to every computer on the network and do this, nor would you want to remote into them. It'll just happen automatically. Normally, the refresh interval is approximately between 60 and 90 minutes. Now that Group Policy has refreshed, if we check Windows Defender Firewall on this individual host, we'll see the Request IPsec connection security rule. And when a session has actually been established between two hosts that support IPsec, you would see it under Monitoring. Now, if you were to capture IPsec traffic, which I have done using the free Wireshark tool, and then let's say we filter the traffic for ESP encapsulating security payload, I have a number of ESP packet transmissions shown in the capture. Now, if I select one of them and go down into the packet headers, so I've got my standard Ethernet header with the source and destination MAC addresses. I've also got the IP header, which has my standard IP address information, among other items, so source and destination IP. But after that, in the IP header, depending on the traffic, I might expect to see maybe a TCP or a UDP header, but I don't even know what type of traffic this is, because what follows is encapsulating security payload. So I've got encapsulation done here where an entire original packet has been encapsulated and new headers have been added. So in this way, the traffic is protected. For all I know, this could be FTP traffic, but due to ESP, encapsulating security payload mode, I don't know what it is. And so the traffic then is secured. In this demonstration, I'm going to be encrypting cloud storage in the Microsoft Azure cloud using Key Vault keys. So I'm going to be creating two resources here in Azure. I'm going to be creating a storage account, and I'm going to be creating a Key Vault. In the Key Vault, I'll generate a key pair that I use to encrypt the storage account. So let's get started here in the Azure portal by clicking Create a Resource, and I'm going to search up Storage Account. I'll select that, and then I'll choose Create. I'll fill in some details, such as the subscription to create this account in, the resource group that I want to deploy this into, and of course, ultimately, the storage account name. I'm going to call this Store Account App 782, and I will deploy it in the Eastern US region. I'll accept the defaults for everything else, but we will just click on encryption up here to take a peek at the default. The default setting for this storage account is that it will be, in fact, be encrypted, except it will be encrypted with Microsoft managed keys. Now, sometimes regulations might stipulate that you must be in control of the decryption keys for data that's protected with encryption. We'll change that after the fact. For now, we'll leave it on Microsoft managed keys, so I'm just going to click Review and Create in the bottom left, and then I'll click the Create button. All right, before you know it, the deployment will be complete. So down under Next Steps, I can click Go to Resource to open up the properties of this storage account. There are really four types of things you can store in an Azure storage account. You can build blob containers, which are like folders on a disk, and then upload blobs, which are essentially just files. You can upload files to be stored in the cloud. You can create a shared folder here in the storage account like you would on a Windows file server. You can work with storage queues. That will be of interest to developers, where they can have software components drop messages into queues that then get picked up and read by other software components. And you can also work with basic key and value table storage. So we're not going to get involved with the content of the storage account, but let's assume that there's some content here and we want to protect it with customer managed keys. So I'm going to click the home link up in the breadcrumb trail, and I'm going to create a resource yet again. This time it's going to be a Key Vault. So I'll search for Key Vault, I'll select Key Vault, and I'll click Create. So in the Azure cloud, the Key Vault is a central storage location, a secured storage location for secrets. Things like usernames and passwords, PKI certificates, encryption keys. So I have to create the vault that will store those things securely. So I will tie it to a subscription and a resource group, and I'll call this KV for Key Vault App East. I'll deploy this in the East US region. I'll stick with the standard pricing tier. Premium would be something you might choose if you must have HSM-backed keys, hardware security module, which is a physical appliance that's tamper-resistant that can store cryptographic secrets and perform cryptographic operations. If you've got regulations that require that type of security, then you would choose Premium. I don't need that, so I'll stick with Standard. I'll choose Review and Create, and I'll choose Create. Okay, so when the deployment is complete, I will click the Go to Resource button to go into the properties of the Key Vault. What I want to do here for starters is check out access policies. We want to make sure that we have access to this storage account. We want to make sure that we have access to manage this Key Vault, and our name is down below with all key, secret, and certificate permissions. So let's go ahead on the left and click Keys, and we're going to click the Generate Import button. I want to generate a key pair. You could import keys that you already have or restore them, but I want to generate a new one. I'm going to call this Store Account Key. It's going to be an RSA 2048-bit key. I'm not going to set an activation or expiration date. I could set a date and time when it can be used and when it no longer is valid, but I'm not going to bother. I just want it available now. And I'm going to make sure that this key pair is enabled, and I'll choose Create. So we now have our Store Account Key. In the left-hand navigator now, if I go to my Storage Accounts view and open up the storage account we created, as I scroll down on the left under Security and Networking, I can choose Encryption. And this is where it's currently set, as we know, to Microsoft Managed Keys. Well, regulations might require us to use keys under our control. Well, we've already got a key in a Key Vault. We just have to point to it from here. So I'm going to choose Customer Managed Keys, and down below, I'm going to click the link to select a key vault and a key. So I'll choose Key Vault. I'll choose our key vault from the list, and I'll choose our key here, Store Account Key, and select. And down below, it's going to create a system-assigned managed identity. That's an underlying Azure Active Directory object that represents this storage account where it can be given permissions such as to access keys from a vault. So I'm going to go ahead and choose Save. And after a moment, the setting has been saved successfully. We can verify this by clicking our bell notification icon in the upper right. It successfully updated our storage account. So we are currently using a customer managed key from our key vault to protect data at rest in this cloud-based storage account. In this demonstration, I'm going to be testing for injection attack vulnerabilities. Now remember, there are a couple of different types of injection attacks. Standards would include things like command injection or a SQL injection. Well, I can use the OWASP ZAP tool to do this, to test for vulnerabilities. ZAP stands for Z Attack Proxy. So the OWASP ZAP tool can be a proxy whereby between a web browser client and a web server and examines the traffic for testing purposes. But I can also launch a vulnerability scan against a web application given a DNS name or an IP address using this tool, and it will tell me if it discovers vulnerabilities, including injection vulnerabilities. So we can download the ZAP tool for Windows or Linux or for the Mac OS for free. Now what we're going to be running the ZAP tool against is the Metasploitable 2 virtual machine. Metasploitable, you recall, is a free downloadable virtual machine where you can set it to low security and you can test various types of vulnerabilities, including injection vulnerabilities. I've installed OWASP ZAP, so from my start menu, I'm going to launch the tool. Now once it loads up, I'm just going to minimize it for a second because I've got my Metasploitable 2 intentionally vulnerable web app virtual machine up and running. And it's running, in my case, on 192.168.4.124. So here it is. Now, what I'm going to do is go into DVWA. That's the Damn Vulnerable Web Application. I'll log in as admin with the password of password because I want to go into the DVWA security item. Currently, by default, this virtual machine is set to high security, which means it's not vulnerable. But what I'm going to do in this case is set it to low and submit it, and it's reflected above here. It says the security level is currently low. Excellent. So now we can run a scan against this, and we know we're going to get results for testing purposes. Results about vulnerabilities in the web application. Now here in the OWASP ZAP tool, if you've previously run a vulnerability scan against a web app, you can go ahead and open it up if you saved it by going to File, Open Session. What you would have done to save it is you would have selected Persist Session. So if I go to Open Session, I can go ahead, for example, and open up anything that I've saved. So there are times when you might want this to run in the background because it can take a while, and then save it and then analyze it at some future point. Just don't wait too long. We want to make sure we analyze it quickly as possible to identify vulnerabilities. But to run a new scan, what I can do here is I can go ahead and click Automated Scan, and I can fill in this case, the IP address or the hostname, if I have that configured, for what I want to scan. And I can determine if I want to use spidering to go and crawl, basically, and discover and test the vulnerabilities using, for example, Firefox headless, which means not the GUI, but the backend engine. Or in my case, I can choose Chrome headless. Now, at this point, I'm ready to go. That's really all I have to do if I want to directly scan a web application for vulnerabilities. Now, these kinds of tools like OWASP ZAP and Burp Suite, not only can they do what we're talking about, web app vulnerability scanning, they can also add as a proxy. So you can monitor traffic from web browser clients, for example, through this tool on its way to the web application and back. And so you can watch what's happening with those requests and responses, even make modifications and send it back out on the wire, that type of thing. Here, we're just scanning for web app vulnerabilities. So I'm going to go ahead and click Attack. Now, immediately under the spider item, we can see it's testing connectivity. It's learning about all of the web pages that are available on that web app, in this case at 192.168.4.124. And as it's running, we'll be able to go to alerts to see if there's any output about problematic issues that we need to focus our attention on. So at this point, I'm just going to go ahead and wait for that to run. And depending on your app and how large it is and how many pages it has and so on, this might take 2 minutes or it might take 2 hours. Now you can go under the Active Scan tab here in OWASP Zap to see whether or not it's completed. You'll have a percentile here. Now it's already completed here, so you can also save this. You can go to File and you can choose to persist the session. So you can open it up at any point and you can analyze it. So at this point, if I click Alerts, I have a full listing of any results that it encountered. Now we are interested primarily in the red flags. Those are alerts of some kind of high severity, whether it's an injection attack or anything else. So for example, cross-site scripting attack, persistent, or otherwise called stored attack. If we open that up, we can see the URLs that were connected to determine whether or not that's a problem. And it looks like the attack that was actually sent was just a JavaScript alert message box. And if that succeeded, then that's why it showed up here as being a problem. And so it talks about cross-site scripting attacks, and also the idea being that we need to make sure that we are validating and sanitizing the input. Now over here on the right in the OWASP Zap tool, I can also get a list of what was actually sent to that. And again, that's kind of a summary of what we saw down below, the JavaScript alert function. So by selecting these things, we can get some details about what kind of vulnerabilities were found within our web application. So as I go further and further down, I've also got external redirect errors, path traversal errors. Now I say errors, what this really means is that it's a weakness, it's a vulnerability that was found within the application. Now this is all very important because we can then focus our energy on solving these problems, hardening these issues. In other words, closing the loop, making sure these security vulnerabilities are no longer vulnerabilities at all. We've got remote command, OS injection. That's another problem. As we go further down, server-side include, SQL injection attack problems. So we know where to focus our work now to harden our application. And remember, it specifically is giving me the URL, so I know which pages we really need to focus on. The OWASP Top 10 for 2021 item A03 is injection. Injection attacks essentially mean that the malicious user can inject some data to the server-side code running on a server that isn't properly being validated, isn't sanitized, in other words, not removing special characters, which could potentially allow a malicious user to supply data to the server that the server will execute and then return information that otherwise really shouldn't be disclosed. So in this case, we're going to focus on a SQL injection attack for a backend SQL database. In my web browser, I've navigated to the IP address for my Metasploitable 2 virtual machine, which I have running on my host. And I'm going to go down and click on the DVWA link. And I'm going to sign in here, as it tells me at the bottom, as admin with the password of password. What I'm interested in doing here is clicking SQL injection over on the left, where we can submit user IDs to the server, and it will search through a SQL database. It will run a SQL query to retrieve information for the user ID that we specify here. Okay, well, that sounds like it could be useful. So if I enter a user ID of 2 and click submit, okay, apparently user ID 2 is Gordon Brown. If I enter 4, it's Pablo Picasso. If I enter 7, well, there's nobody. If I enter 5, it's Bob Smith. Okay. So it's allowing us to enter a user ID, it's passing it to the server runs the query, shows us the user information. Now, if I click the DVWA security link on the left, currently the security for scripts on this server is set to low. Now we can choose between low, medium, and high. Low allows us to test vulnerabilities on this app, whereas high would switch to a high script for all of these attacks, where the high script means that security is properly put in place and the attack will fail. So let's see what that means. So we're going to leave it on low. We're going to go to SQL injection. In the user ID field, I'm going to run 1 equals 1. And each of those ones is enclosed in single quotes. But when I press enter, it doesn't like the syntax, but it is telling me here that I'm running a MySQL server. From a malicious user standpoint, that's narrowing the focus on looking for vulnerabilities with MySQL. We don't have the version string, but we do now know it's a MySQL server in the back end running as the database host. Okay, let's test this a bit here. I'm going to put in 1 single quote, space, or space, single quote, another space, and then single quote equals single quote. So what I'm telling it here, I'm testing the backend database engine to see if it will accept a query where we look for either 1 or equals, which always evaluates to being true. Let's see what happens. I'm going to click submit. Look at this. It's returning everything in the backend database because querying for 1 or equals is always true. This is telling me that there's no proper input validation server side. It's just letting us type whatever we please into the user ID field, and it's using it as part of the SQL query. It's not even sanitizing the input, looking for special characters like quotes and removing them or anything like that. So it's not escaping any weird characters that we might provide. So let's explore the file system web pages that comprise that part of the Metasploitable web application. So here in the Metasploitable Linux VM, I'm going to change directory to var/www/dvwa/vulnerabilities/SQL I for SQL injection. Okay, so I'm going to go into the source directory where we've got our high, low, and medium PHP files. So when we change the security in the web interface, it's switching to one of these scripts, and that is what becomes the index PHP here. Okay, so let's go back into source, and what I want to do is cat the low.php file, pipe it to more. All right, what's happening here? Okay, it looks like it's got an ID variable here. We're getting the ID, and then that ID is simply being used as part of the SQL select statement where it's selecting the first name column, the last name column from a table called users, where the user ID equals whatever we put into that field. Nothing is being checked. No input validation, no escaping of weird characters. This is not good. However, if I were to cat the hi.php and pipe that to more, we've got our $ID variable where we retrieve the ID from the ID field on that form, but then the strip slashes function is being called against our ID that we've entered. Okay, well that's good. Then a MySQL built-in function called MySQL_real_escape_string is being executed, and we are passing it our ID variable. Excellent, we've got some sanitization being done. Then some validation. If is numeric $ID. So if it's a numeric value, because user IDs are numeric, then okay, we're going to run the query. We're going to run the SQL select statement along with the ID. And it continues on through the loop, getting the results of the query. So when we switch to the high security part of the website, it will not simply let us put whatever we want in the ID field and have that run server-side. Let's test it out. So back here in the web app, let's go to DVWA security on the left. Let's switch it to high security, use that script and submit. We know what's in the script. Let's go back to SQL injection. Let's try this again. 1 single quote space or space single quote space single quote equals single quote submit. We get 0 because we are properly validating and sanitizing that input server-side before simply executing the SQL query. We're going to take a look at yet another example of an injection attack. This is item A03 for the OWASP Top 10 2021. So you've got things like SQL injection attacks, where you've got improperly validated input from a user that is fed into a query that returns sensitive information that shouldn't be returned. But in this case, we're going to look at a command injection attack. In other words, we want to somehow manipulate a web server into executing commands of our choice. So let's flip over here to our Metasploitable 2 virtual machine. I've got the web app running, so I've connected to it. And I'm going to click DVWA on the left, and I'm going to sign in as admin with the password of password. What I'm interested in clicking on the left in this example is command execution. So we've got a sample web page here that allows us to ping for free. We just enter the IP address that we want to ping, and the server will do it for us. So we aren't pinging from the machine here that we issue this from. It's going to happen web server side. So if I ping one of Google's DNS servers, let's say 8.8.8.8, okay, after a moment, we've got some returned output where the server has pinged that IP address and we've got the returned echo reply. This did not happen on the local machine where I'm typing this in. This happened from the server's perspective. From a malicious user standpoint, it would make me wonder, what else will it let me execute server side that we're typing into? Is this field validated? Is it being checked for what is being supplied? Really, all it should allow is an IP address, but is that what it will limit itself to? So let's say I'm just going to get it to ping something like its own loopback IP address in IPv4. The local loopback IP address to test your own IP stack is 127.0.0.1. But the thing is, in the Linux command line environment, you can separate multiple commands with a semicolon. So we could then try another command like ls-l, a long listing, let's say, of the root directory, just /. If this field is not being validated properly, it's simply going to take all of this and execute it. And in Linux, you can have a bunch of statements strung together with semicolons. Let's click submit. Well, this is good. It says error. You have entered an invalid IP. That is what we want. That field is being checked. That's because here in the Metasploitable configuration, if I click DVWA security on the left, well, it's set to high security. That's good. That's really how it should be in production. But let's examine what would happen if we set this to low security, which changes the web pages to use a low security version of that app. So submit, go back to command execution on the left, and in that field, 127.0.0.1, semicolon ls-l, long listing of the root directory, submit. Well, what do you know? Not only did it ping the local loopback IP address, but below that, it also did an ls-l, a long listing of the root directory. Now I have a listing of the files and directories at the root of the file system on the web server that ran this command to return the output to my web browser page. This is a problem. Here in the Linux command line on the web server, I've already navigated to /var/www/dvwa/vulnerabilities for this intentionally vulnerable web application that we're using for our testing. If I do an ls here, I've got a subdirectory called exec for command execution. So I'm going to change directory to exec and clear the screen, do an ls. The index PHP that is currently set up here will depend on whether we've set high, medium, or low security. So if I go change directory into the source location in here and do an ls, this is where we've got the high, low, and medium security pages for this particular exploit example. If I were to cat low.php, here we've got a PHP page that runs server side where an HTTP post is being submitted to the web server where we're requesting the IP address. That's the IP address that we can ping on that example web page. And it's actually then running the shell_exec PHP function to run a command line tool like ping, and we are passing it $target. $target is simply whatever we typed into that field. And then we're returning the result of that command into the HTML page. So nothing is being checked. The user-supplied input could contain anything, and it's going to try to ping it, which means it could run a multitude of commands here in Linux. Whereas, if we clear the screen and cat the hi.php file, let's scroll back up and take a peek at what's happening in this particular case. Okay, we still have the same construct here in PHP for submitting an HTTP post. We've got the target variable requesting the IP, but then it's using the PHP strip slashes function to remove any slashes that might be present in the user-supplied input, so that's a good first step. Then we've got a comment, and PHP comments, or at least single-line comments, are prefixed with 2 slashes. Check if each octet of the IP address is an integer. And it's doing that by calling upon the is_numeric function. Now, we've got an octet variable that is established above by exploding apart the IP address by separating each chunk based on the dot delimiter. And of course, there's a dot between each of the 4 parts of an IPv4 address. And we're checking each one. It's an array. So the first item is item 0, the next is item 1, item 2, item 3. It starts counting at 0. We're checking each one to make sure they're numeric. And we're making sure that the size of the octet variable is that we have 4 items, 4 parts of an IP address, no more, no less. Then, if they're all integers, we're putting it back together. The target variable is putting back each of those 4 items, octet items 0, 1, 2, and 3. And then, of course, it continues on actually executing the command, pinging the target IP, generating some HTML and returning it back to the browser. So this would be one way to properly check that what was supplied in that field is what is required, which is an IPv4 address, 4 octets long, each separated by a period, nothing less, nothing more. In this demonstration, I am going to execute a cross-site scripting or XSS attack through a web page form. Now, with cross-site scripting, there are a few variations on how this attack can actually be executed, as is usually the case with any of these types of things. Specifically, what I'm going to be doing is submitting a stored or persistent XSS attack. Now, a stored or persistent attack is called as such because it means that the attacker somehow has injected malicious code that is stored server-side. Hence, it's persistent. And the way that it's going to work in this particular example is the attacker will take advantage of an input form, so a web form with a field that's not being properly validated, where they can inject JavaScript. Now, JavaScript doesn't run server-side, but it can be stored server-side so that when others pull up that web page, that JavaScript can execute in their client-side web browser. And if you've done any work with JavaScript, you'll be aware that it can be quite powerful when it comes to things like cookie manipulation and doing things in the local web browser instance. Luckily, these days, many web browsers, if they're new and kept patched, are sandboxed. So you can't just break out of the web browser and get to the underlying operating system, at least not easily. It's possible. So here on the Metasploitable 2 web page, my insecure web app server, I'm going to click DVWA on the left and sign in as admin with the password of password. Now notice on the left in the menu of attacks that I can test, I've got XSS reflected and also XSS stored. So cross-site scripting stored is what we're going to focus on. Cross-site scripting or XSS reflected attacks are a little bit different. The idea is that a user is somehow tricked to click a link, and the link itself is targeted to a different website that it's designed to attack or somehow compromise. So in this case, it's going to be XSS stored. I'll click on that. So we've got a web form here with 2 fields. Imagine this might be on some kind of a forum website or a blogging site of some kind where people might submit information. They could submit their name and some kind of a message. In this case, it's for signing a guest book type of app. So for the name, maybe I'll specify something like C. Blackwell. And for the message, you would normally type in a message that you want to include when you're signing the guest book. However, if this message field is not properly validated, then malicious users might be able to inject scripting code like JavaScript, and if it's a stored cross-site scripting attack, it would be stored server-side so that when others come to view the guestbook and look at this particular entry, the JavaScript simply executes on their machine. With JavaScript gets embedded in HTML, we use the script opening tag, so embedded within a less than and a greater than sign, and then we have a closing one, which is really pretty much the same, except it's got a slash in front of the word script. And whatever code you want executed goes between. This is where you put your JavaScript code. It might be just a little bit, might be simple, could be very long and complex. In this case, all I'm going to do is run the alert function, which displays a message box. And I'll have it say, hello there, close the parentheses and semicolon. Normally, attackers will do something a little more covert. Instead of displaying a message which might alert a user that something is happening on their client machine, it might do something in the background without any kind of indication visually at all. Maybe it's manipulating cookies on the user's browser machine or something like that. In any case, I'm going to click Sign Guestbook. Okay, so immediately it executes and it says hello there, but let's click OK. So we've now got an entry here. Of course, the message isn't filled in. To really make this appear benign, malicious actors would normally add a message as well. But if we click on something else and then come back to that page, the JavaScript executes immediately. JavaScript executes in the client web browser. It does not run server-side. Java itself runs server-side. Active server pages and PHP, that's all server-side code. This runs in the client browser. And so for attacks that are trying to target something on the client side, either directly or indirectly, such as through a reflected cross-site scripting attack, this can be particularly worrisome. Here in the file system of my Metasploitable Linux virtual machine, I've already gone into var www, dvwa, vulnerabilities. If I do an ls, we've got two cross-site scripting subdirectories, one with _r for reflected and the other for _s for stored, which is what we want to look at. Change directory xss _s clear. And like all of the other file system structures for these attacks, for this intentionally vulnerable web app, we've got the current index PHP. So depending on the security level in the app, we'll determine what that exactly looks like. But that comes from the source folder, where as usual, we've got a high, low, and medium.php file. So if we set the website to high security, the high PHP becomes index PHP, the active one. And alternatively, if we were to choose low security, then that becomes the index PHP. Let's take a look at them. So cat low.php. Okay, so we've got a message variable and also a name variable, which corresponds to the two fields on the input form. And they're both being trimmed, which means remove leading and trailing and extra spaces. Okay, that's a good idea. Then we've got a comment here to sanitize message input. So it's using our message variable, which refers to the message field, and it's running the strip/php function. We pass it the $message variable. It's also running the MySQL _real _escape _string function. Again, we pass it the $message variable. That's good, but not quite complete, and you'll see why in a moment. Then the name field, or variable, which references the field, is also being sanitized. All of that is good, and then of course the query to add an item to a MySQL database is executing using the insert into syntax, where the comment and name fields or columns in the underlying table are being filled with the values from our $message and $name variables. Okay, that's all good and dandy. However, let's cat the hi.php one. What's different here is the HTML special characters PHP function that's being used, and we're passing it our $message variable to remove special characters like the greater than and the less than signs, which is required to embed a JavaScript tag within HTML. Right, so back here in our web browser, let's try this out. Let's go to DVWA security. Let's set the security to high, submit. Let's go back to XSS stored. Let's try this again. C Blackwell, and I'll put in the exact same JavaScript I did before, and I'll click sign guest book. Well, notice the difference down here. Instead of embedding the JavaScript so that it would actually execute, as was the case with our first example, in this case, instead of having an actual less than sign for the opening script tag, the HTML special characters PHP function has instead converted that to and LT for less than. And respectively, instead of a greater than symbol, we have and GT for greater than. That way, it's not treated as embedded executable JavaScript within HTML. This demonstration is all about how to hijack a web browser session for an active user. And there are many things that we can do through that type of connection. We could display whatever's happening on their web camera. We could play a sound on the remote machine, check the plugins in their browser. Perhaps, depending on what's installed on the machine and how unpatched it is, perhaps even browse the remote file system. So we can compromise a web browser then using cross-site scripting types of attacks, basically tricking users into following a link or clicking on a link that hooks their browser and makes it available in a central command center, so to speak, where attackers can issue these commands against hooked or victim browsers. So to do this, we're going to be using the BEEF tool. BEEF is short for the Browser Exploitation Framework. Now here I've got my Linux machine. It happens to be Kali Linux. It could be any distribution of Linux really, because even the newest versions of Kali don't seem to have the BEEF tool installed. So from a command prompt on that server, The first thing we should always do is run sudo apt update to make sure that all of the package repositories this machine points to are up to date, so that when we issue a command to install something, it's checking the latest locations. And we could do that with sudo apt install, and in this case, the package I want is beef-xss, and I'll press enter. So we've already got it installed here. I've already done this to save time, but if you haven't, you'll have to answer the letter Y for yes to allow it to perform the installation. Now, normally when you do the installation, it will start the beef service automatically. What I could do to force this to run is run sudo. It needs to run with elevated root permissions. I could tell it I want to run beef-xss with the -h parameter. Now here it says something's already using port 3000. That's the default port number that it binds to. So it just shows us now that the beef daemon is up and running. Let's just flip back to our terminal window for a second. So it's loaded the beef service, and if I go back to the web page that it automatically opened up, it's going to port 3000/UI/authentication. I'm going to run this on my Windows 10 computer in Microsoft Edge, where I know there's more support for running a lot of these vulnerabilities. So here in a web browser window, I can connect to the IP where we're running the beef service. So what we need to do essentially is trick a user into visiting this URL. This URL is pointing to the IP of our beef server, port 3000/hook.js or JavaScript. You could also head over /UI/panel at that site. And if you're prompted to sign in with the beef username and password, it's normally beef for the username, and beef is normally the password, but you might be prompted to change it during the installation. Either way, once you've signed in, you can click the basic demo page link, which says here, and the web browser is now hooked into the beef console. Now, any malicious user that wants to try to control hooked browsers will do it by connecting to port 3000/UI panel. It switched the URL here for me, so if I sign in with the beef credentials, it takes me into this screen where on the left, I'll have a list of online browsers that have been hooked, as well as offline. So if I click on any of the online browsers, we'll have all of the capabilities shown over here on the right, which includes things such as the host name or IP address, even the screen resolution, so the window size and height for the browser, the number of CPU cores, the type of CPU or GPU information. In this case, it's telling us it's a Windows 10 computer, 64-bit, so there's a lot of details here. The Logs tab shows me any activity related to that victim web browser being hooked. If I go to the Network tab, I can get a quick diagram of where that machine might exist over the network. So we've got our hooked browser shown here connected to beef on the same subnet. If I click the Commands tab, then here I have a list of categories for different types of commands for the machine that I've selected on the left. That machine on the left is a hooked or a hijacked web browser. Now remember, that happens because one way or another we are tricking somebody into executing that hook JavaScript URL. At the end of the day, the best mitigation against this type of thing is user security training. And of course, limiting which devices can get on the network and having strong firewall rules, all of that stuff. So for this hooked machine, I'm going to open up the Commands Browser category. And just for fun, why don't we play a sound? So we could specify a URL, a port number, as well as a WAV file that we want to play on the target machine. And what we would do to actually execute that is just click the execute button down in the bottom right. Now, when you issue these commands, you'll get something in the module results history. And if I click on it, I'll get the output. Here it tells me that the sound was played on that remote machine. Same thing goes for things like webcam. Here, if I want to try to trick a user into clicking something to allow access to their webcam, then we can have this fake information about the website using Adobe Flash pop up. You've probably seen this if you've been on the internet a lot, these fake sites that don't look legitimate and state that they need Adobe Flash to be installed. So I can change any of the details for this, but if I just want to go ahead and click execute, it's being sent to the compromised web browser. And this is the type of thing that you would see. So it's just a way to trick users into enabling things in their web browsers to allow further compromise. Now, there are all kinds of different categories of these modules that you can run. The ones that are green will most likely work in the target system. If it's red, it won't. If it's orange, then it might. Usually the gray ones mean that there's no support for it. So if I want to detect a pop-up blocker and go ahead and click execute over on the right, and then after a moment, and it might take a moment to get the results back, when I look at the results of the command, apparently a pop-up blocker is enabled on that machine. It's set to a value of true. If I go down to host, down on the left, I could even do things like get geolocation. Where physically is that hijacked browser? So I could choose one of these APIs available on the internet, and I could click execute. So not only will we have information about the compromised web browser that we've hijacked, not only can we do things like try to trick people into enabling features, but we can also pinpoint where they are geographically. So if I click on the result of that command, I will have the details over on the right on exactly where that browser is. Now, of course, if the user is using an anonymizing browser or network VPN solution, then this might not be accurate, but it's a good starting point. I could even choose Get Internal IP. Not just the public IP as being reported on the internet, which is usually the public IP of the public interface for the NAT router. So if I look at the result of command 1, if the command will execute and we give it enough time, we will get the results here. Notice that this one is orange, so it may or may not work. If I go down, let's say, to the miscellaneous category, if I were to choose raw JavaScript, here it wants to run some JavaScript that will pop up on the machine. Maybe I'll have it say, hello, there. So this is what we're going to see in the victim machine. Of course, it could be much more sophisticated than this, but the point is that we are invoking JavaScript remotely that is executing on a compromised client web browser. I'll just click OK to accept that message. Back in the Beef control panel, that command that we've just sent, the result is that it worked. If the user signed into Gmail, we could attempt to read Gmail messages. So the list goes on and on and on of the interesting things that you might do against a compromised web browser. So this is one of the reasons why it's absolutely paramount that web browsers be kept up to date, that users receive periodic security training, that you have strong firewalls in place on every device and at the network perimeter, that network encryption is being used, that you have some kind of security incident monitoring solution in place. This is one of those types of security issues that can indirectly affect the security of your web applications that you might be hosting. All it takes is one client computer on your network where that website is hosted to be compromised in order for your website to potentially be compromised. And that's why this is such a big deal. These days, there are a lot of websites that are hosted in the public cloud environment, whether it's Amazon Web Services or Google Cloud Platform, Microsoft Azure, to name just a few. And so as a result, it's important that we are aware of security controls that can be put in place to secure our cloud computing environment, including the hosted web apps. This is the Cloud Controls Matrix, or the CCM page for the Cloud Security Alliance, CSA. Now I'm going to go ahead and download the Cloud Control Matrix so we can take a look at some of the categories of security controls and some of the security controls themselves that should be put in place. Now, as this is being updated all the time, make sure you come and visit this frequently to get the latest version. Here it's going to be version 4. So I just have to go down and fill out a couple of quick little questions before I can download it. So what you will have downloaded is a zip file. So I'm just going to go ahead and extract it using whichever tool I have available to extract zip files. And I'm interested in the CCM file, Cloud Controls Matrix. I'm going to go ahead and double click that and open it in Microsoft Excel. Okay, so the CCM then serves as a reference for cloud technicians when it comes to securing their cloud environment. So we have a number of worksheets at the bottom, including CCM. This is where we have what are called control domains. The first one is audit and assurance, and specific controls that can be put in place, such as independent assessments. And each control is assigned a unique control ID according to the CCM. And this is an accepted global standard for securing cloud computing. For the control specification, it'll provide some further detail, in this case, running independent audit and assurance assessments at least annually. So it's still quite general, but it serves as a reminder that we can tweak to our own specific requirements. As I go over to the right, we can see where the responsibility lies in the cloud, such as for Platform as a Service, or PaaS. It says shared responsibility. That means that the cloud service provider, which controls the underlying infrastructure and hardware on which our hosted web apps run, they are responsible for having periodic security assessments, But shared means that we as cloud customers are also responsible for conducting our own security assessments on the services that we are running on cloud provider platforms, like hosting websites. As I go further down, we then get to the application and interface security control domain. For instance, we have one control title that states application security baseline requirements. So the specification spells out that we should establish, document, and maintain baseline requirements for securing our apps. A baseline is a standard of normalcy of what is accepted when it comes to security for a web app. Maybe the security baseline that you would set up when scanning web apps in the organization is that directory listings must be turned off for all web apps. HTTPS must be used. Perhaps centralized authentication is required. There are no anonymous web pages that are allowed. So maybe that's part of your security baseline. So depending on which type of assessment tool you run periodically will determine exactly where you specify those details so that you can identify outliers or non-compliant web apps that need to be addressed right away, because they fall outside of the scope of the security baseline. Further down, we have another control for secure application design and development that should be applied at all SDLC or software development lifecycle phases. Automated application security testing. We've touched upon this topic already. It could be such that when developers do a code check-in for code that they checked out previously to modify, that when they check it in, it automatically triggers a test. And if that test succeeds, it might automatically trigger that component or software to be packaged up and made available, maybe notifications sent off to subscribers of that app. So at the very least, the Cloud Controls Matrix, the CCM, can serve at least as a good guide or a reference point. It gives us things to think about on how we might want to modify our security policy and how it relates to cloud-hosted web applications. One great way to test changes to a web application running in the Microsoft Azure cloud while keeping a production copy of the site running all the time is to use a deployment slot. Now, you can create one or more deployment slots for a single web application. What you're really doing is creating a different URL for the web app, and developers could connect to a separate URL where they could then manage the code in the web app and the content, the files, make changes, and test it, all using a different URL than the production version of the website, which remains up and running. And unbeknownst to the users of the web app, developers are making changes and testing it elsewhere. So in order for this to work, we need to have an existing web application in the Microsoft Azure cloud. Basically, it lets you have a testing or staging version of a web app, as well as a production one, all at the same time. Here in the Azure portal, in the left-hand navigator, I'm going to go down to App Services. This is what Azure calls a web application that is running or is being hosted in the Azure cloud. And I've got one called Web App YHZ1, and currently the status of that web app is that it is up and running. So if I click to open up its properties, and then if I click the Browse button, it opens up a web browser window separately where it shows me the page for that web app. Now, not every web app is going to have a home page with a user interface. Some might run as some kind of background service used by other web app components. But this one does, and it is up and running. And also, it is accessible over HTTPS by default. I could stop the website, restart it, delete it. However, what I want to do here on the left under deployment is go to deployment slots. The production version of the web app is its own deployment slot called, no surprise here, production, as shown in our list of deployment slots. And that's fine. But what I want to do is I want to add a deployment slot because I have a need to make changes to the web app periodically, maybe update features, fix bugs, whatever the case might be, but I don't want to have to bring down the production version of the web app to test or implement those. So I'm going to click the Add Slot button up at the top, and I'm going to create a slot called Testing. Now, what it will do is it will create a new URL for what is essentially a different version of the web app, and the new URL will include the name of the slot. So the web app is called Web App YHZ1, and normally the DNS suffix is .azurewebsites.net. That's the default. You can use a custom DNS domain name, but that's a different topic. But what happened here is it renamed the web app at the DNS level to Web App YHZ1 /testing. Testing is the name of my new deployment slot. And then the DNS suffix of .azurewebsites.net follows. So it's a different DNS name is really all we're saying. We can choose to clone the settings from the production version of the web app, things like database connection strings and so on if required. But this is a very basic web app. I don't have that, so I'm not going to clone the settings, and I'll click Add. Okay, so it's successfully created my slot named Testing. I'll click Close, and now Testing shows up down below. So it's got my web app name -testing as a running deployment slot. Now, currently, 100% of the traffic is going to the production URL for my web app, the production version of the app. So what software developers would do then when they want to make changes, fix bugs, add features to the web app, is they could do it to the testing slot. When I click on the link for the name of that deployment slot, it takes me into its properties. I get a new navigator over on the left, and it's important to take note of the fact that it says app service and in parentheses slot. Of course, we have the name of our deployment slot testing. So this isn't the production version of the web app, it's the testing one. And in the overview section, which is selected on the left, over on the right, notice that the URL for this deployment slot includes the name of it, -testing. And so if I browse to it, so we do have our web app running at that deployment slot. Of course, our production web app is still up and running. Now, what we could do after developers have connected to this URL, this deployment slot for the web app, and made changes and tested them, and they're satisfied that the changes are ready for production, what you can do is use the swap button up at the top to swap the production default slot with the testing. So the testing slot we're working with, where we've made changes and tested it thoroughly, will become the new production slot, new version of the web app. So we could click swap. For source, I'll choose my deployment slot. The target will be the real production slot, the default production slot. If there were any source and target config changes that would be shown in the summary down below, I'm going to go ahead and click the swap button. Okay, and that's how quick and easy it is. We have a message that states that it successfully completed the swap between the slot testing and slot production. And this is all transparent to users of the app. They're still connecting to the same URL they always did, which if I go back to my web app, the production web app slot, which is currently running, now would reflect changes that was made to the testing slot because we just swapped out the slots. So this is a great way to deal with testing and to minimize downtime of a web application. In this demo, I'm going to be working with Docker on the Ubuntu Linux platform. Docker is an engine that allows you to work with application containers. You can work with Docker container images and launch containers from them. You can also pull container images from other image repositories. You can push your own custom container images to repositories you have access to. So what we're going to be doing here in Ubuntu Linux is beginning by installing the Docker component. To do that, I'll start with the sudo command, so I can run this as a privileged command, because I'm not logged in as root. If I were to type in the whoami command, I'm logged in as a user called C Blackwell, so I don't have root privileges, hence the need for prefixing with sudo, S-U-D-O. Then I'll run apt-get install docker.io. Docker.io is the package I want to install. That's the Docker server, the Docker engine. So it's in the midst of being installed now. So once that's done, I'll clear the screen, and I'm just going to run sudo docker with no parameters to see if it recognizes the command, and it does. So we know then that Docker is installed. If I were to run sudo service docker status, it shows me that the Docker container engine is active and up and running. So if I enter the sudo docker images command, we have no local images on this on-premises Ubuntu Docker server. Out on the internet, we can navigate to many different types of container repositories or container registries where we can search for container images and then even pull them down to our Docker machine and begin working with them. Here I'm at hub.docker.com. Now you can create a free account and sign in, but I'm just going to go ahead and search, let's say for MySQL, to see what they've got for container images for that. And there's one right away called MySQL. It's the official image. If I click directly on it, it gives me the details about it, and it even gives me the command line syntax to pull the image down to my local machine, such as docker pull MySQL. So we could search for quite a variety of different items in order to be able to pull down container images and run various tools, even pre-configured applications. Here I've searched for Caddy, which is a very small, lightweight, open source web server. And again, if I click on it to go into the details, it tells me that Docker pull Caddy is how I can bring down this small open source web server app. Well, why don't we give that a try back here in Ubuntu Linux? sudo docker pull Caddy. Now, I don't have to tell it where to pull this from because unless otherwise specified in the name of the container image as a prefix, it will assume I'm talking about the Docker Hub repository online. So it's pulling down that container image. Naturally, depending on how big it is, will determine how long it takes. It looks like it's done. So if I were to run sudo docker images again, this time we've got Caddy, the latest version of that container image. So to run a container from that container image, the syntax would look like this. sudo docker run, let's say -d to run it in the background. -p, I want to map port 80 in the container to port 80 on this host because I know that there is a web server stack in that container. Not every container has that, but I do know that this one does. And the last parameter is the name of the image, which we know is Caddy. Okay, it looks good. So if I were to type ifconfig, let's say, to get our IP address information, it looks like our IP is 192.168.4.154. Why don't we navigate to that in a web browser? Okay, and just like that, we've got our little Caddy sample web application, where it then gives me instructions on the web page itself on how I can customize this to suit my own needs. But the point is, we have a web server stack in the container up and running on our Docker server. Let's say we want to push that into our Azure Container Registry. Back here in the Azure portal, I'm still in the properties of my container registry. So on the left, if I click Quick Start, it gives me the instructions on what to do to begin actually interacting with this container registry. Step 1 is to install Docker. Well, we've done that. Then step 2 is to run a hello world image. Well, we don't need to do that. This is what I want. Log into your container registry. It gives me the specific syntax. I'm going to go ahead and copy that. And I'm going to run that here in my on-premises Ubuntu Linux machine. It then asks for a username. Well, if I go to access keys over here in the portal on the left, the username is the name of the container registry, in this case, Project A, and we can specify one of these two passwords. I'll just copy the first one. Okay, so I'll sign in as Project A, and I'll paste in the password. So I'm going to run sudo docker login projecta.azurecr.io. Then it asks for the username. Well, over here on the left in the properties of my container registry, I'll go to access keys, where the username here is Project A, so it's the name of the container registry, and I can use either of these two passwords to authenticate. So let's log in here, Project A, and I'll paste in that password and press enter. Okay, login is successful. So we are now authenticated to our Project A Azure Container Registry. And actually, before I clear the screen, I'm going to copy that DNS name. The reason is because if I were to run sudo docker images, currently our image is simply called Caddy. Well, when you want to push it up to a repository, you have to rename it or tag it so that the prefix of the name of the container image is the name of the repository you want to push it up to. Here's what I mean. sudo docker tag, it's called Caddy right now, but what I want to call it is projecta.azurecr.io, that's the name of my registry, /caddies, the container image, and latest version. So we're just renaming it with this command. Let's press enter. And I'll use the up arrow key to go back to sudo docker images. We still have our original version of our container image that we pulled down from Docker Hub, but here's the one that I just named. At this point, all I have to do is run sudo docker push and then specify the name of my newly tagged Docker container image. And it's on its way. It's being pushed into the Azure cloud as we speak. And that's it. Let's check our work in the Azure portal. So back here in the properties of my container registry on the left, I'm going to scroll down and click repositories, and there it is. Caddy is now showing as a container image in here. If I click on it, we've got the latest version of it. You can have multiple versions of a given container image. So now other developers could use the docker pull command to pull this container image to their machines. Ideally, this would be a customized and tweaked container image. We might have installed developer tools and files and whatever it is that we need in our environment to make application development quicker and easier. These days, larger web applications are normally broken down into smaller segments or components with function-specific tasks, and these are called microservices. And often, developers are choosing to run microservices nowadays in an application container. So in other words, a modern application, a web app, might consist of one or more containers working together. So in this particular example, what I'm going to be doing is deploying a container registry in the Microsoft Azure cloud. As you might guess, a container registry is like a centralized repository, and what it would contain are container images from which we can launch containers. It's kind of like having a centralized repository of operating system images that you would use to deploy that OS to machines. The same type of thing is true with the container registry. Now, the great thing about doing this in the cloud is that it's a managed service, which means I don't need to worry about setting up the virtual machine and the operating system and the software to make this all work. I just deploy it and it's ready to go. So let's see how that works. Here in the Azure portal, I'm going to click Create a Resource in the upper left, and I'm going to search for container registry, and I'll just choose that from the list, and I'll choose Create. As usual in Microsoft Azure, I have to specify a subscription for billing purposes for this item I'm creating. I only have one. I'm going to deploy this into an existing resource group, which is simply used to organize related cloud resources, and I have to give the registry a name. So if I'm going to be working with application containers for a specific project, let's say it's called Project A, perhaps I would call the registry Project A, and it will add .azurecr.io as a DNS suffix. That stands for Azure Container Registry. I'm not going to change anything like the location or the SKU, so I'll just click Next for networking, where because I didn't choose the premium SKU, I don't have the option of controlling the visibility of this container registry. So it's going to be publicly accessible. If I click Next, in the same way, because I didn't choose the premium SKU, then I don't have the encryption option. So that's fine for this case. I'll choose Review and Create. After a moment, the deployment is complete, so I can click Go to Resource to open up the properties of my newly created container registry. And if I scroll down on the left and click on Access Keys, here I can enable the admin user, where I've got an admin username and 2 passwords. Either one can be used, you don't need to use both at the same time, to authenticate to the container registry. So maybe software developers would have this information so they could push container images they've customized up to this repository, or pull down container images so they could work with it as a running container. Now you have 2 passwords because over time, periodically, you should change or regenerate a new password. So you might do that for password 2. Password 1, we'll call it, would still be valid, but password 2, because you've regenerated it, is no longer valid. You'd have to supply the new password. So it's just a way to keep things secure by rotating things periodically. If I scroll down on the left under Services, I can click Repositories, and this is where if I have any container images, they would show up here. We're going to be using Docker running on Ubuntu Linux on premises to push a container image up here in a moment. The other thing to watch out for here from a security perspective over on the left is if I click Access Control IAM, I can click Add Role Assignment, and I have a lot of Azure Container Registry or ACR specific roles, which are collections of permissions, like being able to push container images into the repository or registry, and being able to pull from the registry, so ACR push, ACR pull. These are roles I could assign to other cloud technicians that have a user account in Azure Active Directory. Or maybe I would assign the permissions from the role to a managed identity that represents a virtual machine running code that needs to talk to the container registry. It could be any of those things. At any rate, let's close out of this. So we've got our container registry. Let's flip over to Ubuntu Linux running on premises, where I've got Docker running. So here in Ubuntu Linux, I'm going to run the sudo service docker status command to make sure that the Docker engine is up and running. And it is. It says active and running. So I'll press Q to quit out of that. Next thing I'm going to do is run the sudo docker pull, and I'm going to pull a container image called Alpine, which is a small, lightweight Linux-based container. I'm going to pull that from Docker Hub. So unless you specify otherwise, it's pulling it from the Docker Hub repository on the internet. And so if I run sudo docker images, besides any other images I might have had locally, I now have a container image called Alpine. And I could run that with sudo docker run, let's say -it, so interactive in a terminal, and it's called Alpine. And what that does is it puts me in a command prompt for that Linux-based container image. I'm not in my local Linux machine anymore. If I type ls, I'm viewing the file system within the Alpine container. If I type exit and type ls, now I'm back in Ubuntu Linux where I've got whatever it is that exists in my file system. I'm going to use sudo docker tag, which allows me to rename a local container image. And I want to rename Alpine to project.a.azurecr.io. That's the DNS name of my Azure Container Registry /Alpine : and I want it to be the latest version. So now if I run sudo docker images, I will have a third container image. The original Alpine container image remains as it was. You need to prefix the name of a container image with the name of the repository or registry that you want to push it up to. And you can push it up there after you've logged in to your Azure Container Registry. I can do that with sudo docker login and then give it the name of my registry. Now I'm already signed in, so it didn't ask me for a username and a password, but if it does, here's where you find that information. Here in the portal, in the properties of your container registry, if you click Access Keys on the left, we've enabled the admin user, so the username would be Project A, and you could use either of these two passwords to authenticate. So now that we're authenticated to that container registry, we can do the following. We can run sudo docker push, and then I'll specify the newly tagged or newly renamed container image. So I'm pushing it to that registry. And it's on its way. It's being uploaded to my Azure Container Registry over the internet. Back here in the Azure portal, we can check our work by going into the properties of our container registry, which is where we are, and then clicking repositories on the left. And there's Alpine. If I click on Alpine, it's showing as the latest version. So we've successfully created an Azure Container Registry, and we've successfully pushed up a container image to that registry. One of the great things about most cloud providers is that they make it very easy to deploy IT services in the cloud without having to provision underlying virtual machines and storage and all of that stuff. It's a managed service, so they make it very quick and easy. In this case, we're going to use the Microsoft Azure Cloud to deploy an Azure container instance. In other words, I just want to run an application container in the cloud as quickly as possible with the least amount of fuss. So to do that here in the portal, I'll click Create a Resource, and I'm going to search for Container Instance. I'll choose Container Instances, and I'll click Create. So I will associate this new container instance to a subscription and to a resource group, and I'm going to call this container AppYHZ172. I'll deploy it in East US, and then I can determine where I want to get an image, a container image from, to run as an Azure container instance. It can be quick start images, so we've got some standard Hello World examples that are based on Linux containers or Windows containers, such as a sample web server. Or I could choose an Azure Container Registry if I've created one, and I do have one called Project A, from which I can then select from the images that I might have uploaded into that container registry, or I can specify other registry, whether it be public or private, where I could specify, for example, a container image I wanted to pull down from Docker Hub, such as MySQL. So because I haven't specified a prefix, which would include things like a container registry, it assumes I want to pull this down from Docker Hub. But I'm going to choose one of my container images from Azure Container Registry. Let's say I'm going to choose the Caddy lightweight open source web server image and the latest version of it. So it's designed to run on Linux. And I can change the size of this container instance. There's going to be an underlying virtual machine in the cloud running this, even though we don't have direct access to manage that virtual machine. So it's 1 vCPU, 1.5 gig of memory, but I could change that if I needed to. That'll be fine to accommodate this sample workload. I'll click Next for networking. So public is the default networking type, which will create a public IP address for my container instance, so it's accessible over the internet. You may not want that, but in this case, if it's a public-facing web app component that should allow direct connectivity from the internet, then of course it would make sense to do that. I'll leave that as it is. I'm just going to click Review and Create, and then I'll click the Create button. That's it. That's all you need to do to get a container up and running in the Azure cloud. All right, so after a moment, the deployment is complete. I'll click the Go to Resource button to go into the properties of that container instance, where on the left, I can click on Containers. And we've got our container shown in a running state. If I go to the Overview blade, I've got a public IP address as per our configuration. I'm going to go ahead and copy that to the clipboard. I'm going to open up a new web browser window and paste that in. And what it does is it shows me, in this case, the web application running within that container. Not every application container is going to have a web server or a front-end interface for users, but this one does, and this is what is popping up. So let's deploy another container instance, but with a container image from Docker Hub. So I'm going to choose Create a Resource. Once again, I'm going to search for a container instance, and I'll choose that from the list, and I'll click Create. I'll deploy this into a resource group. This time I'm going to call it app YHC173. And down below for the image source, I'm going to choose Other Registry, and I'm going to type in MySQL. Now, if I go to hub.docker.com and search for MySQL, there's actually an official image for it. If I click on the link for the official image, it's actually simply called MySQL. So Docker Hub is implied unless you otherwise specify a container registry as part of the name of the container image, but that's all I need here. So I'm just going to go ahead and choose Review and Create. I'm not going to specify anything else, and I'll click Create. All right, the deployment is complete. So once again, I'll click the Go to Resource button to go into the properties of this container instance. And when I go to the Containers view on the left, our MySQL server is in the midst of starting, so the state currently shows waiting. Let's go to our All Resources view over on the left. Here's where I've got app YHC172. That's what we deployed first. And if I go to Containers, once again, we've got a running container, which is our Caddy web application. All I'm going to do here is select Connect down at the bottom. And I'm going to choose /bin/sh. I know that's the type of shell within that container. That container contains a Caddy lightweight open source web server, which is based on Linux. So there is a Linux shell environment available within the container that I can interact with from here. So I could choose Connect, and now I'm in. So if I do ls, we would be dealing with whatever files are in that file system, cd space ... to go back in the file system. So if I need to manipulate files and manage that type of thing, I can go ahead and do it by interacting directly with the container if the container supports this. Not every container is the same, but this one happens to support this feature. Microsoft Group Policy was introduced way back in Windows 2000. Prior to that, it was called System Policy. What it does is it allows us to have a centralized location with numerous settings that we can apply to either some or all users and computers. Specifically, we can centrally do that with an Active Directory domain. So as long as computers are joined to that domain, they can partake potentially in any group policy settings that we might configure. But it's important to note that group policy is really broken down into settings that apply to users, regardless of which station they log on to, and then there are settings that apply to the station that's joined to the domain, regardless of who is logging in. And there are literally thousands of group policy settings. Not every one of them is related to security, but that's going to be our focus here, because if you're using a Microsoft Active Directory domain, then you can harden your environment centrally using group policy. It's not the only thing you can do, or should do, but it's a part of an overall security solution. And of course, the first thing you should do whenever you get messages about updates being available is, in accordance with your organizational policy related to such things, maybe test them in a sandbox environment and then get them deployed as soon as possible upon approval. So here on my server, I'm going to open the Start menu and I'm going to go under Windows Administrative Tools, because what I'm looking for in the Gs is the Group Policy Management option. The server I'm doing this at is an Active Directory domain controller. So it has a replica or a copy of the Active Directory domain database, which contains things like user accounts, groups, and it's associated with group policy settings, that type of thing. You don't have to set group policy from an Active Directory domain controller computer. Any machine can have this tool installed. As long as you authenticate to that domain, you'll be able to manage it if you have the permissions to do so. So I'm going to start Group Policy Management. Now, what I see in the left-hand navigator in this tool is a hierarchy of my Active Directory environment. My Active Directory domain is called quick24x7test.info. So it looks like a DNS name. That's normal. And then I have a couple of organizational units, or otherwise called OUs. The default domain controller's OU contains domain controller computer accounts. But I've got an OU here that I've created called East, into which I could then create users and join computers to the domain that are in the Eastern region. I can also expand group policy objects, which are also called GPOs, These are the items, each of which contain potentially thousands of settings, which could be used to harden our environment, because not all settings in a GPO are related to security, but there are quite a few of them. In my particular setup, if I look indented underneath my Active Directory domain name, I have the default domain policy, which also shows up under group policy objects. The difference being, under my domain, it's showing up indented under it, which means that that policy is associated with my Active Directory domain. Whatever settings are in the default domain policy will apply to everything in my Active Directory domain. It will flow down to all of these OUs. Now, technically on an OU, you could right-click and block inheritance of settings that it might have inherited from above. By default, that's not on, and therefore that's why we say settings flow down through the Active Directory hierarchy. So what I'm going to do is right-click on East, and I'm going to choose Create a GPO in this domain and link it here. So I'm doing two things at once, creating a group policy object, and it will be linked to the East OU. And I'm going to create a new GPO because I want some security settings that only apply to this part of the Active Directory hierarchy. I'm going to call it East Security Settings, and then I'll choose OK. There's our East Security Settings GPO, and as you might guess, it also shows up down under Group Policy Objects. So I'm going to right-click on East Security Settings and choose Edit, which is going to open the Group Policy Management Editor. So this is where we can edit the thousands of settings split between computers and users. Most security settings are really at the computer level. Under User Configuration, if I expand Policies, under Software Settings, we got some software installation items we can configure. Under Windows Settings, I've got security settings, but really, I've got public key policies, so dealing with certificates and what's trusted. And if you recall, when we discussed self-signed certificates for a web application, maybe an intranet website used by employees, by default, self-signed certificates are not trusted by client devices. You have to install a trusted root on them all so that they'll trust the issuer of the certificate. Well, you could do that centrally with one configuration here in Group Policy under Public Key Policies. However, what I'm going to do here is under Computer Configuration at the top, I'll expand Policies. I'll go to Windows Settings. It too has security settings, but notice there are many more options available. Under Account Policies, for example, I could set a password policy. You want to be careful with this because technically password policy settings only work in a GPO linked at the domain level. Even though it shows up here, this is assigned or associated or linked, whatever term you want to use, to the East OU. You can set these password policy settings, but they aren't going to do anything. That only works at the domain level. However, other settings like local policies, auditing settings, maybe what I want to do is audit object access. Now this works with file systems on Windows servers. So if I go in and say I want to audit the failure when people attempt to do something in the file system, and then I could click OK. Now that goes hand in hand with settings in the file system. So for instance, if I were to go down into the file system on this server, let's say, look at some sample files. I've got a sample files folder. I want to set auditing on that. So I'm going to right click, go to the properties, go to security, go to advanced, and then click the auditing tab. This is where I could add who I want to audit. So for example, select a principal. Maybe I want to audit everyone. And maybe what I want to do is modify any writes made to files in this location. So I would just click OK. Now, what we're doing then in Group Policy is we're saying that we want to apply audit object access. We only want to know when there's a failure, in this case, from someone in the Everyone group, the built-in Everyone group, when they try to write. The thing to bear in mind is that file servers where you want this to happen, their accounts need to exist in the East OU. Let's just go to the Start menu and open up Windows Administrative Tools and open up the Active Directory Users and Computers tool. In the East OU, all I've got are a couple of user accounts. My auditing configuration will affect no servers. Of course, if I were to move a server or servers into East, then they would be affected by our GPO settings related to auditing. So always think about these things, how they all work together. That's only one type of security item. We've got a number of security options, such as renaming the built-in guest account, as well as not displaying the last signed-in username, the user that signed into this machine, or forcing log-off if log-on hours kick in for a given user account. Maybe you don't want people logged on after 6 p.m., so you can force that to happen even if they're already logged in before that time comes around. For security reasons, you might clear virtual memory swap files or page files when systems are restarted. We could even go to system services. Remember, part of hardening an environment is disabling unused components. So maybe what we want to do here for servers affected by this GPO is we want to go into Worldwide Web Publishing Service, that's the IIS web server. We want to define the policy setting and we want to disable the web server service because those machines should not have a web server running. Those are perhaps controlled separately in a different OU, or maybe they're running on Linux hosts. I could go down under Windows Defender Firewall with advanced security, and I could actually define inbound or outbound firewall rules to control inbound and outbound traffic to machines affected by this GPO. Connection security rules, well, this is where I could configure an IPsec policy centrally in group policy that would affect machines in Active Directory, specifically machines in the East OU or under it somewhere. So we have a number of security settings then that we can configure centrally in group policy that could potentially apply to all machines and users in the domain, for example, if it was done in the default domain policy. One important way to make sure web applications are as hardened or secured as they can be is to make sure the environment that they run in, the network environment, which could include other network devices, other network hosts, other web servers running different web apps. All of those need to be secure in order for a web app to be secure. Of course, we still have to make sure secure coding guidelines are adhered to and whatnot. Well, in the Azure cloud, we can use Azure Policy to check for security compliance, whether it's compliance for encrypted virtual machine disks or database encryption being enabled or disaster recovery being enabled for VMs, whatever the case might be. To get started here in the Azure portal, I'm going to search for Azure Policy up in the search bar, and I'll choose Policy. That will open up the Policy Management console. The way that this works is we first have to be aware of the policy definitions that we can assign to the Azure hierarchy. Now, you can have custom policies in Azure that are built, or you can use built-in ones. You might also notice in the definition type column, besides just the word policy, you'll also come across things like initiative. A policy initiative is a collection of related policies grouped together. For example, for NIST type of compliance, you can assign a built-in initiative, which is really itself a collection of related policies. Now, I can also filter this list. For example, I'm going to search for the word encrypt, and all of the policies that have encrypt somewhere in their name will show up. For example, managed disks, which are disk resources in the cloud that get attached to virtual machines, should be double encrypted with platform managed keys, that's Microsoft managed keys, as well as customer managed keys. I can also filter on other items. For example, I'm going to search for the word disaster. And I've got this one called Audit Virtual Machines Without Disaster Recovery Configured. Now, that's part of the CIA security triad, where the A stands for availability. Disaster recovery means that we want an easy way to be able to fail over to a copy of a virtual machine running in an alternate or secondary geographical region if the first one fails or becomes inaccessible for some reason. So I'm going to click to open up that policy. And in here, I could click Assign to assign this to a scope of the hierarchy in Azure. However, if I go to the Assignments view, I could also create an assignment from here. I could choose Assign Policy. And for the scope, if I click the Scope selector, I could select a management group. The default tenant root group is shown here, but I can create additional management groups under which I can then organize subscriptions. Let's actually duplicate our web browser window and examine that for a second. Here in the portal at the top, if I search for management group, I can go into my management groups, and we have our default tenant root group under which we have our pay-as-you-go subscription. Now, the idea is that if you have numerous subscriptions, you can organize them in some way under different management groups. For example, I'm going to create a management group called East 1. That will also be the display name, and I'll click Submit. Okay, so East 1 shows up here kind of like a subdirectory under a parent folder if we were talking about a file system. The idea is that I can then use the selector to the far right of the pay-as-you-go subscription, or any type of subscription, and click Move, and in this case, move it to East 1, save, and refresh. And now, if I expand East 1, there's the subscription. Why is this relevant? Well, let's get back to our policy assignment. Just going to refresh my web browser window and get back to assigning a policy where I click the Scope Selector button, and now I can choose the East 1 management group. That means the policy that I assign here would flow down to all of the subscriptions under East 1 and ultimately to all the resources in the subscription. So if we're still talking about auditing virtual machines for disaster recovery, it would audit every virtual machine in every subscription. Or of course, I could choose a specific subscription only, or I could even drill down to a particular resource group and have it examine or audit virtual machines only deployed in that resource group, which I will do here. I'll select RG1. I'll click Select. I can also specify exclusions. If I click on the selector for that, I can choose specific resources I want excluded from this audit, but I don't want to do that. I want everything in RG1 to be audited. Now we have to select the policy definition here. So once again, I'm going to search for disaster. There we go. Audit virtual machines without disaster recovery configured. Select, and I'll review and create that policy assignment, and I'll click Create. So the audit virtual machines without disaster recovery configured policy is assigned to my resource group. Depending on how many resources you have in your subscription, or subscriptions, if the scope selection was a management group, will determine how long this really will take. So if I go to the compliance view, and I'll just click refresh, it might take a few minutes until we see our new policy assignment and the results of the compliance audit shown here. After a few minutes, my audit virtual machine policy assignment shows up, and the compliance state shows here non-compliant, and it's got a value of 1 in terms of number of non-compliant cloud resources. Let's click on that to open it up. And if I scroll down, I'll see the resources that are not compliant. In this case, a virtual machine called WinServe1-WebApp1. Now from here, I could click the link for the virtual machine, and I could go and enable whatever it is I need to enable on it to make it compliant. So to do that, I would click the View Resource button at the top, which puts me in the properties for that virtual machine. And if I scroll down in the left-hand navigator, down under Operations, here we have Disaster Recovery, which I can enable for this VM. Again, basically creating a replica of it in a secondary geographical region. So compliance checks, especially when they're automated, are absolutely critical in ensuring that the entire ecosystem surrounding a web application is properly hardened. IT technicians should be aware of CVEs, common vulnerabilities and exposures. This is available at cve.mitre.org on the internet, and it's a central repository of known vulnerabilities, and it's always kept up to date. Now, these are vulnerabilities that would apply to a wide variety of IT solutions, whether it's client web browser plugins or web server stack or operating system based. Here on the CVE website, we've got some tweets related to new problems discovered with cross-site scripting or XSS bugs in GitHub repositories. However, notice that there is a message at the top here that says there's a transition to the new CVE website, which will become www.cve.org. And if I follow that, the site is actually up and running and available. Here we have the ability to report vulnerabilities. And when a vulnerability is discovered and reported, you have to request a unique CVE ID. We'll take a look at some soon. So here at the top, we can search for CVEs based on the CVE ID, but it says go to cve.mitre.org if you want to search by keyword. Okay, so back here in the cve.mitre.org site, I can choose Search CVE List. And if I were to search for XSS, as in cross-site scripting, and click Submit, then after a few moments, we will get a list of all of the CVEs related to cross-site scripting issues. Now notice the CVE name consists of CVE, then the year, and then an occurrence of a vulnerability within that year. So if I were to click on any of these CVEs, it would give me more details about this exposure or this problem with cross-site scripting. There are always reference links here that you can follow to learn more about this problem, and some of them will also have comments shown at the very bottom. So we can search on any number of potential issues. For example, if I were to click Search CVE List again, and if I were to look for buffer overflow, then we would get nothing but buffer overflow CVEs that we could take a look at. And as I scroll down through this list, notice that there are plenty of them. And as I go further and further down the list, we're going further and further back in time. Right now, we're looking at 2014. But one of the crazy things about this is that even some problems that existed way back, let's say in 2014, will still in some cases be out there. That's why malicious actors will continuously scan the internet looking for vulnerable hosts. Not everybody keeps things up to date. Every now and then there's a server that everybody forgot about, whether it's physical or virtual. No one has assumed responsibility for it, and as a result, it's not patched. That's how these things can still be effective. Let's go to the new CVE website, because we also, over in the news section on the right, can read the latest information about CVEs, like the CVE list download formats changing. If I go to the downloads link at the top, I then have a number of formats that I can download my CVE records in. So CSV, comma separated value, HTML, text, XML. So I'm going to go ahead and download the all items HTML file so we can take a look at it. Okay, so if you download that file, it's quite large. It's just an HTML file, which is really just a bunch of text, but the size here is 198 megabytes and a bit of change. So what I'm going to do is go ahead and open that up in my web browser. So this is what we have, stemming all the way back to the first CVE in 1999, numbered as 0001, where it's talking about BSD Unix and the TCP/IP network stack that can allow malicious users to cause a server crash or hang by sending certain types of packets that are crafted in a particular way to that host. But we can also perform searches here. For example, I'm going to search for Apache struts. Now, we've mentioned this a few times in this series where we're talking about the Java framework that runs server-side that's used by many web applications that had some known serious vulnerabilities in the past. So let's go through and see what we can find about that here in our CVE document. So we've even found the first occurrence, one of 4 here, that stems all the way back to 2005. There's a cross-site scripting or XSS vulnerability in Apache struts, and of course, what's important here? The version. We need to know what version of these types of web server stack components that we are running. Now, if we know we're using the Microsoft Internet Information Services or IIS web server, then we could search on it. Of course, we want to make sure that we're looking at the current version that would apply to whatever we are using in our environment. And finally, back here on the cve.mitre.org website, if you go to the data feeds link at the top, you'll have a way to subscribe to a variety of different types of feeds, such as a JSON vulnerability feed or an RSS vulnerability feed. Or if you want to subscribe to the CVE Twitter account, if you use Twitter, there are plenty of ways that you can be notified when there are new vulnerabilities that are discovered. In this demonstration, the focus will be on how to harden a back-end database. Now, you could have a database that you manually install the software for and configure a server on premises. You could do the same thing with a virtual machine in the cloud, or you could deploy a database as a managed service, which is what I'm going to do here in Microsoft Azure. What this means is all I do is specify the database details, in essence, and it takes care of provisioning the underlying virtual machines and the software for me. We're going to do that, and we're going to talk about hardening options while we deploy the database and afterwards. So to get started here in the Azure portal, I'm going to click Create a Resource. And under Popular Azure Services, I'm going to select Create under SQL Database. Okay, so I'm asked to fill in a lot of details like the subscription, where I want this deployed. I'm going to deploy this into an existing resource group, and I have to give the database a name. So I'm going to follow organizational naming standards to give this database a name. Now, what I have to do in the cloud here is I have to tie this SQL database to a SQL server. If I already have a SQL Server resource created in Azure, I can just go ahead and select it in the list. But it says no available items, so I don't have a server. So I'm going to have to click Create Server. So to be clear, I'm creating 2 things here. I'm creating a SQL Server resource in the Azure cloud, and I am creating a database. So for server, I'll click Create New. That takes me into the Create SQL Database Server screen. So assuming this database server will host a multitude of SQL databases, I'll just call this Apps Quick 24x7, assuming my organization is called Quick 24x7. And what it will do is add the .database.windows.net DNS domain suffix. I'll deploy this server in East US. For authentication method, I'm going to stick with standard SQL authentication. I'm not going to integrate it with Azure AD or anything like that. So I'll specify the SQL Server admin credentials, and then I'll click the OK button. So that takes care of the SQL Server, which now shows up in the server drop-down list. We've just defined it. So we're back to creating the SQL database. Now, if I'm going to be hosting a multitude of databases, and I want them to have a pool of resources that they share among themselves, resources like underlying compute power, I could configure a SQL Elastic pool, but I'll leave it on the default of no. So speaking of compute power, we have compute and storage options here, which is configurable. So right now it's set to generation 5, 2 vCores, 32 gigabytes of storage. I could click configure database and make alternative changes to the underlying horsepower. But I'm okay with this, so I'll just click the X in the upper right. Down below for backup storage redundancy, it's already set to geo-redundant backup storage, which means backups across regions in case there's a failure or a disruption in one region. That's great. Next, networking. Okay, part of hardening a database is determining from which locations that database is accessible. So the default here is no access. We could make this database publicly accessible, but there are security risks with that because essentially it's a public IP address that will be available over the internet, and so it might be subject to things like port scans and malicious user attempts to break in. We could also have a private endpoint that's available, which would also allow you to access it, for example, through a VPN link to the Azure cloud. To facilitate this demo, I'm going to leave it on public endpoint, but bear in mind you have to think about this carefully in testing and production to make sure you limit from which networks the database can be seen. So then we've got firewall rules here. Do we want to allow Azure services and resources to access this server? In other words, do you have a front-end web app, perhaps, that needs to talk to this as a back-end database? For now, I'm going to leave that on no, but I can go back and configure this after the fact. Do I want to add the current client IP address? If I go to whatismyip.com, my current public IP address is shown here. That's normally the public interface for your NAT router, depending on how your network is configured. So therefore, I want to add that because this is the machine, this is the location specifically I will be managing my SQL database from. So I'm going to choose yes so that it does that. And I can always change that after the fact here in the portal. The connection policy is set to default, but we have two other options. We could use proxy, which means that you would have an Azure SQL database gateway deployed through which all connections are proxied to get to the endpoint database. That's a safe thing to do, but it increases network latency. It reduces throughput, but it's safer. Or redirect. Clients talk directly to the node hosting the database. Now, the default selection, as it says here, uses a redirect policy for client connections that originate inside Azure and proxy for external connections. That sounds like a good choice, but I could change it if I needed to, either here, during the deployment, or afterwards. Now, this is a good default setting down below for encrypted connections. It sets the minimum TLS version to TLS version 1.2. TLS versions 1.1 and 1.0 are considered insecure and should not be used. There are known vulnerabilities. So that's great. TLS 1.2 it is. Next, for security. Now, if you want to conduct periodic vulnerability assessments against your database, you can enable a feature called Microsoft Defender for SQL. Now, you can set up a 30-day free trial period, and then it will switch to $15 per server per month. That would definitely be a part of hardening any environment in IT is conducting periodic vulnerability assessments. Now, from there, of course, you might learn of weaknesses that you could use to harden the system in a more specific way, to close certain security holes or patch things that need patching to make them more secure. Now, we also discussed CIA, the CIA security triad, where the I stands for integrity. Can we be assured of the trustworthiness of data to make sure it's not been tampered with? Here in SQL Database in the Azure Cloud, you can enable the Ledger option, which verifies the integrity of data in the database. Another way to harden working with SQL databases in the cloud is to use managed identities. What this means is that managed identities represent Azure resources in Azure Active Directory to which you can then assign permissions. In other words, if we have a piece of code running in a virtual machine in the cloud, that needs to talk to this SQL database, we do not want to embed database connection details, especially credentials, in the code. Not only is it hard to manage and track over time, it's not a secure solution. Instead, we could just have our code running in a virtual machine without credentials, but the virtual machine object would have been granted permissions to the database using role-based access control in Azure. And then we've got transparent data encryption, or TDE. And that's certainly not specific to the Azure cloud. That's long been a staple of working with SQL servers and databases to encrypt the database content, database backups, and logs. Now, it's called transparent because it means we don't have to make any changes to any of our database code, any stored procedures or triggers or anything like that. Now, right now, it says Service Managed Key Selection, Configure Transparent Data Encryption. If I click that link, I can opt to use a customer managed key. So I could click the Change Key button, and I could go into a key vault, and then I could select a key I might have created in a key vault so that the key is under my control. Because the default is it's service managed. In other words, it's under Microsoft's control. And that might violate certain regulations or contractual obligations, whatever the case might be. However, I'm not going to change any of these things, but it's important to note that they are here. I'll click Next, Additional Settings. So if I want to start with a blank database, I would leave it on None, or I could choose to restore a previous database backup to populate the new database I'm creating, or just use sample data. I'll leave it on None. I can also set the maintenance window time frame where updates can be applied. And then if I were to go to Next Tags, I don't have to specify anything here. That would take us to the point where we could review and create the database, and we have a cost per month of running this. So if we were to deploy this database, all of the security-related settings that we just talked about for hardening the database would still be available and could be changed at any point in time. Yet another possible security vulnerability on your network would be devices that are vulnerable. And the devices might not even be tied directly to your web application server or your database server at all. But if they are compromised, then that could allow an attacker to execute lateral movement techniques on the network to ultimately scan and discover and potentially break into a web server. So it's important then to know or have an inventory of every device on the network and what its purpose is and have some details about it. In this particular demo, I'm on the internet on the Shodan.io website. This allows me to search for devices that are visible to the internet, even those that are vulnerable with known vulnerabilities or with default credentials. Whether it's an SSH Linux host, whether it's a wireless router, whether it's a security camera system in a home, whether it's a baby monitor, any type of IoT device, they'll show up here. So, needless to say, very intriguing indeed. So I'm going to go ahead and click the Explore link up at the top. Here we have categories for devices that we could check out on the internet, whether they're video game consoles, network infrastructure devices, database servers, even industrial control systems to control things like oil refineries, manufacturing processes, water pressure and valve state, all of that type of stuff. And you've got a lot of common searches that are shown over here on the right, like webcam, netcam, default password. Now, there's an interesting one because that would be considered a type of security misconfiguration. I'm going to click on default password. So right away, we have something that apparently might be vulnerable to default credentials in Indonesia, specifically in Jakarta. So we could take that IP address and explore it further, such as in a web browser or using a variety of tools. The thing to watch out for is that you're not crossing that line, whether it's ethical, whether it's legal. Just because something is potentially vulnerable over the internet and you know how to get into it, doesn't necessarily mean that it's okay to do that. Usually, without express permission of the system owner, or if you've been hired by a company to perform penetration tests against their equipment, it's generally frowned upon. So as we scroll down through the list, we have a number of devices that are potentially susceptible to default credentials. So if I were to click the IP address for one of these items, it gives me more details about that device, such as the fact that the country for this device is the Russian Federation. I've got the city, the organization, even the ISP. So here we've got the fact that there are 2 open ports, 53, which is normally used for DNS queries, and 10,001. Although we can't be sure unless we were to dig deeper, port 10,001 is used by some various types of security camera manufacturers. Let's go back to our list. Notice that if we were to scroll up and look at some of the stats on the left, some of the top operating systems showing up here include Windows Server 2012 R2, Windows Server 2012 R2. That's a 10-year-old operating system, yet it still shows up here. There's still a lot of old stuff out there, which is why we end up with a lot of security compromises. I'm going to go back one level and go into the databases category. And let's say I'm interested in exploring MySQL databases that were discovered over the internet. Now notice for some of these filters, it requires you to log in. You can create an account for free. So I'm going to go ahead and log in. I've already done this. So now when I go to explore MySQL, I get some results. Interestingly, over on the left, it's been graphed geographically, meaning that we can see the number of discovered items in the United States, Germany, China, Hong Kong, and so on. So if I were to scroll down and click on the IP address for another discovered host here, this one has a lot of open ports, like port 22 for SSH, 53 for DNS, port 80 for HTTP, port 110 for POP3 mail services, 443 for HTTPS, 3306, which is usually used by MySQL. And if I click on that, it shows MySQL, but we also have a version string. And if I click on that, it adds it to my little filter list so I can search for MySQL version strings that match that specifically. And they're all shown here in the list. Again, if I start clicking on those, I can just drill down further and further to learn more about this device exposed out to the internet. We've got port 21 on TCP here for FTP. So there's an FTP daemon that it looks like it's allowing anonymous user logins. Bear in mind that even if you do authenticate with FTP, that's sent in clear text. As I go down on the left, I get a list of CVE numbered vulnerabilities for this particular host. Things related to OpenSSH. Okay, so there's a lot that can be learned then by going to the Shodan.io website. This just gives us a sense of what kind of vulnerabilities might exist on devices out there, and it reinforces the fact that we need to inventory and harden the devices in our ecosystem where our web app is being supported. In this demonstration, the focus will be on how to hash credentials. Now, some Unix and Linux operating systems by default will hash user credentials and store them in a file. Let's examine that a little bit here. So here I'm using Kali Linux, but really it could be any distribution of Linux. I'm going to start here by changing directory to /etc, where you'll find most config files either in this directory or in a subdirectory. One of the things I want to focus on is the shadow file. Clear the screen. So I'm going to cat the shadow file, and I'm going to pipe that to more to stop after the first screenful of output. Now I get a permission denied, and that's because this is a secured file. It contains important secured hashed passwords. And so I need to run sudo in front of that to run this as an elevated or privileged command, to run it as root, basically. So sudo cat shadow, and again, pipe it to more, and this time it works fine. It's asking for my current user password. I'll enter that in. So what we are looking at here is a list of user accounts along with some password expiration information, but in the second field, we'll have a representation of a hashed password if any exists. For example, if I look at user Kali way towards the bottom, each field is separated with a full colon delimiter. And what follows in the second place is the hashed password for the user Kali. Now the password is actually Kali, K-A-L-I, and it resulted in this hash. So when a user specifies username Kali with a password of Kali, the password of Kali is passed through the same hashing algorithm that generated this hash, and if the hashes match, it means the user knows the password. Okay, so let's add a new user account here. I'm going to go ahead and run sudo user add, and we're going to add user C Blackwell. So if I were to tail the /etc/password file spelled PASSWD, this contains user account information as well as things like the user ID, the ID of their primary group, their home directory, but it does not contain their password. That's in the shadow file. Okay, so let's sudo, because the shadow file is protected. we're going to run tail to show us the last couple of lines of /etc shadow. So C Blackwell is here, but what we have in the second position is an exclamation mark. In other words, there is no password. So I'm going to run sudo password, spelled PASSWD, for C Blackwell. We're going to set a password for that user account. I'll enter the password, and I will then retype it or confirm it. All right, and we get a message that the password was updated successfully. Let's use the up arrow key to tail the etc shadow file once again. Notice this time in the second position, we now have the password hash for user C Blackwell. So if I were to try to log in as user C Blackwell, I can do that with su, the switch user command, and I'll put in dash, which means I want to run a full login environment for that user, which would mean executing scripts. And I'll specify the username of C Blackwell. If you don't specify a username, you're switching to user root. So you would have to know the root password. Well, I know C Blackwell's password. Let's just test it out. So when I enter the password here, it's going to be fed through the one-way hashing algorithm compared to the etc shadow entry for C Blackwell. And if it's good, then I will be logged in. So if I type, who am I? Indeed, I am successfully now logged in as user C Blackwell. I'll just type exit to get back to my regular Kali user account. Now, another way that the password hash for the user is affected is when you lock the account. For example, if I run sudo usermod to modify user, C Blackwell is the user I want to change. I want to use -L to lock the account. So let's tail /etc/password again. Well, that hasn't changed. It's just the regular user account file. There's no password here because that's in shadow. So let's tail /etc shadow to see if anything's different. So let's run sudo tail /etc shadow to see if anything's different. What's interesting here is C Blackwell's password hash begins with an exclamation mark here. The exclamation mark implies that the password hash has been invalidated, in this case because the account is locked. If I were to run sudo usermod C Blackwell -u for unlock, let's clear the screen and let's tail etc shadow again. Notice that the exclamation mark at the beginning of the password hash has disappeared. Now we're back to having a valid password hash for user C Blackwell, which of course will allow authentication by that user. Modern password hashing, such as with most distributions of Linux these days, will also use salting. Salting also adds some randomized data to make it much more difficult to try to crack the password hash. Traditionally, what has been used to crack password hashes is what's called a rainbow table. Here I've gone to freerainbowtables.com, and we've got all kinds of variations on different types of rainbow tables with mixed alphanumeric with spaces or symbols and passwords. Essentially, what we have are pre-computed hashes that we can compare to what's, for example, in the etc shadow file. But in the rainbow table, we also have the origin password that resulted in that hash. So we could download these password hash tables if we're a malicious attacker and compare them to password hashes, which would be one way to crack what the original user password was. A crucial part of securing today's network communications is encrypting those communications, or at least encrypting stuff that is sensitive, like logon credentials, or maybe encrypting entire sessions, or maybe putting everything through a VPN tunnel, which means it's encrypted. In this particular case, when it comes to encrypting credentials over the network, we're going to start by talking about SSH or secure shell. Here in the free Wireshark packet capturing tool, I've got an SSH packet capture. I can actually filter for SSH by typing SSH as the protocol in the bar at the top. It turns green, and then I press enter. So all I'm doing now is looking at SSH traffic. I've got the source and destination IP addresses. I've got the length of the transmission, a bit of information. Of course, if I select any one of these packets down below in the center, I can expand the packet headers. So I've got the Ethernet header here, where we've got the source and destination MAC addresses. We've got the IPv4 protocol being shown as being the next header. Now remember that the MAC address is a 48-bit hexadecimal unique address assigned to a network interface. But the MAC address is only used locally on the local area network. The IP address allows us to talk to a device on a remote network. So following the Ethernet header, we have the Internet Protocol or IP header. And if I expand that, we have a number of fields, like the version, in this case, version 4, the total length of it, this particular header in this case. And as we go further down, we have things like the time to live or the TTL. The TTL value in the IP header is set differently depending on the type of device or operating system. But what is consistent is that each time this transmission goes through a router, the routing device will decrement the TTL value by at least 1. Once the TTL value has been decremented to nothing, then the packet is discarded and is no longer routed. The IP header also specifies that in this case, the next higher level header is TCP. And then, of course, in the IP header, we have the source and destination IP addresses. So notice so far that none of this is encrypted. We have not encrypted, at least with this transmission, the packet headers. And notice what we've selected up at the top is an SSH v2 transmission, which does allow encrypted secure communications. It just doesn't encrypt the packet headers. Let's continue on through. Let's take a look at the TCP or the Transmission Control Protocol header. In the same way, we've got all of the fields here. So the source port is a higher level port from the client. The destination port here is port 22 because that's normally what SSH listens on by default. Then we have a number of other fields that are available. The point is that the TCP header is also not encrypted. Then we start getting down into some details like the actual payload of this transmission, where if we start selecting some of that, we get a sense here of some different cipher information that's being exchanged. Normally what happens is when a client talks to a server of some kind, they negotiate what types of protocols they each support, whether it's for hashing like SHA-1, or whether it's triple DES or AES-128 for encryption. And finally, as I actually go down and drill down into the SSH protocol header, it's at this point that we realize we can't make sense of what's actually happening in the transmission down in the data portion of the payload. And if we start selecting varying packets, the same thing will be true. It just looks like a bunch of different characters. Every now and then you might see some ciphers referenced, but this is an encrypted transmission. And so we are providing confidentiality over the network through encryption here when managing devices using Secure Shell or SSH. But SSH isn't the only way to encrypt credentials over the network. Still in Wireshark, here I've got a different packet capture opened up. What I want to focus on here is TLS, or Transport Layer Security. So we have a number of different types of transmissions here, TCP transmissions, but eventually we'll get to the point where we have some TLS version 1.2. Now, versions of TLS prior to 1.2 should not be used as there are known security vulnerabilities that affect them. So what we could do is filter for TLS here just by typing TLS in the filtering bar at the top. I'll press enter. Now all we're looking at is TLS traffic. So we've got client hello traffic to the server, server hello traffic along with certificate information. Now remember, with TLS, what we're really talking about is the server sending its public key to the client. So we've got some key exchange information happening here. Now the server's public key is given to the client device because the client is going to generate a unique session key. But we need a secure way to send that session key to the server because the session key is a symmetric key. It's the same key that's used to encrypt that is used to decrypt. Both sides of the connection must have the session key. So when the client generates it, it will encrypt the session key with the server's public key that it was given. And the server will decrypt that on its end with the related private key. So now both parties would have that unique session key, which is further then used for encryption. So as we go through the TLS handshake, we get to the point where if we actually broke down the headers within that transmission, in this particular case, it's using a loopback adapter on a device with IP version 6, after which we have a TCP header and ultimately our Transport Layer Security or TLS header. Of course, we have to look at the ports that are being used here in the TCP header. In this particular packet I've selected, the source port is 443. That's normally used by HTTPS. So a web server stack with a certificate configured and an HTTPS binding. and it's talking back to the client on a high-level port, in this case 10,500, but that will vary. But the point is this: as we step through this, we can't really tell what's happening in the packet payload because TLS is encrypting the transmissions. In this demonstration, I'm going to be analyzing plain text transmissions using the free Wireshark packet capturing and network analysis tool. Now, when we talk about plain text transmissions, we're talking about stuff that is not encrypted. Now, that's especially a problem when we are talking about usernames and passwords, so credential sets or any other type of sensitive information that might be transmitted. But the fact is that a lot of older network protocols, or even some newer standards, if not configured correctly, still transmit in plain text. So in this case, we're going to talk about Telnet. The old Telnet standard, and it's still out there in use in some cases, it is a server-side listening daemon. It can also be enabled on a lot of network infrastructure devices. It listens on port 23 for remote management connections. It gives a remote command prompt on the target host as if you were at it directly typing in commands. And so this used to be widely used to remotely manage things like network switches and routers and Unix and Linux hosts. But the problem is that it transmits everything in plain text. If we were to select a Telnet packet from this packet capture and examine the headers, in this case, we've got the standard Ethernet header with the source and destination MAC addresses. We're using IP4 in this case, so we've got an IPv4 header with all the standard fields, including the source and destination IP addresses, followed by the TCP header. Telnet uses TCP as a transport mechanism, not UDP. And in the TCP header, we have the destination port here of 23. So this is a transmission from a client going to a Telnet daemon running on some kind of a device. The source port number is always higher to talk back to the client. And if we take a look at the actual Telnet header, well, it's hard to tell if it's encrypted or not because there's nothing really happening. But what's interesting here is if we put all of the Telnet packets together for the session, so if I select one of the Telnet packets, here in Wireshark, if I go to Analyze, Follow, TCP Stream, it'll start to put it together so it's a little bit more digestible. And so what we have here is we have a login of test with a password of capture. We then even see some of the commands that were typed in this case for a Linux host, such as uname-a to display the Linux kernel version and then exit and then log out. So we're seeing everything here, including the credentials. And really, in this day and age, there's no good reason to use Telnet. That's where SSH or Secure Shell kicks in because everything is encrypted and it still gives us remote command line access and it still runs as a daemon on a server or a network device. Luckily, with most modern operating systems and devices, Telnet is disabled and SSH is enabled, or SSH is there and can be enabled. So all an attacker has to do is place themselves in the communication path if they know Telnet traffic is occurring to capture it. But they would have to be on the network to be able to do this. And they might use techniques like ARP cache poisoning to force all LAN traffic through their host before forwarding it off through a router. That's one way it could be done. At any rate, let's take a look at something else. Let's take a look at an FTP packet capture. FTP is the file transfer protocol. It has long been used for many decades as a simple way to upload and download files over the internet on devices, whether they're running a Mac OS, Linux, Unix. Back in the day, it might have been a Novell server. Maybe it's a Windows server. Whatever the case was, FTP was a standard that was not tied to an operating system. However, like Telnet, FTP transmits data in the clear. That means credentials are not encrypted. Now, over the years, there have been some standards that have evolved. FTPS to secure FTP connections through encryption. But standard FTP is not encrypted. So I notice I have a number of FTP packets here. If I select an FTP packet, we can quickly examine the header structure. So in this case, it's a loopback network adapter IPv6, followed by the transmission control protocol or TCP header, where the destination port is 21, which is normally what is used by FTP. The source port is a higher level client port that the FTP host communicates over when it talks to that client device. Now, even if we look down in the payload section, it looks like we've got some legible information here for Telnet. It looks like we've got some legible information here for FTP. Why don't we filter the protocol list here at the top for FTP? We don't even have to follow a TCP stream like we did with Telnet or anything. I have an immediate listing here that the username is administrator and that the password looks like a variation on the word password. That's how easy it can be to view FTP credentials if you can manage to get on the network and capture it as it's being transmitted. Again, the lesson is that we should not be using FTP unless we have a secure add-on in some way, like using FTPS. Finally, let's take a look at an HTTP packet capture where credentials are being sent over the network. So if I were to select some of this traffic, for example, I've got a TCP packet here. If I look at the header listing, we've got our Ethernet header, an IP header, and a TCP header. Notice the source port is 80. Well, that would be indicative of an HTTP web server, not HTTPS, because that would normally use port 443. That's interesting. So having that packet selected, if I go to Analyze, Follow TCP Stream, it's put together the entire conversation to the point that I have the username and password shown clearly here because HTTPS is not being used to secure the connection. In this demonstration, I'm going to be deploying password policies using group policy. In a Windows environment, you can configure group policy on an individual machine, but what we're going to be doing instead is configuring it centrally within an Active Directory domain. The benefit here is that the settings within it, in our case, password policy settings, can be applied to some or all computers in the entire domain, or all users in the domain. So what I'm going to do then here on my server is go to the Start menu, and under Windows Administrative Tools, I'm going to fire up the Group Policy Management tool. You don't need to do this from an Active Directory domain controller computer. You can do it from any machine as long as you're authenticated to the domain and you have the Group Policy Management tool installed. We can have a GPO or a group policy object linked or associated with an OU. Here in my Active Directory domain, I have an OU called East to organize users, groups, and computers in the Eastern area. But my GPO here is called East Security Settings, and if I right-click and choose Edit, I could configure potentially thousands of settings. At the computer configuration level, if I drill down under Policies, and if I go under Windows Settings, and then Security Settings, one of the things I can do is drill down to Account Policies and ultimately to the Password Policy. Here's the thing. Even though we can actually go and configure this here, it will never be put into effect. The reason is because it is a GPO that is linked to an OU. If you want to set central group policy password settings, you need to do it in a domain level GPO, like the default domain policy. So I'm going to right click on it and choose Edit, and we're going to drill down to the same part of the hierarchy we did previously. So Computer Configuration Policies, Windows Settings, then down under Security Settings, and then I'll click Account Policies, and we were going into Password Policy. So we have a number of settings here that we can configure, such as enforcing a password history. In other words, how many passwords should be remembered. This prevents users from reusing the same password over and over again. Here it's set to its maximum value of 24, and I want to make sure that define this policy setting is checked on. So I'll click OK. We can also set a maximum password age. Currently it's 42 days. Let's say that we've got a maximum password age of 30 days. In other words, every 30 days, the password needs to be changed to something else. I'll click OK. The minimum password age is set to 1 day. Let's set that to 10. This will prevent users from changing their password right away and cycling through 24 times, for example, so they can reuse an old password that they know. So I'm going to go ahead and click OK. The minimum password length here, let's set that to 8 characters. All of these settings would normally be configured in accordance with organizational security policy settings. We want to make sure the password meets complexity requirements, and at the same time, we could also go to the account lockout policy. So I'm going to set the account lockout threshold to 3. This means after 3 subsequent failed login attempts, the account will be locked. When I click OK, it sets default settings for how long? 30 minutes in this case. But we could change that to be something different. Now, this is a great way to thwart attackers that might enumerate a directory service like Active Directory, try to find user accounts, and try a bunch of passwords against them. After the third incorrect attempt, the account will be locked. Although these days, attackers know about this type of thing, and they use password spraying techniques, where they might try one password on one account, then move on to another account and try that password. And once they've finished enumerating all accounts, they'll cycle back to the first one and try a different password. And that's done in an attempt to circumvent account lockout configurations. Okay, so now that we've done this within the default domain policy, it will flow down the Active Directory hierarchy to all computers. Now, we could go to a command prompt on a given computer, and we could run gp update/force to update group policy settings from the nearest domain controller. Otherwise, it could take 60 minutes, 90 minutes. It really depends on your wide area network replication topology. If your Active Directory domain spans a WAN, that will really determine how long it takes for machines to get refreshed with the new password policy settings. In this demo, I'm going to be showing you how you can try to break into a web application by sending username and password combinations to a web page. Specifically, we're going to try to crack a web form password page. So to do that, I'm going to use our free Metasploitable 2 intentionally vulnerable web application. I've got this virtual machine downloaded, it's running, and it's running at 192.168.4.196 on my network. Remember, when you sign into your virtual machine, your Metasploitable virtual machine with username msfadmin and password msfadmin, once you've done that, if you issue the ifconfig command, you'll get the IP address of your host. So that's what I've got running here as a VMware virtual machine. So let's go back to the web page. Back here in Metasploitable 2, I'm going to click the DVWA link on the left, which brings me to a login page where it prompts me for a username, a password, and I also have a login button. So I have two fields and a button on this web form. If I were to right-click here in my web browser on the page, we could choose to view the page source. And here we've got a standard HTML document that is using a cascading style sheet for formatting. We've got the image source tag with the logo. And the form action here is passing the login.php file, which is part of the URL, to the web server using an HTTP post method. The method equals post for the form action. We've got the username and password text that's shown on the web form. And we've got two input types of fields. One is text for the username, and the other type is password, which will mask what we're typing in as we're typing it in. And the name of that is password with a maximum size of 20. And then we've got an input type of submit, which gives us our button, which we've labeled with the value of login. And then the form tag is closed. Pretty basic HTML document. Let's close that. Now, attackers would need to know something about how the page is constructed in order to attempt to crack the credentials on it. Also, they'll have to know the URL. So here at the top, we've got our host IP address, or it could be a host name or an FQDN, /DVWA/login.php. So this is a PHP page that runs server-side on our web server. If I were to enter an incorrect username and password, it returns login failed. Now, this is important. We need to observe this behavior because in order to try to attack this web page, we need to know which username and password combinations did not work. And we can do that by verifying if it returned login failed. So that's important to know as well. I've downloaded the latest Kali Linux virtual machine image. Kali Linux is a penetration testing tool. It includes many security tools that are built into this Linux distribution, one of which is called Hydra. I'm going to use the man command to view the manual page, the help page, for the Hydra command line tool, because Hydra is the tool we're going to use to attempt to break the credentials on a web form type of page. Okay, so it talks about Hydra being a very fast network logon cracker, which supports many different types of services. Okay, well, that's interesting. We're only going to use it to try to crack the username and password fields on our web page form. So as I go down through this tool, all of the command line parameters are shown. We're not going to be using all of them, but we are going to be using a few of them, like -l. And remember, Linux is case sensitive. Lowercase l is different than a capital L. So -l means that we either specify a login name that we want to attempt to crack the web page with, so a username, or if we have a file full of many usernames, we could use -L and specify the file name. -p, we then specify the password we want to attempt to try, or if we have a password file with many passwords in it, we could use -P and specify the password file. Okay, so I'll press Q to quit. There are other parameters, but we're not going to need to use them. So I'm going to change directory to /usr/share/word lists. And if I do an ls here, we've got a zipped up file, a gzipped file called rocku.txt.gz. Well, I can use the sudo unzip command to unzip that file. So it asks for the password for my Kali user. The password for Kali is Kali. Username and password is the same. So now if I clear the screen and do an ls, we've now got rocku.txt. This is a sample file. And if I just show the contents with cat rocku.txt, this sample file contains many variations on things like passwords. We're going to use this as our password file that we're going to feed into our Hydra command to ultimately try to break the credentials on the web page form. I'll press Control-C to stop that. Of course, you can modify this file. Now, if I cat that file and pipe the result to the grep line filtering command, I can look for specific passwords to see if they're already in there, like the word password. And there are many variations on it, including just password itself in lowercase letters. Now, the reason I'm doing this is because I happen to know that the username is admin and that the password is password for that sample web page. Definitely not following good password guideline. So bear in mind that if account lockout settings are enabled, let's say after 3 incorrect login attempts, the account is locked for a period of time, that would stop this attack after it tries the first 3 passwords, assuming they don't allow login to that web app. The command's going to look like this: Hydra. Then I specify the IP address of the host I want to attack, in this case 192.168.4.196. It could also be a DNS name. Then I'll specify -l, so the login name I want to specify is admin. I don't have a file full of usernames, but I could. I would just use a capital L instead and specify the file name. I'm going to use -P because I do want to reference the rocku.txt file that we were just looking at with all the various passwords in it. So the HTTP method here is going to be an HTTP-post-form, and then space, and in double quotes, I'm going to give it the URL. We need to know the URL, dvwa/login.php. Next thing I'm going to do is specify :username equals, and I'm going to use a caret by shifting my number 6 key, and I'm going to put in user in uppercase letters and caret again. What are we doing here so far? Well, we're telling it that on that login PHP page, we want to go into the username field and we want to inject whatever is in the user variable. In this particular case, the user variable is the name admin, which we specified here on the command line. Otherwise, if we had a file full of usernames, it would keep replacing with the usernames from that file. Then I'm going to put in an ampersand, so and password equals, so that's the password field on the web form we're referencing. And we want to feed into it a variable that's going to be, so a caret symbol, uppercase, pass, caret symbol again. That's going to replace the password field on the web form with passwords from our rocku.txt file. So the admin username will always be used, but we're going to be cycling through all of the passwords. Then I'll put and login equals login. That's the login button. That's what it was named. Remember when we viewed the page source? Login failed. That's how we know that it didn't work. That's our return message. And then I'll press enter. And before you know it, it will have quickly discovered that the login for that web page is admin and the password is password. Now, this may be painfully obvious to you already, but I'm going to state it anyways. Do not run these types of attack tools against sites that you do not own or do not have express written consent to run the attack against. Because running this type of attack is crossing the line. You could be prosecuted for it, depending on what you're doing it to and where you're doing it from. So only do this in a test environment or as a pen tester. In this demonstration, I'm going to use the free community edition of the Burp Suite tool to crack the credentials on a web page. So when we have form fields that ask for things like usernames and passwords, if we can inject ourselves as a middleman between a web browser client and that server, then we can gather that information. Kind of like what you can do with the OWASP ZAP tool. You can act as an HTTP proxy. And that's exactly what we're going to do here. So I'm going to go ahead and download and install the Burp Suite Community Edition. All right, when I start the Burp Suite tool, I'm asked to create a temporary project or open an existing project. I want to just work with the temporary project. I'm not going to save it, so I'll just click Next. I'm going to use the Burp defaults. I'll click Start Burp. And what I want to do here is go to the Proxy tab up at the top. Currently, Intercept is off. I want to turn Intercept on. I want to act as a middleman so that requests to a web app go through Burp Suite. Now, I could use a web browser and configure it to proxy through Burp Suite, or I could just open the browser built into it, which I will do. So open browser. And what it's done is it's already started to give me some details about that web browser session here. Now, in my Burp Suite browser, I'm going to enter in the IP address of the web app that I want to try to intercept or even try to hack into. And I'll press Enter. Now, it might look like it's taking forever. Essentially, each request, each submission to the server is paused and captured by Burp Suite. Now, in a totally separate web browser, this is what the page should look like. Ultimately, we're going to be navigating to DVWA, where we have a username and password field on this login web page form. So back here in the Burp Suite, to continue on, I'm going to click Forward. And we've got an HTTP GET request, and the host IP address is shown here in Burp Suite. So I'll click the Forward button. Back to the Burp browser, that gives us the Metasploitable 2 page now. So if I click DVWA, it looks like things are paused once again, so let's go back to the Burp Suite, and I'll click Forward. So it looks like the GET request now reflects the login PHP page on that host. We even have some cookie information that's been intercepted here. So I'll just click Forward. Here on the DVWA sample web page, I'll just pop in a username and a password, and I'll click Login. Again, everything appears to have been paused. Back here in the Burp Suite, this is how easily it was able to retrieve what was just typed in for the username of admin and the password of password. Now, of course, an attacker would have to be able to position themselves for a man-in-the-middle type of attack such as this between a client and the server. And that's much more difficult than just stating it. Not only that, the Burp Suite tool can also be used to analyze or troubleshoot activity related to a web application. At any rate, if we were to click Forward here, it would complete the connection. And here in Burp Suite, if we go to HTTP history, we'll have a little bit of the history about the connections that were made to that host and the URL, and whether the HTTP method was GET or POST. If I were to click on the Options tab at the top, this is where we could configure proxy listeners. We mentioned here that you could have a different web browser proxy through Burp Suite on specifically port 8080. You can also add conditions down below for which type of client requests that will be intercepted by Burp Suite, whether it's HTTP methods of a certain kind. So if I click Add, you could specify the match type, whether it's a domain name, IP address, HTTP method, URL, a file extension, a cookie name, the list goes on and on and on. So Burp Suite is quite an extensive tool, which works great as an HTTP interceptor. It can be used by nefarious individuals for trying to break into web applications, but it can also be used to test the security of a web app as part of a vulnerability assessment. So that's just a little bit about how to use the Burp Suite to kind of analyze activity on a web page form. In this demonstration, I'm going to crack an RDP password using the Hydra tool. RDP, of course, is the Remote Desktop Protocol. This is used for GUI remote management of Windows hosts. So I've got Windows Server running here already. What I want to do is go into a command prompt, and what I want to do from here is find out what the IP address of this host is. So I'll type ipconfig, and here we've got 192.168.4.167. So that is the host that I will be running the RDP password crack against. But here we're being handed this on a silver platter. We know this is a Windows host, so presumably RDP is running on it and available for remote connectivity. But what if we don't know which hosts are even up on the network, let alone those that support RDP? Well, that's why we have tools like Kali Linux, which consist of multiple command line utilities for testing security, such as Nmap, to scan hosts on a network to see which ones are up and running and which ports might be available. For example, if I were to say Nmap 192.168.4.1 through to 170, let's say, I want to scan that range of hosts in that IP range. And maybe I'll change my command so I have nmap-P lowercase n, which means I don't want to perform a host discovery, and I'll press enter. So we'll give it a moment here to scan the network to see if it discovers anything with port 3389, which would be indicative of RDP, of course. Of course, if we wanted to scan a single host, we could specify it with its IP address and even a single port we're looking for with -p. So RDP listens on port 3389, so I could issue this kind of nmap command, and I get a returned listing that shows that the state is open. That machine is listening on TCP port 3389. So that could then reduce my number of hosts that I want to potentially break into if I were a malicious user. Now, speaking of playing the part of a malicious user, what would they do at this point? Well, the next order of business would be to make sure that we have a username and or a password list file that we want to apply against our newly discovered RDP host. Currently, if I issue the pwd print working directory command here in Kali Linux, I'm in the USR share word lists directory where I've already unzipped a file for rocku.txt. This is included with Kali Linux, and if I cat the rocku.txt file, it is an enormous list of passwords. Okay, so we can use this as a password file when we want to try to crack passwords. So I'll press Control-C to stop that output. Now, if I look at the manual page, the help page for the Hydra command, it gives me a listing of all of the command line parameters that we could pass to the Hydra command. And what I'm interested in, notably, is -l, where I can specify a login ID, a username, in this case for RDP on the Windows host, or I could use a -L and specify a file containing many usernames. I could use -p and specify a single password on the command line I want to try, or -P and a file, which we have, the rocku.txt file. So we have a couple of ways to run the Hydra command. Now, of course, leaving an RDP port open out to the public internet is never recommended for security reasons. It can be discovered with Nmap and potentially attacked with the Hydra command line tool, among many others that are out there and available. You might also want to make sure that RDP is only available on the internal network. Maybe you have to establish a VPN tunnel to get to it, or go through a jump box. And of course, at the user account level, use complex passwords, enable account lockout settings, and you should be using multi-factor authentication to mitigate the type of attack we're about to jump into. Okay, so Q for quit. Let's make it happen. Okay, so I'm going to issue the Hydra command with -l. Now that's a lowercase l, so that's the login name that I want to specify. Here I'm going to specify a user account of C. Blackwell. Now I know that that is a valid user account on that host. Otherwise, you could guess at the command line or use capital L as a parameter and specify a username file. -P, we know the file here in the current directory is called rocku.txt. It's got all of our passwords in it. then RDP:// and the IP address of the host that I want to attack. Let's go ahead and press enter. Well, it doesn't seem like we're having too much luck. Of course, we would wait it out, but I'm going to press Control-C, because if I think that the username is C. Blackwell and it's not working, well, maybe I could try what I know is normally present on a Windows host, such as the administrator account. Let's see if that's the case here. Yeah, that was it. It didn't take very long for it to discover that the login name administrator has a password of the word password, a variation of it with ABC123 at the end. So that's potentially easy. It might be for a malicious actor to break into a Windows host by trying a bunch of different passwords against the RDP port. Many Unix and Linux distributions store user passwords locally in a file called shadow. And this is in the /etc directory, and what it does is it stores a hashed version of the user password. So it doesn't actually store the password itself. Modern Linux variants will use salting, which adds randomized data when generating the password hash to make it more difficult to crack. So essentially, we want to make sure that attackers cannot get access to the /etc shadow file where hashed user passwords are stored normally in Unix and Linux environments. Because if an attacker can gain access to this file, even an offline copy of the file, they can still run various attacks against it to try to determine what the original password was, even using rainbow tables. So in this case, we're going to use a free tool called John the Ripper to attempt to crack hashed Linux user passwords. So I'm going to run sudo, and I'm going to run tail/etc/password, spelled PASSWD. Now, this is a Linux file that contains user account information. For instance, we have user mbishop, along with things like the user ID, the home directory location for that account, and the login shell that they will have when they sign in. But what we don't have in this file in newer Unix and Linux distributions is the hashed password for that account. Instead, we clear the screen. We can see that by running sudo tail/etc shadow. Now here we have an entry for user mbishop once again, and this is to be expected. But what follows in the next field, and each field, by the way, here is delimited with a full colon symbol. That's what separates each field of information here, because we have password expiry info, we have the username, and what we're interested in, the password hash, which I've just selected here. Okay, but that password hash is the result of entering in a normal password and then it being fed into a hashing algorithm, which results in this value. But there are ways that we can try to crack this by feeding in lists of potential passwords and just comparing the hashes against what might be seen here. So, okay, what we're going to do then is we're going to run the sudo, because we want to run elevated privilege commands. I'm going to run the unshadow command here, because what I want to do is I want to combine the contents of /etc password and the contents of /etc shadow. And I'm going to output that using my output redirection symbol. It's a greater than sign. I'm going to store that in a local file in the current directory called creds.txt. The John the Ripper tool needs to have the contents of those two files in one file. And that one file here is our creds.txt file. So once that's done, we're going to take a look inside creds.txt just to make sure everything seems like it's good to go. So cat creds.txt. Yeah, it looks like it's a combination of what we looked at in those individual files, so that's good. We're good to go there. Clear the screen. The next thing that we want to do is make sure we are aware of a password list file or files that we want to use. So for example, I'm going to run head against a file under /usr/share/word_lists. And this is a built-in password file. I actually decompressed it or unzipped it. It's called rocku.txt. It's part of Kali Linux, which is what I'm using. And if we look at the head of that file, just the first 10 lines, there's the passwords. If I use the up arrow key to bring up that command again, and let's say we actually use the cat command to show the entire contents of that text file, it would take quite a while for it to finish because we've got a ton of passwords here that can be used in our particular case to try to crack password hashes that are really stored in /etc/shadow. Okay, so I'm going to press Control-C to interrupt that. So now that we know the preliminary information, how do we make this all work? Well, I'm going to run the John command, John the Ripper, -- word list. And what I want to do is I want to make sure I'm pointing to /usr, /share, /wordlists, /rocku.txt. That's the file we just looked at. Now, that could be a tiny file that you create, a text file with just a handful of common passwords. It could be anything. But in this case, I'm going to refer to that one built into Kali Linux. And the next parameter is the credential file that we created, creds.txt. Remember, that was a combination of /etc password and /etc shadow. So let's go ahead and press enter. And okay, now we're going to run John -- show. And we want to show the results of any cracked password hashes related to creds.txt. And immediately, for user Kali, we can see that we have a password of Kali. For user 1, U1, we have a password here, which is a variation of the word password. And the user that we looked at, mbishop, it's determined that that password hash was derived from an original plaintext string of password ABC123. So that's how incredibly easy it can be to start cracking Linux password hashes. Now, mind you, an attacker would have to have access to combining etc password and /etc shadow. But we're going to see some examples later of how easy it is to get files from a web browser interface. So an insecure web app might allow attackers to inject commands that execute server-side and return the results of sensitive files like etc shadow back to a web browser interface. And then if an attacker has that offline, they can save those, they can do this password cracking offline, and then they could try to sign in with legitimate credentials to a web app. So that's why we have to be aware of how this works. And it really lends itself to telling us that we need to have very long, complex passwords, or ideally, multi-factor authentication to mitigate these types of attacks. Probably the best way to break into someone's account, whether it be Twitter, whether it be for a Windows server, a Linux host, some website, is to trick them. Whether it's tricking them into clicking a link in an email message, whether it's making a telephone call and tricking them into providing credentials, or whether it's cloning a real website but having it run on a fake host to gather or harvest credentials. That's what we're going to do. We're going to harvest credentials using a tool that's included with Kali Linux called the Social Engineering Toolkit. Social engineering is deception. It's trickery. So whether we want to steal credentials from someone's Twitter account, Facebook, or online banking, it could be anything. What we first have to do is figure out what the correct normal URL is for that site, because what we want to do is copy the look and feel. We want to clone it onto our own machine where we're running a small web server stack. We want to trick people into visiting our fake web server, which will look just like this, so they'll be fooled into entering their credentials and trying to sign in. So I've downloaded and am running the free Kali Linux virtual machine on my local host. And what I'm going to do is enter the sudo command to run a privileged command. And I want to run SE Toolkit. That stands for Social Engineering Toolkit. It wants the password for user Kali. Well, that's also Kali. And after I read what's on the screen, I can choose to agree or not agree with the terms of service. I'm going to press the letter Y, as in I do agree with the terms. And with this tool, I don't even have to enter command line parameters. I've got a menu-driven system. Could it be any easier? So we've got a number of items such as social engineering attacks, pen testing, and working with third-party modules for this tool. Well, I know I want to go into number 1, social engineering attacks. So I'll type in number 1 and press enter. Now notice, by the way, our command prompt is for the Social Engineering Toolkit, or SET now. Then we get a second level menu where we have all kinds of goodies like spear phishing attacks. Spear phishing means you are targeting attacks to specific individuals to try to trick them, for example, into clicking a link. Number 2 is website attack vectors. That's the one that we're going to do. Then we've got options further below in the menu for infectious media generation. mass mailer attacks, the list goes on and on. Let's go into number 2, website attack vectors. Okay, then we have another sub-level menu. Do we want to run a Java applet attack, a Metasploit browser attack, credential harvesting, which is actually what we want to do. So number 3 for credential harvesting, enter. And what I want to do is I want to clone the Twitter login page. So number 2 for site cloner. Okay, so it asks for the IP address for the post. In other words, where do we want to direct the captured credentials? And that's going to be for the IP address of this local host, 192.168.4.161. That's where I'm running Kali Linux. I'll press enter. For the URL that I want to clone, I will enter https://www.facebook.com/login, because that's the site I want to copy or clone, and I'll press enter. And after a moment, it is running on port 80, in this case, on this local machine. So I just need now to trick users into visiting my fake website, whether that's through some kind of DNS poisoning of a DNS server to redirect that DNS name to my IP. So I would have to have a public IP address on my attacker machine, or I could make that work through port forwarding, whatever the case might be. Or if I have control of a victim's computer, I might add an entry in their hosts file to redirect the Facebook DNS name to my server. So this looks like the real thing. Of course, we don't have a certificate, so our browser says not secure. But if I enter in a username and a password and then attempt to log in, it looks like nothing happened other than some kind of glitch occurred or it just didn't accept my credentials. So the user would normally specify their real credentials next, which would then actually log them in this case, to Facebook. But let's go back and check Kali Linux. Wow, looks like stuff happened back here. So as I go back up, we have listings here for possible username field found, where the email specified was test user. That indeed is what I logged in with. And then possible password field found. And indeed, the password I entered was test password. So it actually captured these credentials because I would have tricked a user to come visit my fake site, which looks like the real Facebook login. Now they've been redirected on and they're not going to give it a second thought. But naturally, I can now sign in as that user into Facebook. This is one of the reasons why user education, user training is very important. Users need to understand that if they get messages in their browser about a site not being secure, then that usually means something's up. It could be something as simple as the website certificate expired, but still users must be educated to not go to that site. It could be they entered a different URL or IP address than matches what is in the certificate, or it could mean that this is some kind of a social engineering attack. Multi-factor authentication means that we have multiple authentication categories that are required before authentication succeeds and ultimately leads to the authorization to access a resource. So instead of something like just a username and password, we might in addition require some kind of authentication code that is sent to a user's phone, for instance. While there are many ways to enable MFA in different systems, in this particular demo, I'm going to be using the Microsoft Azure Cloud. If I navigate to Azure Active Directory, so I'm going to open my navigator on the left and go to Azure Active Directory, and if I go take a look at my user's view and open up the user in question, in this case, it's going to be Bonnie Grace. Currently, this user has an email address or a sign-in name and a password, which I could reset if forgotten. But both of those items fall under the category of something you know, and so therefore, this constitutes single-factor authentication. If somebody can guess the password, and if they don't know the email address, they guess that as well, they could be in. So we want to make it harder for people to break into these accounts. We want to enhance user sign-in security. That's where MFA comes in, because you have to have another category of authentication. Some web apps will call it two-step verification if it only requires two different categories, but it all works out to be the same thing. So what I'm going to do then is I'm going to go back to my user's view here in my Azure AD tenant, and I'm going to click the Per User MFA button up at the top. That's going to open a new web browser window, which will list my users and their multi-factor authentication status. The default is that when you create a new Azure AD user account, MFA is disabled. However, we've got a few here that are enforced, which means it's been turned on and people have logged in with MFA. And we also have some that are enabled, which means MFA has been turned on, but that user has not yet signed in with MFA. For our subject, Bonnie Grace, it's showing as disabled. So I'm going to turn on the check mark to select Bonnie Grace, and I'll click Enable over on the far right, and then I'll just click the Enable Multi-Factor Auth button. And then it tells me that it's now enabled for that selected account. Perfect. I like it. So I'm going to click Close. So for Bonnie Grace, we now show enabled under the multi-factor auth status column. What we're going to do is sign in as user Bonnie Grace to see what it looks like the first time a user signs in after MFA has been turned on, and then we'll log out and log back in again to get an overall feel for how it should behave. Okay, so in another web browser instance, I'm connecting to myapps.microsoft.com, although the URL has changed, and I'm going to pick user Bonnie Grace. Her email address is here because she's signed in previously in this web browser. I still have to know the password for the account, so I'm going to go ahead and enter that in. And I'll click Sign In. And then it says that more information is required. And this is because we've enabled MFA. So I'm going to click Next. So the first thing it wants to do is determine how we should be contacted for the second factor of authentication, such as having a smartphone or an office phone or a mobile app. So I'm going to choose Mobile App, and I want to receive notifications in the app for verification. Now you might wonder, well, how is that going to work? Well, we're going to determine that when we click the Setup button, where it's going to provide a QR code. So it gives me the instructions. It tells me to install the Microsoft Authenticator app. Well, I've got that installed on my Android phone, but it is supported on Windows phones and on Apple iOS devices as well. And I'm going to add a work or school account and then scan the image below. If you don't have the Authenticator app installed already, just go to your app store for your device to do that. Okay, so all I do is point my phone's camera to that QR code, and it knows automatically that the Azure AD tenant is Azure DevOps, and it knows that it's Bonnie Grace. It picks all that up from the QR code. So I'm going to go ahead and click Next. And I'll click Next again. And what's happening on my smartphone right now is in the Microsoft Authenticator app, it's popping up and asking me to approve the sign-in. I'm going to tap Approve. Let's see what happens here. Okay, verification is successful, taking me to the next step. Perfect. In step 3, in case I lose access to the mobile app, I can specify the details related to my phone number. So I'm going to go ahead and do that. And I'll click Next, and then finally, Done. So now I am signed in as Bonnie Grace after having initially set up MFA. Back here in the Azure portal, if I go back into per user MFA and take a peek at user Bonnie Grace, notice now it's showing under the multi-factor auth status column the word enforced. Okay, so let's sign out as Bonnie and let's do a fresh sign in just so that we know MFA is working as intended. So of course I need to have my smartphone handy here in order to approve the request. So I'm going to select the username and I still need to know the password. And then I'll click Sign In, and it says Approve Sign-In Request. And the same thing has popped up on my smartphone. So I'll just tap Approve, and then we'll be off to the races, as they say. Looking good. Stay signed in? No. Okay, so now we have successfully authenticated using multi-factor authentication for user Bonnie Grace. Now, you really want to pay attention to enabling MFA for powerful administrative accounts. Really, if you can swing it, you really should enable MFA for every user account. It just really is a simple thing that can be done to greatly enhance sign-in security as opposed to just using a username and password. Yes, it's a bit of effort to set up, and yes, it might be a few more steps for users and a bit inconvenient, but that's always the case when things are more secure. So let's just do one more test. We're going to see what happens if we pretend that we don't have our smartphone app available. So I'm going to go ahead and sign out as Bonnie. And of course, I'm going to sign right back in again. So I'll select your name and enter the password and choose Sign In. But this time, when I get the approved sign-in request screen, I'm going to choose I can't use my Microsoft Authenticator app right now. At which point, I get the Verify Your Identity screen. So we could choose, for instance, to send an SMS text message to the configured phone number. A user might get a new smartphone and move over the SIM card so they have the same phone number but not have the app configured. So this can be useful in that kind of scenario, among others. Okay, so I entered the 6-digit code that was texted to my phone, and I'm going to click Verify. At which point, we just proceed on, and we are signed in now with MFA. When it comes to the IT supply chain and security, one consideration is where you're getting your software from, and not only just new software you're installing, but also where are you getting the updates or patches that you apply to that software, whether it's software for the OS, for the web server stack, for app components, whatever it is. So in my web browser here, as an example, I've navigated to Google Linux software repositories. Now, this would be important if you want to have a trusted source from which you install packages and updates for them. Now, as I go further down below, there is a signing key here that is available so that you can verify the integrity of the packages that you're installing. And so the documentation gives us instructions on how to install the signing key for machines that use APT like Debian-based Linux, Ubuntu Linux. Kali Linux is actually based on Debian, and we're going to be working in Kali, so that would be applicable there. If we wanted to use Google Linux repositories, there are also instructions for installing it on RPM-based systems like Red Hat Enterprise Linux, SUSE Linux, Fedora, Mandriva, to name just a few. So here on my Linux host, what I want to do is use the sudo privileged command and then nano, the text editor. I want to reach into /etc/apt/sources.list. Now, this is an important file for our discussion because it's a file that contains a reference to the repositories that this Linux host will connect to when it comes to installing software. For example, if we use the apt install command, this is where it knows to go out and get those software packages over the internet, as well as getting updates and applying them. So this is based on Debian, so we have deb. Then we have the URL of the site where we've got package repositories available. In this case, http://kali.org/kali. But then we have another directive here that says kali-rolling. This is the branch for software packages on the site that we refer to. In this case, it means it's the default location for installing packages for Kali Linux, and it's often used. It also means that there are updates that are made available here on a frequent basis. Then we have a number of components. What this means is which types of packages do you wish to be able to use from this branch in this repository online? So main packages, contributed packages, and non-free packages. And we could add multiple sources to this file if we wanted to be able to install software packages from other locations. But you want to make sure they are trusted. And as we saw with the Google Linux repository listing, you might have to install a key in order to be able to verify signed packages to make sure that you are assured of their trustworthiness and that they haven't been tampered with or corrupted after having been downloaded. So let's get out of here with Control X. I'm going to run sudo apt. Now, of course, if we wanted to install a package like the Snort intrusion detection system, we would run this command, and it would look at our sources list file, our repositories, to determine if that package is there and available for install. Now here it says Snort is already the newest version. However, what we can do when we're working with software packages and updates on Linux is we can first run sudo apt update. What this is going to do is make sure we have an updated list of packages from our configured repositories. Notice it's connecting to http://kali.org. Now, once that's been completed, I'll just interrupt it with Control C. What we can then do is run sudo apt upgrade. What this is going to do is look at any packages that we have installed on this host and compare it with what's in configured repositories to see if there are updates that need to be applied. So here we have a number of items here that need to be updated, and it tells me the amount of space that's required for this to happen. Do you want this to continue? Now, in the interest of making sure the system is patched, you would type in the letter Y, and it might take some time for it to happen, but given that you've got a trusted repository list, you can be assured that you're pulling down the proper updates. And we know that applying updates to firmware, to operating systems, to web servers, to app components is absolutely crucial as part of the hardening process. The OWASP Top 10 for 2021 includes item A08, Software and Data Integrity Failures. Well, let's focus on software integrity. Specifically on a Windows host, specifically a server, we can enable the Windows Server Update Services or WSUS update feature. That's going to be the focus here of this demonstration. Now, it's true that Windows operating systems, client and server alike, out of the box these days will automatically pull updates periodically down from the internet. But in an enterprise, instead of each individual Windows client and server pulling down the same updates over and over and over, especially if you've got hundreds of the same versions of Windows 11 or Windows Server 2022, why not pull those updates down once on an update server, maybe test them thoroughly to make sure that they work well, and then configure them to be deployed to certain groups of computer with specific settings that you would enable in group policy? That sounds like a viable solution. And that's where WSUS kicks in. But what we need to do is we need to install the WSUS component in Windows. It's available, but it's not installed by default. So what I'll do is I'll click Add Roles and Features, and I'm just going to accept the defaults as I go all the way through, down to the point where I get to my list of server roles. Because at the bottom of the list of roles, it's alphabetical, I've got Windows Server Update Services. Now, if I've got 20 Windows web servers hosting web apps, I probably don't want each and every one of them going out to the internet and getting the same updates. They're running the same version of the Windows OS. And that's where even using WSUS means we can realize efficiencies in only downloading those updates once, but then distributing them from the WSUS host internally to all the hosts that need it. So I'm going to turn on Windows Server Update Services. It'll pop up and say, would you like these additional components? Which also includes admin tools. I do, so I'll click Add Features and I'll click Next. I don't want to add any features. We've just added the WSUS role, so I'll click Next. And I'm going to continue on through here, accepting the default settings for WSUS. And here it asks, where should we store the updates on the update server? So maybe I'll specify d://WSUS/updates. And then I'll click Next. And I'll click Install. So we're installing the WSUS role, but we're going to need to go and configure it in order for it to be useful in securing our environment by applying patches in a timely manner. Once the installation has completed, I'll click Close, and I've got a little alert in the upper right that tells me there's some post-deployment configuration for Windows Server Update Services. No problem. I'm going to choose Launch Post-Installation Tasks to further configure WSUS. After a moment, the configuration wizard begins. So I'm going to click Next on the introduction screen, Next on the next one, and what we're going to do is synchronize updates from Microsoft Update on the internet to this WSUS server. We could synchronize from another upstream WSUS server, perhaps one at our headquarters location that already downloaded the updates. But in this case, synchronize from Microsoft Update, Next. I don't need to use a proxy server to get out to the internet, so Next. And then I'll click the Start Connecting button to make sure that this server can see, in this case, the Microsoft Update service online. So once the wizard has connected and retrieved information about updates, I can proceed by clicking Next. So from here, I can specify the languages that I'm interested in downloading updates for. English is selected, so I'm okay with that. I'm going to click Next. So now I can select or deselect any items that I want to look at in terms of products which would have updates. So for example, if I know I'm only using a certain subset of these components, then I can go ahead and select whichever item I want to get a list of updates for. So for instance, maybe I'll just select something quick here, Windows 10 and later drivers. If I know I'm using that internally, I'll click Next. Maybe I just want security updates, or I want driver sets, or I can choose the classifications of those updates. I'll choose Next. I can synchronize manually or specify how many times per day, so I'll leave it on manual for now. I'll tell it to begin the initial synchronization. I'll click Next. And then I'll go ahead and I'll choose Finish. After that's done, you can go to your options here in the WSUS management tool to make changes to perhaps the products and classifications that you're interested in getting updates for. So you can come back here and change your mind at any point in time. So for example, if I've specified synchronizations, I've got a list of synchronizations here, and of course I could just right-click and synchronize whenever I wish based on my settings. What I'll end up getting are a number of updates. So if I go to security updates, let's say, and if I look at a status of any and refresh, I've got a number of Windows Server 2019 types of updates and so on. Now, for computers over on the left, I could build a computer group. I could right-click and add a computer group called IIS Web Servers, because maybe that's what we want to control the patching of for hardening our web app environments. We could configure group policy to determine servers in Active Directory, let's say, that should become a member of the IIS Web Servers group. Or we could go to the unassigned computers built-in group and just simply move them over, whatever the case might be, to determine which computers will be affected. But when I go look at my security updates, I can go to any one of them or select a group of them, and I can right-click and choose Approve. And this is where I could choose to deploy it to a specific computer group. So if I click, for example, on the arrow for IIS Web Servers, I could choose Approved for install, and then I could choose OK. So whichever servers then are a member of our group, so that would be over here on the left, of course, the IIS Web Service group, would receive those updates internally. One way to verify the trustworthiness, the integrity of a script, is to ensure that that script is digitally signed and that the machine on which that script will execute trusts the signer. And so here we've got a simple PowerShell script. The file name is called script1.ps1. PowerShell scripts normally have a PS1 file extension, but they certainly do not have to. This script is only doing one thing. After clearing the screen, it is getting a list of services with the get-service PowerShell commandlet. After which, the result of that, which is normally a list of all of the installed services on the local host, and that comes along with all their properties, we are piping that with our vertical bar or vertical pipe symbol. We're piping that to the where-object commandlet. Now, where-object is an alias symbol here of a question mark, which means where-object. And then within opening and closing curly braces, we have an expression of what we want to filter out. What we're doing is we're saying we want the status of the service to equal, -EQ is the operator, running. Now notice how we're referring to the status. We're calling upon the .status property, but of what? Well, $_. You have to bear in mind here that PowerShell is object-oriented. Get-service returns an object collection, and that's a collection of services. But what we need to do is evaluate each individual service within that collection. We need to basically loop through them. Well, a built-in way to do that in PowerShell is that when you pipe a collection to another commandlet, if you use the $_ built-in placeholder variable, that's like a looping variable. So if get-service returns 100 services and we pipe it to this expression, well, the very first returned service is referenced with $_. We check its .status property and see if it equals running. Then we go to the next service in the result of running get-service, and we test its status to see if it equals running. And we keep going through the entire return result of get-service. So that's all the script is doing. What we're going to do is we're going to test how this behaves when a machine will not trust scripts unless they're digitally signed. And then, of course, we'll digitally sign it. Here in PowerShell on my host, I'm going to run get-execution policy. This is unrestricted. What this means is that any script from anywhere can run on this host. It will be trusted. Well, I don't really want that. So what I'm going to do is I'm going to run set-execution policy, and I'm going to set it to all signed. It says, are you sure you want to do this? And I'll press A for yes to all. Now I get an access denied message. Well, why would this be? Well, it's because I need to make sure that when I start PowerShell, I'm running it as administrator. The word administrator is not in the title bar, so I'm going to exit out. And from my start menu, when I go to run PowerShell, I can choose to run it as administrator. So that's what I'm going to do in this case. Okay, now we have administrator in our title bar. So we're going to do this again. Set-execution policy, all signed, A for yes to all, and it's done. Now if I run get-execution policy, it returns all signed. Okay, so scripts need to be signed for them to be able to run. So if I change directory into scripts, do a dir, there's our script1 ps1 file we looked at, / current directory is what I'm referring to here. I want to run script1.ps1, and it says cannot be loaded. Can't run it on the current system. Okay, so there's been a PowerShell or a PS security exception. Well, it's because it's not signed. So what we're going to do is create a variable called $cert, and it's going to equal the result of running new-self signed certificate-cert store location. It's going to be the PowerShell cert drive, cert:/current user /my -type. I want to make a code signing certificate. Now I'm setting up my own code signing certificate. In a larger enterprise, this will be issued centrally. But developers, or in this case, script writers, should have a code signing certificate if they are to be expected to digitally sign scripts. And I'll just add -subject, and this will be for user C Blackwell. So if I type $cert so we can see what's in that variable, it's got the information, including our certificate thumbprint, for our self-signed code signing certificate. To digitally sign the script, I'll use the set-authenticode signature PowerShell commandlet. Now there are two parameters I'll have to specify here. The first being -file path. I have to point to the path and file name of the script in question that I want digitally signed, and I need to tell it the certificate to use to sign it. I do that with -certificate. In this case, I'll pass it our $cert variable and I'll press enter. After having done that, if I open up my PowerShell script, I still have the original script statements, but then we have a signature block that begins and continues all the way down through. So now the script is digitally signed. So let's try to run it again. So I'm still in the scripts directory, so /current directory script1.ps1. Now I'm getting another error. It says a certificate chain processed but terminated because the root certificate isn't trusted. Well, I'm going to run MMC, the Microsoft Management Console. I'm going to go to File, Add, Remove Snap-in. I want to add the certificate snap-in for my current user account. Let's take a look at what's happening here. If I drill down under certificates for the current user personal, here's the C Blackwell code signing certificate. But it says that the CA root certificate is not trusted. It says to enable trust, install this certificate in the Trusted Root Certification Authority store. Okay, so I'm going to right-click on that certificate, all tasks, export, next. I don't need the private key exported for this purpose. I'll leave the default file type. And let's say I'll put it in C:\scripts and call it trusted root. I'll click next and finish. The export was successful. So in the file system, there's our trusted root file. If I double click on it, I can choose to install the certificate. I'm going to choose a local machine, next. I'm going to choose place all certificates in the following store, and I'll click browse. I'm going to choose trusted root certification authorities, okay, next, finish. And it says the import was successful. So if I go back into MMC, remember we were looking at the code signing certificate for C Blackwell? Now if I double click, it no longer states it doesn't trust it. Excellent. Well, that should mean then by all rights that the script will be allowed to run, correct? Let's try it out to verify this is true. Okay, so back here in PowerShell, let's just use our up arrow key and try to run our script again. So in PowerShell, we haven't installed C Blackwell as a trusted publisher, but that's okay. It says, do you want to trust this? I'm going to press the letter A for always, and it ran. It's only showing us our running services. That's what our PowerShell script does. Let's try to run the script again. This time it runs seamlessly. Now, naturally, in a larger enterprise environment, you're going to have to make sure that the issuer of code signing certificates is trusted by devices. In a Microsoft environment, you might even push that out using group policy in an Active Directory environment. In this demonstration, I'm going to be working with file hashing in Windows. Now, there are plenty of tools out there that allow you to generate file hashes or to compare them against previous hashes to detect if something is corrupted or if something's been tampered in an unauthorized way. I'm going to do it using PowerShell. So on my computer, I'm in a folder on drive C called Testing. Let me do a dir here. I've got 3 files. I've got a JPEG file called doggy.jpg. I've got a tool here for hiding files within JPEGs. This is referred to as steganography, when you embed a message within another file, and that file looks benign. You can't even tell anything's inside it. And then I've got an actual file called message.txt. If we flip over into the GUI here in Windows, if I look at the picture of the dog, there indeed is a dog. If I open up the message.txt file, it's just a text file that says this is a secret message. What I want to do is I want to take a file hash of this picture of the dog. The file's called doggy.jpg. Before we embed a hidden message within it, then we'll generate a file hash after to see if it's different, because this is one way that you can detect nefarious changes to a file. All right then, so back here in PowerShell, let's start with running get-file hash, and that's going to be for our doggy.jpg file. So the default is that it's doing a SHA-256 hash, secured hashing algorithm 256, and we get a unique hash value. Now I could specify something different on the command line, so if I use the up arrow key to bring up that previous command, I could say at the end of it, -algorithm. Maybe I need to generate an older MD5 hash. Or if I change that, perhaps I want to use the SHA-384 algorithm. Whatever the case is, I'm going to go back to the original, which is just a SHA-256-bit type of hash, and we get a hash value. Now, we could write that to a file. I could output that using output redirection, like the greater than symbol. Let's call that original hash.txt. Now, if I run Notepad against that file, there it is. So we have the file name, the algorithm, and the hash. Okay, so what we're going to do now, back here in the GUI, is we're going to use this JPEG file hiding steganography program to embed our message.txt in the picture of the dog. So I'm going to run that program, and I'm going to click Open JPEG, and I'm going to select the picture of the dog. Then I'm going to choose Hide. It says, okay, enter a passphrase, so I'll do that, and I'll click OK, and it says select the file you want to hide. Well, in this case, that's going to be the message.txt. Okay, let's save the JPEG. So now we've saved the JPEG, but there's a hidden file embedded within it. I'll just close this tool. If I open up the picture of the dog, it looks like a picture of a dog. It doesn't look any different, at least upon visual inspection, but is it really the same file? The answer is no. Notice that for the same file, our hash is definitely different than what it was originally before we embedded that message in it. And so using get-file hash in PowerShell is one of many different ways that we can work with file hashing to detect if something's corrupt or if a change has been made. Now, to complete this example, the message was embedded within the file. We detected a change using hashing. So the picture of the dog, for example, might be uploaded to a file repository somewhere for some other malicious actor to be able to open it and read it and see the secret message. And it doesn't necessarily have to be a malicious actor. That's just my example. Now, the way that they would extract that hidden secret message, whether the file was uploaded to a server, whether it was sent as a file attachment, they would have to have the same tool and know that that file has something embedded in it. So they would use that tool, they would open that JPEG file, and they would choose Seek instead of Hide, at which time they're prompted for the password. So they would have to have knowledge of this password. Then they're asked to save the hidden file. So I'm going to call it hidden file for clarity's sake. And if we go back and open up the hidden file, that's just a text file. There it is. This is a secret message. Now, of course, you might wonder, from a security perspective, let's say this is a file on a web server, an important file. If we don't have the original hash, then how can we calculate if it's changed or been tampered with? Well, outside of any other auditing mechanism, you really don't have a way to do that. That's why some web server admins will periodically generate file hashes for every file that a website consists of and use that for future comparisons to detect changes. In this demonstration, I'm going to work with file hashing in Linux. So here I'm using Kali Linux, and I want to work with file hashing because I want to have a way to detect if a file was changed. Now, whether that file was changed legitimately by an authorized user or perhaps maliciously by an unauthorized user, or maybe we're talking about transferring files over a network and making sure that files were not corrupted during that transfer process. So comparing the original hash value of the file on the server with what we've downloaded to make sure they're the same, because if anything's changed, the file hashes will be different. So here in Linux, I'm going to change directory into my home directory, which is a /documents. And in here, I've got a couple of prepared files, one of which is called samplefile1.txt. Let's cat samplefile1.txt. This is just a file that contains text that says, this is sample file 1. Well, it doesn't get much simpler than that, does it? What I want to do is generate a hash of that file. Actually, I want to generate numerous different types of hashes using different hashing algorithms. We'll start with MD5. Message Digest 5 is really a much older hashing algorithm, but you'll still see it being used periodically, such as to verify that what you've downloaded from a website in terms of a file matches the hash value, so you know that it hasn't been corrupted. So MD5 sum is the Linux command, and I'll specify the name of my file, samplefile1.txt, and we have the unique hash value, specifically the MD5 hash value for that file at this point in time. But there are a number of other different hashing algorithms that are available using different commands here in Linux, such as SHA-256 sum, secure hashing algorithm, or SHA-256 is a different type of way to result in a hash, and it's commonly what's used nowadays, where MD5 is an older hashing algorithm. So I'll specify my file once again, and notice that we get a much longer hash, regardless of how big samplefile1.txt is. The hash is always a fixed length. But at any rate, notice that the hash is longer, and it's a different value, of course. And in the same way, if I were to run SHA-512 sum against samplefile1, once again, we get an even larger fixed length hash value, and it's different. Okay, so that's fine. But what I want to do is I kind of want to have a way to automate this. Let's figure this out. If I do an ls here, I've already got a script file, a bash script file that ends with .sh. It's called hashscript.sh. I'm going to use the nano editor to open up hashscript.sh. Now, this is just a basic Linux script. We don't want to get too caught up in the details, but I'll explain what's happening here. What I'm doing is creating 3 variables at the top: day, year, and month. I can call them whatever I want, but that's what I'm calling them. Now, each of these variables is running the date command in Linux and adding a format string to extract just respectively the day component, the year component, and the month component from the full date. Notice that the entire command after the equal sign is enclosed within a backtick at the beginning and a backtick at the end. That is not a single quote, it's a backtick character. Usually you get that by pressing the tilde key on your keyboard, usually towards the upper left on a US layout. At any rate, the next thing I'm doing is I'm echoing some text. Specifically, I'm literally echoing SHA-512 hash value. Then I want to put in the month, the day, and the year. And notice that when I refer to my variables, I prefix them with the $sign here in the bash shell environment. And then I'm using my append output redirection symbol, which is 2 greater than signs together. And I want to append to a file called samplefile1_hash_history.txt. Now, if that file doesn't exist, it'll be created. If it does exist, it will not be overwritten. We will be adding to the end of it. So what we're adding to the end of it is just a little header that says SHA-512 hash value with some date information. Then I'm actually running SHA-512 sum against sample file 1 txt, and I'm appending that to our sample file 1 hash history txt file. And then I'm echoing a new line character, so kind of like pressing enter. And again, I'm appending that to the same file. So this is a way to have a script where you could just run the script and it would keep a running record of the hash value of a file at different points in time. That could be cool. Let's Control X out of here. I don't want to save this. I really haven't made a change to it. First thing I'll have to do if I run ls-l, long listing, is I'm going to have to make sure I add the execute permission for this file. There's no execute permission set, just read, write, read, read. So I can do that easily here with chmod, change mode. I'll just say +X, I want to execute for everybody on the file called hashscript.sh. If we do an ls-l again, it looks like the execute permission is available for anybody that wants to be able to run this. Of course, you need the read permission too, otherwise, how could you read the contents of the script you're trying to execute? But that's a file permissions thing. Okay, let's run our script. So / current directory, it's called hashscript.sh. Well, looks like we have some kind of a syntax error, n not found. Well, maybe I missed something in that file. Let's change the echo line at the bottom here to be just echo, and in double quotes, we'll have our new line /n shown here. Control X to save that, yes, to write it to the file, and let's give it a go. So I'm going to run our hash script, and let's cat our hash history file. Okay, so we've got our header SHA-512 hash value with the date information from our variables. Then we've got the SHA-512 hash value for sample file 1 txt. And it looks like we've got an extra line at the bottom. Let's modify the contents of sample file 1 and run the script again. So I'll open up sample file 1 in the nano editor, and I'll add some text to change, and we'll save that out to the file, and we're going to run our script again. And we're also going to view the contents of our hash history. Notice that we've got our SHA-512 hash value with the dates, and notice that the hash value is actually different the second time because we had made a change to the file. Therein lies the purpose of hashing. I need a way to detect that something has changed, whether it's a message over the network or, as in our demo, it could be a file in the file system. Yet another way to verify software integrity is to verify that any software solutions that you build, that the dependencies are checked for any vulnerabilities. And that's where the OWASP Dependency-Check Tool comes in. As usual with OWASP, this is a free tool that you can download and use on a variety of platforms, such as the Mac OS, Linux, or Windows. And when you install the Dependency-Check Tool and you run it against one of your software projects, and what it will do is try to detect if there are any known publicly disclosed vulnerabilities in your project at all. And as it states here, if it does find any, it will generate a report that links to the associated CVE entries. This sounds like a dream for software developers. Now, over on the right here on the OWASP.org page for this dependency project tool, we've got downloads available. There's a command line version of the dependency check tool. We've got essentially plugins for a variety of different tools, including Maven, Gradle, Jenkins, and there are some external resources you can refer to related to this, such as GitHub, Bintray, and so on. So what I want to do then is I want to download the command line version of the tool. So I'll click on that link. And it's downloading my dependency check zip file. So if I go to my downloads folder, I can then choose to extract that downloaded zip file. So I'm going to go ahead and extract it right here. That gives me a dependency check folder in which I've got a number of files and folders. Of course, there's a README file. If I go into the bin location, this is where I've got a shell script. If I'm doing this on Linux, dependency-check.sh. And for Windows, I've got a dependency-check.bat file. But what I want to do is I want to run the dependency check from Linux. So I've navigated to a github.com site where I can get a version of the OWASP dependency check tool downloaded. Specifically here, it's version 7.1.0, and it's a zip file. So I'm going to go into the Linux command prompt and download that. Now, in a similar fashion, here in Linux, I can navigate, in this case, to GitHub, to a github.com page, where I can download a version of the dependency checking tool. In this case specifically, it's going to be version 7.1.0. So I'm going to go ahead and select that zip file to download it. I'll choose Save File and OK. So the download is completed. So if I go into, let's say, my Downloads folder for my current logged in user account, there's the dependency check zip file. So I'm going to go ahead and run unzip, and I'll specify that file name. So then I'll change directory into my unzipped folder for the dependency check tool, and I'll go into bin, and here we have the dependency-check sh. So if I were to run /dependency-check sh, well, we know that it's being recognized and that it's doing something. Okay, so I'm going to bring down or download an intentionally vulnerable web app, Matilde. It's the same one that's used on the Metasploitable 2 virtual machine. I'm going to do that by running sudo git clone. So I'm going to clone the repository, and I've got the URL for the Matilde app. And I'll press enter. The result, if I do an ls, is that I've got the Matilde folder here. So I've got my dependency check tool, and I'm going to check the project dependencies for Matilde. Okay, so I'm going to run ./dependency-check.sh. That's my shell script, -s for scan, and I'm going to point to ./Matilde. That's my project dependency I want to check, and I'll press enter. Now it says here that it needs a couple of CVE updates, so that might take a few minutes the first time I run this on this system. Once it's completed, it will have written the report to a specified location, in this case my Kali home user account under Downloads Dependency Check. So why don't we just navigate for that in the GUI here. So I'm going to go to File System, go to my Kali home user, location, Downloads, Dependency Check, bin, since that's where I was running this, and there's my dependency check report HTML. Let's open that up. So as I go further down, it's showing me any vulnerable dependencies for my application. So we've got some dependencies shown here on the left, and the packages that they come from, and the number of CVEs that are reflected from these. Remember, each CVE is a specific common vulnerability and exposure. So as I scroll further down through the report, I get the listings of those individual CVEs with an explanation of what the problem is, and of course some URL references for it. Now this is absolutely paramount for software developers, especially if you are inheriting a custom developed solution that you didn't write, and you want to be able to periodically check that there are no vulnerabilities associated with any of those project dependencies. Item A09 for the OWASP Top 10 2021 is all about security logging and monitoring failures. And if we were to dive into the details for that OWASP Top 10 item, one of the things in the description it references is logs that are only stored locally. And so one of the things that we have to consider, even though we're focusing on website application security, we have to think about the fact that we don't want logs for the host operating system or application container or web app components all stored just locally on the host. Because if that host is compromised, so are the logs. What we need is a way to forward log entries from a web app off to other hosts. And not just the web app, the underlying operating system and all of these supporting components that support that web app. And what we're going to focus on here is how to forward log entries from one Linux host to another. The idea is that we would have a protected, centralized logging host, perhaps on an internal network, that all other servers send their logging information to. So here on my Ubuntu Linux host, I'm going to configure this machine as being the one that receives log entries from other Linux hosts. So in other words, it will be the logging server. So what I need to do then is run sudo for elevated privileges, and I'm going to run the nano text editor against /etc/r syslog.conf. Now, because it's the first time I'm running sudo with elevated privileges, it wants me to verify the password for the user I'm currently logged in as. So I'm going to go ahead and enter that information. And here in the rsyslog.conf file, what I need to do is decide whether I want to use UDP or TCP as the transport for receiving log messages from other hosts. Now, normally UDP is used, so I'm going to remove the pound symbol, the hashtag, to uncomment the first line for module load IMUDP. And right below that, I'll do the same thing. I'll remove the hashtag to uncomment that line where we have input type equals IMUDP. And notice that the default port number that this centralized logging host will listen on is UDP port 514. Okay, so now that we've got that done, I'm going to press Control X. When it asks to save the modified buffer, I'll type in the letter Y for yes, and I'll press Enter to confirm I want to write to that file. So what I need to do now is I need to restart the syslog daemon, the service. So I can do that with sudo service r syslog restart. So I'm going to use the up arrow key to bring up that previous command and change restart to status so we can check on the status of the service. And indeed, it's active and running, and it doesn't appear that there are any errors. So excellent. It read the changes in the file. There are no syntax errors in the file. Everything looks good. We can even verify this by doing something like this. We might run sudo netstat. Now, the netstat command can be used to show the listening state of any services that are running on the host. And I'm going to add -nlp, where n is numeric, l means services that are in a listening state, and p meaning I want to see a program, because I'm going to pipe that to the Linux line filtering tool grep, and I want to look for our syslog. And when I press enter, sure enough, our syslog shows up as running UDP port 514. So what this means is we know that it's in a listening state, it's up and running on our server, it's ready to receive log entries from other hosts. So let's run ifconfig to see what this host's IP address is. It happens to be 192.168.4.95. Well, we're about to go to a different Linux host to configure it to forward log entries to this one. So we need to know this one's IP, and now we have it. Let's flip over to another Linux machine. So on a different Linux machine, I'm basically going to edit the same file that we edited on the first Linux host that serves as our logging host. That means I'm going to run sudo nano, so nano editor, /etc/r syslog.conf. It's going to ask me for the password for the user I'm logged in as. I'll enter that in. And what I want to do is really, I don't want to turn on the UDP listener because this server will not be the centralized logging host like the other one is. Instead, I'm going to go all the way down to the bottom. And that's because what I want to do is I want to add a new entry to tell this host, forward your log entries to our centralized logging server. Now, what I can do is something like this, ****. What does that mean? That means I want log entries from all sources, that's the first asterisk, ****, the second star means all types of entries. For example, look up above here. If we want to send only mail error messages, then we could specify mail.err, or mail informational messages from the mail facility on this host, we could use mail.info. And we could see all the way at the top that there are different sources like the cron scheduling daemon, or kern for kernel, or LPR for printing, or user-based items, user dot, whatever the case might be, whatever the priority is. So what I'm doing here is saying I want all log entries forwarded. Now you may or may not want that, but in this case, I know that I do. Then I'm going to put an @ symbol because I have to tell it where I want to send all of those log entries. In this case, 192.168.4.95. That was the IP of the other Linux host. Okay, so let's see what happens here. Control X to save. We're going to type in the letter Y to save the modified buffer. We're going to press enter to write this to the rsyslog.conf file. And we're going to have to restart the rsyslog service here on this host, just like we did in the other one. sudo service rsyslog restart. And let's just do the up arrow key thing and let's change restart to status just to make sure it started up okay and that there are no errors. So on this Linux host, once again, it's active and running. This is the rsyslog daemon for logging. There are no error messages, so I'll press Q for quit, and so far so good. How are we going to test this out? Well, we could just wait for log entries to be sent over, but we can force it using the Linux logger command. So logger, that type of logger. And in quotes, I'm going to specify test log message from, let's say, Kali Linux, close quote. So that logged message then should have been sent off to our centralized Linux logging host. Let's check our work here on that host. sudo cat, and cat shows me the entire contents of a text file like /var/log/syslog. Why don't we pipe that to grep and filter for something we know is in our test message like Kali? So if we do that, sure enough, we have our test log message from Kali Linux, which is now showing up on our centralized Linux logging host. So this can go a long way in helping harden your environment so that if, let's say, the Kali Linux host were compromised and its logs were tampered with, we still have a copy of log messages stored here on this host, which presumably would be hardened and on a protected network. Monitoring the performance of a web application is important because we want to make sure that users have the best possible experience. We want things to be quick, we want them to be reliable, stable, and we want them to be secure. So in the Microsoft Azure cloud, I've already deployed a web application, otherwise called an app service. What we can do is we can work with something called Application Insights to get detailed monitoring of the web app, down to breaking apart different types of HTTP transactions, including errors or failures, looking at things like web page response time, and so on. So here in the Microsoft Azure portal, in the left-hand navigator, I'm going to select App Services. This is going to show me any web applications as well as function apps and logic apps, some of which might be running, some of which might be stopped. Let's start by going into a web application itself. Now, when you're in the properties of the web application, down on the left under Settings, you'll have an option called Application Insights. If you click it, you can choose to enable it or disable it. Now, you also get this option when you're creating the resource, when you're creating the web application initially, but obviously you can change your mind at any point thereafter. Up above, we have a link to view the application insights data. So notice that the type of object we're looking at here is an app service, a web application in the Azure cloud. If I click View Application Insights Data, it takes me to an application insights type of resource. So it's a separate object or a separate type of resource in the Azure cloud. Now, immediately on the overview page, I've got an overview of some things like failed requests. It looks like there are none, at least within the last hour. That's the default time span. I've also got server response time that's being charted here in terms of measuring it in milliseconds. 1 millisecond is 1,000th of a second. It then calculates the average server response time is 12.38 milliseconds. Now, depending on the nature of the application and how many users are concurrently using it and what it's actually doing, will determine if that's an acceptable value or not. You can set a baseline over time by monitoring this and saying, yes, that is an average server response time when the application is performing well. So setting baselines is going to be important to determine if you have situations where things are unacceptable in terms of performance. Down below, number of server requests and the overall availability of the web application. Now, what's also informative is clicking Application Dashboard up at the top. So that gives me a dedicated dashboard for all of these different types of metrics. So the unique sessions and users, failed requests, server response time, some of these things we saw already on the overview page. Then an average page load time breakdown. Down below, any web browser exceptions for clients. The average CPU utilization for the web app, which is very low here, versus the amount of available memory in terms of an average. So again, to attach true meaning to these, you need to set a baseline of what is deemed as being normal when things are performing well for this particular application. Now, I can also double-click on a part of a graph to zoom into it. So now that takes me into performance. I could have clicked performance as well, and I'm still in the Application Insights resource, not in the web app, although this is related to that web app. So then I'm starting to get some details for the number of requests and the amount of time it took to service those requests in terms of milliseconds. Then the duration of requests to the web application. And down below, we have some tabular information that represents the same type of thing. In this case, for HTTP GET operations. I could also click failures on the left here and view failures in this way, so failed request counts. So depending on the activity for your web app will determine what you see here. But that's only application insights for a web application. Let's go ahead and click the X in the upper right to close this. And I'm going to discard any changes that I might have made to this dashboard. I don't want to save anything. And I'm going to go to my virtual machines view on the left and open up an existing virtual machine. Now the reason is because if you've manually deployed a VM, you might have an application running within there. Maybe you're hosting a manual web server instead of having it hosted in Azure. Maybe you just have custom code running in the VM, but you want to be able to track and monitor its performance and availability and the number of failures. So in the left-hand navigator, I'm going to scroll down under the monitoring section where on the left, I can click Insights. If I scroll down a little bit, I can choose to enable application insights for the virtual machine. We then get a message stating that Insights deployment is in progress. Okay, before too long, the deployment is complete. So if I were to go back into that virtual machine's properties and down on the left, under monitoring, choose Insights, once it's had time to gather some activity metrics from that virtual machine, it will be available here. So we can look at the map, we can look at performance, and we're already starting to get some details for the different disks within that virtual machine. The size, the space used, the IOPS for reading and writing, where IOPS stands for I/O operations per second, which is a measure of disk throughput. And as I scroll down, some CPU utilization information, available memory. And it's always important, once again, to establish what is normal when things are performing well. Set a baseline so that when you're looking at these things, you can determine if it's abnormal or if it's within acceptable parameters. If I go back to my app services view, besides web apps, we also have function and logic apps, both of which, if we go inside their details, we can scroll down and view application insights if it's been enabled for that particular, in this case, function app. We can view the application insights data. So it's a standard way to view detailed information for monitoring purposes for applications. And remember, we want to monitor our web apps, not just to optimize performance, but sometimes a performance spike can also be indicative of some kind of a security breach. Snort is a free and open source intrusion detection system, or an IDS. We've mentioned IDSs and the important role they play in securing a web application by monitoring activity and traffic, either at the network or the host level, looking for suspicious activity. So the idea then is that we can download and install the Snort IDS on a variety of platforms. So if I click Downloads, here we have a number of binaries available for different platforms. We've got an EXE for the Windows platform. We've also got a number of RPMs, Red Hat Package Manager type of installers for different platforms. We've even got the source code available if you want to compile it to work on a platform of your choosing. But if I go back here in my browser, I can also download rules. Now, Snort rules are statements of which you can organize many of them in a single rule file for things you want to look for. For example, over under rules, specifically under the community rules, we've got a Snort v3.0 community rules file. I'm going to go ahead and download that just for fun so we can take a look at the contents. So I'm going to go ahead and right-click and unzip that file. That will result in a tape archive or a .tar file, which again, I will go ahead and extract. And then it reveals a folder with the number of files. What we're interested in primarily is the Snort 3 community rules file. Let's go ahead and open that up and examine it. So we have a number of comments. Those comment lines begin with a hashtag symbol. Now, besides installing the Snort IDS tool and have it running on the platform of your choice, you can also load these rule files on that installation so the rule files will be read by the Snort engine. These rule files are updated periodically as there are new types of threats that emerge. For example, as I go further down, we've got an alert here that displays an alert message on the Snort tool about TCP traffic from the external network from any port going to a variable called $home_net, going to HTTP ports, where it's some kind of a web vulnerability scan attempt. As we go down through here, we can read the syntax for all the different types of attacks that get checked for by IDSs, including cross-site scripting attacks. Needless to say, this is an absolute goldmine of a tool that we absolutely must have running on the network, whether on-prem, in the cloud, whether it's a physical appliance, a virtual machine, software you install on a host, whatever the case is, there needs to be an intrusion detection system on the network where web servers reside. Now, I've switched over to Kali Linux, although it could be pretty much any distribution of Linux, but let's say I want to install Snort here. Here I could run sudo to run elevated commands, app, install, and then I'll tell it I want to install Snort. It wants the password for user Kali, which is also Kali. It asks, do you want to continue? I'll type in the letter Y and I'll press enter. So it then gives me a note about configuring Snort. I'll just press enter. It wants the address range for the local network. So let's say it's 192.168.74.0/24. If you don't know this information, talk to network admins who would know that. I'll just go ahead and tab to OK, and basically it's installing everything required to get Snort up and running. So here in Linux, I can also run snort -- version to ensure that Snort is installed, and of course, importantly, to see the version of the Snort engine. Here it's returning 2.9.15.1 with a specific build number. Ultimately, I can run Snort with snort -c for config file, which we know is in /etc/snort. It's called snort.conf. We can also specify -l, these are lowercase letters, for parameters for logging. Maybe I want this to go under var/log/snort. Now notice when I try to do that, I get an error. It gives me a permission denied when it tries to open the rules file under etc snort. Well, of course, that's going to be because I didn't run this with elevated privileges. So up arrow key to that command again, but at the beginning, we're going to prefix it with good old sudo to run this with elevated privileges. Now we're ready to rock and roll. So at this point, any alerts in our rule files would be displayed on this screen and ultimately logged to the location that we specified. So that means somebody has to be looking at this, or this has to be configured as a source for a SIEM centralized logging and monitoring system. In this demo, we're going to take a look at the configuration of the Snort IDS, the Snort Intrusion Detection System, and we're going to go ahead and configure a rule and verify that that rule gets reported. Specifically, we're going to create an ICMP, Internet Control Message Protocol rule. Things like ping and the traceroute command will use ICMP as their underlying transport mechanism, and they will trigger an alert rule to display on the Snort console and ultimately be logged. But first, what we're going to do is poke around a little bit in some of the Snort rule files here in Linux. And if you're a Linux command line person, grep is your friend. Grep is a line filter, and you can quickly sift through all of the Snort rule files looking for something specific to see if there's a rule related to cross-site scripting attacks or directory traversal attacks and so on. If I were to run sudo cat/etc/snort/snort.conf, the config file, and pipe that to more to stop after the first screenful, we'll be able to go through and take a peek at this configuration file for Snort. Really, what's important here is we have definitions for a number of variables like HomeNet for your home network versus Telnet servers versus SMTP servers and so on. And these can be used when you are writing Snort rules. Now also, if I were to run sudo, let's say ls/etc/snort/rules, we have a number of rule files. They all end with .rules. So community rule files, some that are specific to DNS, suspicious activity, or denial of service rules, or FDP rules, and so on. We've got a lot of rules here that we could work with, and they're automatically set to be used. For example, why don't we take a look at about exploit.rules? That sounds interesting. So if we were to run sudo cat/etc/snort/rules/exploit.rules, and we'll pipe that to more. And as we go down through this file, we have a lot of alert rules here that are going to display a message of some kinds, such as an exploit for Netscape or whatever the case might be. But what we can also do is run sudo, let's say, cat of /etc/snort/rules/*. And what I might do is grep that, or pipe it to grep the line filter, looking for XSS, cross-site scripting. So will Snort try to detect any kind of cross-site scripting attacks against our web app? Oh yes, we've got a lot of hits here where it's going to be looking even for that. Now, that's not to say that Snort is a web application firewall. It should be used in addition to a web application firewall, but it does look for a lot of these items. So the interesting thing here is you can check your rules for anything that you think might be of interest. If I looked for CSRF, cross-site request forgeries, nothing. If I were to look for other things like directory, traversal, and put that in quotes, yes, that does show up. We have a lot of hits. So the point is there's a lot of stuff that this is doing out of the box for you when it's running. Now, we've not yet started Snort, but we'll get there in a minute. But the first thing I want to do is actually open up. So I'm going to run sudo. I'm going to open up with the nano text editor /etc/snort/rules. And I want to open up the local.rules file. Here, I've already added a custom rule. So let's go to alert of any ICMP traffic from any network, any port, going to our home network, any port number. And the message will be testing ICMP. And I've got an ID here of 1,000,001, revision 1. Now, each of these specific components here is separated with a semicolon. The full colon separates an item like rev for revision against its value, in this case 1. And the class type here is an ICMP event. So that if I have any ICMP traffic, maybe traffic generated as a result of the ping command against this host or traceroute, then this will be triggered. And we'll test that out. Maybe we'll ping this Linux host to see that our testing ICMP rule actually shows up. At any rate, I'm going to press Control-X to get out of that file. So we've got that added. So you can add your own custom rules based on whatever you want to do. However, it means having a bit of an understanding of the syntax within the Snort rule file. So whenever you make a change to a rule file or the configuration of Snort in any way, you want to make sure that it's valid. So we could do that with sudo snort -T for test and -i eth0 because Snort has to listen on a network interface, and -c for the config file, which by default is /etc/snort/snort.conf. So I'm going to go ahead and press enter on that. And what we're looking for at the bottom is that Snort successfully validated the configuration. Excellent, we're ready to go. What that means is we're ready to start Snort. We could do that with sudo snort-a, capital A for alert to the console, -q, which means quiet mode, and finally -c for our config file of /etc/snort/snort.conf. So it'll automatically use our rule files. And right now it's in listening mode. So we're going to test this. I'm going to ping this Linux host from a Windows host to see if our testing ICMP rule gets triggered. So here from a Windows box, I'm just going to ping 192.168.4.108, which I know is the IP address of our Linux host. And sure enough, we're getting a reply back. Well, that tells me that it's not been firewalled to prevent that type of ICMP traffic, but let's go check our Linux console to see what's up. Sure enough, we have a lot of testing ICMP messages for each of the echo requests that was sent from our Windows ping command. Now notice we also have a couple of other rules that look like they have kicked in, such as universal plug and play or UPnP, some kind of scan or discovery attempt. And that might be normal for devices on your network if they're enabled for universal plug and play. So it's reading all of the rules from the files and displaying the alerts. In this demonstration, we're going to be taking a look at a Wireshark packet capture in order to identify suspicious network traffic. We're going to be doing this manually. Of course, it could be automated with an intrusion detection system. So what I've done here is I've gone to the itf.org site and searched up the request for comments, or the RFC, for DNS TXT records. Now we know that DNS, the domain name system, is a centralized lookup server where most commonly clients will query for a name seeking the IP address, because that's what they need to make the connection over the network. But this RFC is really focused on a TXT record. A TXT record, a text record in DNS, is really just a way to store some kind of arbitrary information in DNS, like a printer name. It could be anything. The format is that you have the attribute name followed by an equal sign and the attribute value. Now, what's interesting from a security perspective is that this is one way that infected computers know where the command and control server is. There are many different methods, but one method is that the attacker will infect a computer, usually by tricking a user to click on something or open a file, and they'll infect it with malware that is designed to go into DNS looking for a specific TXT record to find the URL of a command and control server to receive further instructions from. Now, this can be detected if you have enough infected computers that are going out to the same strange DNS. Now, this can be detected if you've got intrusion detection enabled correctly, if you've got computers performing frequent DNS TXT queries. That's not normal because it's very rarely used. Not only that, if machines afterwards that issued those DNS TXT queries are going out to the same strange URL, that's definitely an indication of infected computers on the inside. Okay, so here in Wireshark, I've got a packet capture where I know there is this type of activity that we've just described going on. I'm going to filter the traffic for DNS, and if I select one of these packets, we've got a DNS standard query going to 8.8.8.8. So first of all, is that a valid DNS server? From my Windows command line, I will run the nslookup command, name server lookup. I'm going to set the record type I want to query to PTR. A pointer record is a reverse lookup record. In other words, I already know the IP address. I'd like to retrieve a name to go along with it. And I get a non-authoritative answer, which means from a different DNS server that's referring this as being a DNS server for Google. Okay, that part's cool. That makes sense. So I'm just going to exit out of there. Back here in Wireshark, why don't we examine the packet header for that given packet a bit further? So we've got the standard Ethernet or hardware header with MAC address information for source and destination. We've got the IP header for IPv4 with a number of different fields, but of course, notably, the source and destination IPv4 addresses. So we've got a client with the given source address doing a DNS query to Google, and DNS client queries occur over UDP, the User Datagram Protocol, where the destination port on the DNS server is UDP port 53. Okay, let's take a look at the query itself. So it's a standard query. Well, within the domain name query header, if we go into queries, wait a minute. The DNS record type being queried here is a TXT record for what looks to be a strange, unrecognizable URL. Why would the computer, the source computer shown up here by IP address, be doing this? Is that normal or is it not? Maybe it's normal for your environment. Remember, when you do security incident reporting and tweak your intrusion detection sensors, it is unique to each organization, to each network, to each host, to each app. You have to be very careful how it's configured. Now, let's assume that there is nothing that we run in our environment, we know this, that does DNS-TXT queries. And we certainly don't recognize that URL. So does that sound suspicious? Yeah, it does. The great news is that I can go to virustotal.com. This is a free online service where I can do things like provide what I think are infected files, or packet captures that have suspicious activity, even suspicious URLs, and it will tell me if in the general worldwide community this is known to be malicious. So I'm going to go to virustotal.com where I want to upload a file. And what I've done is specified the packet capture file that we just looked at, and it automatically flips me over to this results page where it looks like from a Snort detection utility perspective, it's detected 2 alerts, and we can click on it to see what's going on. What does it think is an alert here? Scroll down. Immediately, commands over DNS text queries and responses. Now, This is known not to be normal for a client DNS query activity. And as we go further and further down, we have a list of the DNS requests from that packet capture. So it takes that packet capture and analyzes it and presents it in this nice, easy to digest format. So we see miscellaneous activity. We also see the attempted user privilege gain. So it looks like a specific type of firewall client exploit. So it's safe to say then that we've got some serious problems occurring here as a result of this capture. And if we click on community, we might even get some details related to what other analysis results have determined to be similar. And if I go back under details on the left, let's say, and if we scroll all the way down, let's say under Suricata alerts, then if I go into a network Trojan was detected here, it's giving me some more details. It's pointing me in the same direction that we originally thought via the packet capture, that we've got some kind of a Trojan piece of malware on the inside that's going out to Google DNS servers, retrieving information via TXT record queries, which is usually going to be used so that the infected client knows who or where the command and control server is. So there is value then in simple packet captures. You might schedule them to occur randomly, and you might also make sure they run for a long period of time, save the packet capture files, and immediately the quickest thing to do is just upload it to an online service like this as opposed to trying to pour through it manually. Because you never know what kind of indicators of compromise might result from that activity. Nmap is a free network scanning tool. Not only can you scan a network to see which hosts are alive, or in other words, up and running, but you can also scan each alive host to see which services are running. So in other words, you can conduct a port scan. You can run one machine, you could run a port scan on every discovered device on an entire subnet if you so choose. But the thing about this is it's considered to be very loud. In other words, it's pretty easy to set up intrusion detection sensors that will detect that port scanning is taking place. Now, there are various ways that port scanning can be executed. We're going to take a look at some of those methods here using Nmap. So I've navigated in my web browser to nmap.org. So this is where you can go to get this free download. It's been here for a very long time, and it persists to this day as being a very important tool in the toolbox of network security specialists. And we know that network security directly translates to web application security. Now, when you go to the download part of the Nmap page, you can download it for a variety of platforms. So Windows, the Mac OS, Linux, and other OSs. You have the source code that you can compile yourself if you feel so inclined. Here on the Windows platform, I've downloaded and installed Nmap. So if I were to issue the Nmap command here, of course, we get back some help about the parameters. So we know that Nmap is installed. Whether we're running this on Linux or the Mac OS or Windows, the syntax remains pretty much the same. So for example, I'm going to type nmap, and I'm going to specify an IP address, 192.168.4.1. I want to scan that host, and I'm going to use a -v to do a verbose scan. So first thing that we can see is that it is scanning the host and discovering a number of open ports, like TCP53 for DNS. Notice that's on TCP and not UDP. UDP53 is usually for client DNS queries. TCP53 is for DNS servers to talk to each other, usually for zone transfers. TCP port 80, which implies that we've got a web server stack running on that host. And then we get the summary down below of the ports, the state being open, and the service, such as universal plug and play, and so on. We also get the 48-bit hardware or physical MAC address shown here. Let's clear the screen. Let's do another scan. So maybe what I'm doing here is I want to scan the network for web servers. So Nmap, I want to scan 192.168.4.1 through to .254, so all IPs on that subnet -p for port 80. You can also scan for 443, so 80, 443. I'm looking for web servers. Okay, so after a moment, we get some output here about the hosts that were scanned and whether or not we've got closed, filtered, or what we're looking for is open states for either HTTPS on port 443. So we'll have the MAC address, we'll have the IP address of that given host. Here we've got another one with TCP port 80 open. This is part of the reconnaissance that a malicious actor might begin with to discover which hosts are active on a network and which are running web server stacks. The next thing I'm going to do is do some OS fingerprinting to zoom into one of those web servers where I know a web server stack is running. I'm curious now about the OS, because depending on the OS and the version and how it's configured, there might be vulnerabilities there. Nmap, in this case 192.168.4.196, was one of the web servers that we saw. --O for OS fingerprinting. Now, depending on how firewall the device is, will determine whether or not we get any output. Let's try another one that came in that output. This one gives us much more detail. So we know it's got a number of ports open, and we know it's running Linux 2.6.x. It's one hop away, which means it's on the same network, which we kind of knew already since we're on the network performing a scan. Now, we're only beginning to scratch the surface of what Nmap is capable of doing, but this gives us a sense of how it can be used to perform network mapping. But from the Start menu, I also noticed that I have an Nmap Zenmap GUI tool. I'm going to go ahead and click on that. So besides using the Nmap command line tool, we also have this front-end GUI where we can specify a target and the type of scan that we'd like to perform. For example, I might put in a scan range of 192.168.4.1 through to 254 if I want to scan that subnet. So I'm going to go ahead and perform an intent scan, and notice that it's generated the command line parameters down below as if I were to enter this at the command line. It is using that in the background, but it shows us that here based on our selections. So I'm going to go ahead and click Scan. Okay, so under the Nmap Output tab, the output will tell us that Nmap is done and how many IP addresses it scanned, how many hosts are up, how long it took, and so on. We could scroll back up through the Nmap output to see what it was discovering. We could just go to ports and hosts here. Here what we have is a list of all the different ports it discovered, like port 53, 80, and so on. And if I were to start selecting the host that was discovered on the left, the ports and host will change. So some of these are running a variety of different port numbers, like port 80 for a web server. Some are not running anything, at least anything that could be discovered. Some are Windows hosts, where we have a lot of standard Windows ports, like 135, 139, 445, for things like shared folder access. Now remember that Nmap is a network scanner. It is not a vulnerability assessment tool, but it's the first step in discovering what's on a network and what services are running on a given host. You could always go to host details to get details such as the MAC address, the operating system details if they were discoverable, among many other details. And of course, you can go to the scan menu and you can save this scan so that in the future, you might take some time to open up and go through the scan or have automated scripts that look for something in particular. And you can also go to the Tools menu and compare current scan results with past scan results to see what's different, such as a new host that is now on the network, or maybe one that is no longer up and running, or maybe for an existing host in both scans, maybe a new service was added. That kind of thing you would be able to see by comparing results. A cross-site request forgery, or a CSRF attack, is one where the attacker essentially injects themselves between the communication of an authenticated web client and a web app. So let's say a web browser has been authenticated to an online banking session, and the attacker has somehow compromised the victim's machine or has otherwise tricked them into clicking something that gives the attacker access to things like web browser cookies for that user authenticated session. It means that the attacker then could make changes to requests sent by the authenticated user to the web app. Because the user is already authenticated, as long as there's a valid session identifier, the server will accept it as if the user had legitimately sent that request. And so let's take a look at that here in the Metasploitable 2 virtual machine, where we have a form that allows you to change your admin password. You can specify and confirm a new password. In the bottom left, we see here that we're logged in as username admin. So if I go through and submit a new password change, so I'm going to go ahead and change the password and I'll confirm it. When I click change, what's important is that we take note of the URL up at the top. So we've got our host IP address, DVWA, vulnerability, CSRF, and so on. But then we've got parameters like password_new equals, the new password I set is 2, TWO. And the password confirm equals 2 and change equals change hashtag. Wow. Okay. Well, if that's passed in the URL, an attacker would need to know that. They need to know what the web app expects in terms of the names of these items like password_new, password_conf. But not only that, the attacker needs you guessed it, they need something like a session ID in order for that to be allowed. They need this cookie information in addition to that URL string. Not to mention that all of this is happening over HTTP, not even HTTPS. And so it's completely visible. So how do we put this all together? Well, let me go ahead in my Start menu and pop up the Burp Suite Community Edition tool. Burp Suite is a tool, kind of like OWASP Zap. I could have used the Zap tool as well, but it allows you to act as an interception proxy. You'll see what I mean. So temporary project, that's fine. Next, Burp defaults. Yep, we'll accept all of those items and get it up and running. Because what I want to do here is I want to go to the proxy tab, make sure intercept is on, and I want to start Burp's embedded browser, which will automatically proxy through this tool instead of me having to manually configure my web browser to proxy through it. So I'll click Open Browser. It opens up a little web browser, and that's just lovely. So let's go to our little test web page. Now, when I do that, it automatically flips me over into the Burp Suite because Burp Suite basically stops it in its tracks before forwarding it off to the web server. So I'm going to go ahead and click Forward. Okay, let's go back to the Burp Suite browser. So I'm going to log in as admin with the newly changed password of 2 TWO, and I'll log in. And again, Burp Suite captured that, so I'll just continue on through that. Okay, so we are signed in here, and if I just check the DVWA security, and continue through that in the Burp Suite tool, we're going to set the security to low. So I'm going to submit that. And again, Burp is capturing all of these, so I'll have to forward through that to continue the request to be allowed to go from the client to the server. Now I'm going to go to CSRF over on the left, and in Burp, it's picking up what we're doing. So that's fine, forward. Now this is where we wanted to be, because what I want to do is specify a new password. Okay, so I'm specifying a new password. Got it. And I'm going to click Change. And let's see what we get in Burp Suite. So we can see it's an HTTP GET type of request. And the password here, well, it's not encrypted or anything, so it's just the value of 3. We're missing, well, actually, it looks like what we've got here is cookie information. So let's say that the attacker decides, well, I've managed to capture this information between the client web browser and the web server. I'm going to change the password to 4. So the user officially thinks that they're sending a password change with the value of 3 when we are changing it here to 4. We've got the cookie information down below, cookie : security equals low. There's the PHP session ID. Now we're going to continue this on its way. We're going to send it to the server by clicking the forward button. So what we've just done is manipulated a transmission for an authenticated client session to change something that benefits us, in our case just a password change, that is unknown to the victim. And so I'm going to go back to my regular web browser where I'm going to log out, and we're going to try to log in here to see if it picked up our new password change. I'm going to put in the password that the user request originally included, and I'm going to log in. Or not. It says login failed. Well, remember, the user thought they were changing the password to... In this demonstration, I'm going to be executing a denial of service or a DOS attack against a web server. Now, even though this is very easy to do in this day and age with so many freely available tools and tutorials out there on how to do it, resist the temptation to apply this against web servers that you do not own or that you don't have express written consent to do it to. You're crossing the line by doing this. So essentially what denial of service really means is that we are rendering legitimate use of a web server and ultimately its apps that it is hosting. We're rendering that useless because perhaps we're flooding the server with useless traffic and it's so busy doing that it can't service real legitimate requests. Now, not all denial of service attacks occur over a network. Simply unplugging the power to a server in a server room would be considered a denial of service attack. So the first thing we'll do here in Kali Linux, I fired up a web browser and I've entered in the IP address of a web application. This is the Metasploitable 2 virtual machine. It's up and running. We can click on these links. We can navigate through the site. Everything is working perfectly. Well, what we're going to do is we're going to essentially make that host unreachable by initiating a denial of service attack. What I'm going to do here is switch over to a command prompt in Kali Linux, and I'm going to run MSF console. MSF stands for Metasploit Framework. This is a security penetration testing tool that happens to be included automatically with Kali Linux, where there are numerous exploits that are available, and we can even customize them and add our own payloads to those exploits and send them off to a target to observe the behavior. And of course, this is one of those tools that can be used by security specialists that are responsible, but at the same time, it can also be used by malicious users. And that's why we're focusing on this. Even if our focus is simply a single web application, we're a developer and we've got to harden the web app, that's fine. Hardening a web app is important with secure coding and validation and sanitization and all that stuff. But all of that means nothing if you haven't taken protective steps to protect the web server on the network from things like denial of service attacks. Some of them are very difficult to mitigate against. Usually there's a combination of solutions like throttling to look at abnormal excessive network traffic being sent to an app if it's a network-based DOS attack, or black hole routing to discard suspicious network traffic so it doesn't go anywhere. On the physical side, of course, keeping servers in locked server rooms. Maybe rack mount servers are on a rack that is locked. All right then, so let's proceed with this. I'm going to search for an exploit called Slow Loris. Now this I happen to know is an HTTP type of denial of service or DOS attack. And the way that it works when you're using Metasploit is when you want to work with a particular exploit or use it, you literally have to use the use command, as in use, in this case, dos/http/slow loris, as it's listed up above. I'll press enter and my command prompt changes to reflect that. Now, if I type in show info, that will be in the context of the currently selected or the currently used exploit. If you read the description, this is a classic HTTP denial of service attack where we send a bunch of half-open connections to the server, but we never complete the connection. And so the server gets flooded very quickly trying to service all of these half-open connections. But if I scroll a little back up through that output, we also have a number of options available, such as rhost for remote host, and the current setting column reflects that nothing is set. The rport, the remote port, well, that has a default setting of port 80, although of course we can change it. Whether or not we want to use SSL connectivity, the number of sockets. There are a number of things that you can do to mitigate server-side request forgeries or SSRFs. Now, all of the standard stuff would apply, like basic hardening of the network, so network access control, limiting who can get on the network in the first place, having not only perimeter firewalls with the appropriate firewall rules, but every device on a network being firewalled, all firmware and software having the latest patches applied, default settings changed, unused accounts and services disabled, and of course, when it comes to building a web app, developers must adhere to secure coding guidelines and do all the stuff that we know about, like validate input to make sure that what was input is what was expected, sanitize the input to remove any special characters that don't need to be there, enable strong authentication, ideally beyond just username and password. Now, the nature of some web apps, or at least some parts of a web app, might be that anonymous access should be allowed, and that's fine. But for more sensitive information supported by a web app, strong authentication, ideally through MFA and client-side PKI certificates, should be used. So let's examine a couple of specific things we might do on the web server stack. We're going to do it here in Windows with the IIS web server. So on my Windows server, I've already got IIS installed. So from the Start menu, I'm going to drill down under Windows Administrative Tools, and naturally, I'm going to choose Internet Information Services, of course, IIS. Now, the first thing to bear in mind is that if I select my server in the left-hand navigator, I've got some global types of settings that I can configure, such as authentication. Currently, anonymous authentication is enabled, and that might be just fine and dandy. It might be appropriate for all of the apps hosted on this server. Otherwise, we could choose to disable it. We've got a disable button over on the far right. If I click on the server again in the left-hand navigator, we've then got things we can do like enable or disable directory browsing. And again, it depends on the nature of the app. If you kind of want to treat this as a file repository, but you don't want web pages where you generate links all the time as files change, or you don't have a script that does that, maybe it's appropriate for publicly viewable files to have directory browsing enabled. You just want to scope it out. For every web app, should that be enabled? Usually not, especially if you're hosting multiple web apps on a single web server host. So we could choose just to disable it over here on the right. And then we have a message here stating that directory browsing has been disabled. We also have things like HTTP logging options, so the format for the logging, what we want to log, where the logs will be stored. Remember that we always want to have log files copied somewhere else or forwarded somewhere else for safekeeping, in case this server itself becomes compromised.